So good morning, everyone. I think in the paucity of time, we will start. Those who join us later can do so. I quickly want to introduce the Zak World of Façades conference series to you. My name is Ahmed. I'm part of the organizing team over here. We have been organizing this Zak World of Façades conference series from 2012. We did our second edition in Ahmedabad on the 12th of October 2012, and we're back here after 9 years. But in that 9 years, we've had a great journey. We've completed around 117 editions in 35 countries around the globe, and poised to touch around 135 editions in 41 countries by end of this year. So the conference is, as you all are aware, on facade design and engineering. So we've got topics which are interesting, which are different, which are new to the Indian market, especially to Ahmedabad. Ahmedabad is now one of the fastest growing Indian cities. I think in 2012 when we did the event, that was for Gift City predominantly, which was then announced, and there was a boom of glass facade buildings which were announced. I think now Ahmedabad is evolving as a major metropolis in India. So that's why we've got the theme as a transformative facades for a evolving metropolis. So I'll quickly introduce our event partners without whom this event wouldn't have been possible before we get into talks today. So our presenting partner is Schüco. So Schüco is a German manufacturer, the world leader in aluminium door, window, curtain wall systems. So they are the presenting partners of our event. They've been the backbone of this conference series throughout the globe. Glass wall systems are powered by partners. They are a leading facade contractor based out of Mumbai doing pan-India projects. Our premier partner is Alstom. Alstom is one of the leading metal composite panel manufacturers in India. And then we have our associate partners, CS Specialities, which manufactures louvers. They are represented with their local distributor, Diamond Engineering. Fundamax, Austrian manufacturer of high-pressure laminate cladding for facades. HiFab is one of the leading aluminium door, window, curtain wall fabricator here based in the state of Gujarat. IPH Glasses is one of the leading value-added glass processors based out of Gujarat. Kinlong is a Chinese manufacturer of glass hardware, fittings, tools, accessories, you name it. They've got LED, they've got a lot of other products here, one of the more popular brands and a long-standing supporter of the Zak World of Façades conference series. Osaka Rubber is a manufacturer of EPDM gaskets and sealing solutions for doors, windows and facades. Ozone is an Indian manufacturer of glass hardware, fittings, tools, accessories. Serge Ferrari is a French manufacturer. They have fabrics which can be used in lightweight architecture, especially for roofs and facades. Siderise is a British manufacturer of cavity barriers and pacifier protection products for ventilated facades and curtain wall. They are represented in India along with their partner Allarc. Stone Lam is the Indian representative of Laminam. They have a very interesting non-combustible cladding product. It's an Italian product which is a porcelain-based cladding. Viva is one of India's largest aluminium composite panel manufacturers. They have also been a great supporter of this conference series. Wienerberger is an Austrian manufacturer. They've got terracotta and brick which can be used for cladding. They are represented along with their local distributor, Diamond Engineering. And then our next few events in the series. So we have a break. So we've been doing events non-stop. We've done 10 events in 10 countries since the 9th of February this year. So it's been 10 events on the row. So we have a month's break, and our next event is in Birmingham in the United Kingdom. We've got one in Canada, in Vancouver the following week. We've got San Francisco. We come back to India then. We've got Chennai. We've got Cairo in Egypt. We've got Milan in Italy. We've got another Indian edition in Hyderabad. We've got Hong Kong. We've got Shanghai. And of course, these are our pending 3 events in India, which is Chennai, Hyderabad and Mumbai on 2nd of June, 7th of July and 5th of October. So this is what we've been doing with the conference series globally. what has happened in the past few years is facades have become complex. They are no more your glass boxes. They've become into different shapes, complex geometries, new materials, and then in the last few years, especially from the beginning of the pandemic, I think a lot of Western world countries have acknowledged that climate change is the next big thing which is going to affect our world, and you need to reduce carbon through buildings. Carbon emissions, buildings are one of the largest emitters of carbon. So they've started looking at carbon emission reduction through buildings, through better materials, through better design, through better techniques. So that's become a trend globally, but in India we've still got a long way to take care of our operational carbon, but that's something which is a factor. So all this has led to the growth of the event. You see, we started off in a very humble way in India in 2012, and now being an Indian organizer, we've been able to organize this event across the globe. That's because there's so much to talk on facades. There are several events on structural engineering, on interiors, on other architectural elements, but there's not any event dedicated to facades. So we were able to come into that domain. And the agenda today is a reflection of that. You'll see that there's a lot on the agenda, so it's a good solid full day, but you've got a lot of things. You've got, in cladding itself, you've got 3-4 different materials which are being presented. Then you've got options on low carbon design, on facade quality, on management, on net zero. So there's lots to talk, and everything is related to the building envelope, to the facade. So you will realize that at the end of the day that it's not your simple just glass and aluminium. There's much more than that which needs to be taken care of. And that's why a forum like this is important. All our sponsors have their booths outside. I urge you to please meet them in the networking breaks and interact with them, so that they can also present their solutions to you, which could be useful in your upcoming project. I'm more or less done with my talk. Before I introduce our event host for the day, just a couple of things more. We've recorded this event, so by a week from now, we will send across the YouTube link of the presentations we are allowed to share with you guys. So we will send that across. We won't take any Q&As. If you have any questions, you can ask the speakers in the networking break. So we'll have all out our presentations only. As I mentioned, our manufacturers have booth outside. So if you have any questions from our manufacturers, if you want to see the product samples or anything like that, you can visit their booths outside and network with them. Those who have the red lanyard with the delegate written, there's a USB stick on your lanyard. That USB stick has the brochure of all the sponsor partners of the event. So the USB stick has the brochures, and a week from now, we'll send the YouTube link, which has the recording of today's event. So that's it from me. I'd like to call upon our event host. He's the next generation. I'd like to call upon Mr. Nimit Vora from Hi-Fab Aluminium. He's doing it for the first time, so excuse if he makes a couple of mistakes. I was like this 10 years ago, but I think the future for us should be promoted, and I think it's great that Nimit accepted our invitation. So Nimit will be hosting today's event. He'll be introducing our speakers. He'll hope to keep them in check if they don't go over time, and steer you through the day. So my role ends here. I'd like to call upon Mr. Nimit Vora from Hi-Fab Aluminium on stage, please.
So good morning, everyone. Hope you all have had a great breakfast, and I hope none of you yawn in the whole event. So thank you, Ahmed, for setting up the tone for the event. First of all, my name is Nimit Vora, and I am the director of the Window Factory. Ahmed has already given a small brief about me. So first, I would like to introduce Mr. Jayesh Hariyani from INI Design Studio. He is the CMD and senior principal. So please come on the stage.
Is this on? Yeah, wonderful. Good morning. First of all, thank you, Zak, for creating this platform and sharing this platform with Ahmedabad, Gujarat. Thanks, Ahmed and the entire Zak team for putting out wonderful events, such knowledge-solving platforms for all of us. Nimit, doing well. Don't worry. It's always first time for all of us, so you'll do good. Thank you all of the sponsors. Without support and your sponsorship, this would not have been possible. And all my colleague eminent speakers will be sharing a lot of learnings with all of you. So thank you for all of your efforts. And finally, but not least, all of my colleagues and fellow industry members. Like to just understand who all are here so that I can steer myself properly. Who are here who represent the design side of the industry? Only one architect, two architect, facade designers, engineers, architects? What we are, okay. You think we... then the representative of industry, manufacturers, suppliers, please raise your hands. Few of them. Wonderful. Developers, few of them. Thank you. Anyone whom I missed? Wonderful. So it's a good mix of the colleagues here who share the platform and projects that we do here. So today I organized my presentation, start with net zero, understanding in terms of what net zero means to us for our industry quickly, and then shift the gear. It's a facade that is the subject matter for the entire day, but I have organized a bit little differently. Facade will be there, but it's not upfront. There's a lot of other things that play in when we talk facade, so I have tried to cover those things, okay? वो clicker कहाँ गया? Oh, right here. I think many of you know about us, but still I take the opportunity to just spend a minute to introduce us. I Design Studio. A quick snapshot. We started India operation as Burt Hill. Then we merged with another large consulting firm, Design Engineering, Stantec, with a global presence, 400 plus locations. And we restructured ourselves in India, South Asia, the same practice as I. We reintroduced that. So we still represent the legacy and brands of all these three. In India, we started 2007, currently 250 plus in India, many locations, and the position that we have is we have all of the in-house expertise in most of the built-in industry, service industry. This is the map of I brand, our projects and offices. Sectors, I think most of the built environment has to do whether it's one sector or the other, we have expertise to offer. And the numbers are just speaking for South Asia, India work. that we have delivered in last about 14, 15 years. Now, whatever we do, whether it's design, engineering, everything needs to be driven by values that we really believe in. And when you have a large practice with multi-location, the values have to drive your work, whether it's a small detail of a project, a facade, or entire design concept, has to be driven by the values that you believe in. So these are the values that really we practice. And I will demonstrate how this really percolates into our work. Now, once you have the values, you have the same foundation. And the way we do this is process the entire values as part of the collaborative working as a team. And there's a wonderful publication that talks about our collaborative process, published, available globally. I would encourage you to check it out. Designing for Modern India showcases the collaborative process. Straight into the topic, net zero carbon. Last many years, we talked about sustainability, green. I think all of us have heard that term quite often. Now it's similar way, a step up, net zero, right? Now, I'll just quickly go through the net zero, wonderful research that explains it. But first, setting context, that we are, as a country, 110th number in terms of our carbon footprint per capita. And then we say, why we need to worry about it, right? When there are so many above us. And you can see top 15 and few others. We are 100 down the line in 110th with 1.7 tons per capita per year. When we equate to that, 83 mature trees equivalent, right? So still a lot. And if we don't really start thinking about it now, we will get there very fast. So putting that in context. Now when we talk the carbon emissions, everything is evolving globally, right? The definitions, what's included, what's not included, what would be overall process, what would be the model, how we will certify and what not. Everybody's in the same boat. But when we talk carbon, just understanding whole life carbon, WLC, one is embodied carbon, the other is operational carbon, right? I mean, everybody probably, I would imagine, understands embodied carbon, correct? And when we talk the embodied carbon, what materials or elements are included currently in the industry globally? There is a lot of debate that is ongoing. But in a nutshell, include everything that is in the cost plan of your front end, capital cost, right? Simplifying that way. I won't go through the lot of number, but just the concept. When we say whole life carbon, upfront carbon, which is raw material supply, transport, manufacturing, transport, site works. Number A, just notice this A, B, C, D because I'll be talking in the next 10 slide and it relates to that. B is use stage embodied carbon. Means when building or a project is in use, everything that has to do with it. And end of life carbon, which is deconstruction and how we really process, transport the waste and disposal. And the last is reuse and recovery. So that's the concept of whole life carbon. Then when we slice those things down, breakdown of the carbon emissions in terms of upfront. Facade is right there, significant portion of the pie. When we do the whole chart the other way, in terms of a proportion of whole life carbon, operational cost, significant, upfront and during use. And facade contributes to all of them significantly, that we will just quickly see. So you can see superstructure is about 56, facade is part of that. And you can see the numbers or the pie chart includes B6, B7, and D, the previous slide that I talked about. This is a wonderful data that we participate or with Haroop University. And there's a lot of data that you can go and check it out. The website is down the line. So emissions in terms of our industry, about 32%. Other sectors are also listed. When we break that down in terms of our industry, the 32% into current operational and embodied, 76% is operational. So any decision we make in front end has a huge impact on the overall carbon emission during the life. Product manufacturing in the facade side. You can see the pie chart in terms of the contribution of emissions in the industry. EC3 tool, check it out. It's free online if you are interested in really understanding how to help and minimize your carbon emission while you are designing. So there is a wonderful tool. The website is out there, and it really drills down the element by element. Talking about facade, this data is glass, this is glass plus, okay? Now, glass products, different type of glass products, and glass transformation, treatment. Here, everything else with glass, when we try to push numbers by recycling of aluminum and so forth, still you can see how it impacts to the carbon emission. So this research, 16 different facade typologies were modeled and studied in terms of their performance and emissions, right? Just focus on concept. Don't go in the details because there's a lot to process. Just let's look at the concept. So type of DGUs, whether it's curtain wall, whether it's stick system, whether it's a veneer system, and so forth. So various 16 types of typologies were processed as part of this. Again, the WWR window wall ratios and relevant other factors such as shading, materiality, and so forth were part of this entire research and modeling. A lot of number, but just see the glazing and system performance. All were laid down up front for all 16 models. For each model, so that's really this is A2 typology. The embodied carbon, 180 kg, during A1 to A3. And during A1, A5, all the way to C, 240. Right? A pie chart. So each system, each typology was modeled in terms of its emission, embodied as well as whole life. Right? And then all of them were laid down side by side, all 16 facade typologies in terms of their emission, you can see, and broken by the front end, in use, operational, and so forth. Similarly, by material, right? Whether glass, aluminum, what's impact on each of the facade typology in terms of when we design and so forth. Then external shadings such as fins, whether it's vertical, horizontal, window wall ratio, east, south orientation, and so forth, and how it impacts in terms of when you vary the ratio of window wall from 50 to 80, what does it do in terms of a overall embodied and operational carbon. Solar control types, whether internal blinds, external coatings, and so forth, were also model part of this. And percent of glass to other materials were mapped in terms of emission. And by components. This is important, that which material embodies more carbon during the entire life cycle, upfront, in use, and after, right? So you can see, for example, aluminum, about highest, right? All of the glass put together also adds a lot of it. I'm done with numbers, too many numbers. I hope you get the concept in general, but the bottom line of all these numbers is facade is a significant contributor in terms of emission, embodied as well as whole life cycle, right? And depending on what type of a facade you have, the variation could be 26 to 60%, huge variation, so it's good to think it through, what we are doing with our facade, right? And some of the observation, variation in design can significantly impact the whole life carbon. We must embrace the complexity because a lot of new systems, lot of technologies are being introduced day and day. We better understand those before we start using them. Material selection shows itself that each one has a huge carbon footprint, which one we select and why. And understand the trade-offs in systems and in our design decisions that impact, and all other aspects that go in. So that's the first spell of my presentation. But as an architect and as a colleagues, we don't need to really dwell into lot of numbers and analysis. Few things you can just say, this is right and makes sense, and this is, we don't know, needs analysis, right? So some things you can just screen very fast based on your basic understanding. So now, keeping it simple, passive, right? Let's not worry about numbers, because there are many things we can do with passive which don't have to even do a lot of number crunching. And that's where we have really worked hard in terms of our process, design process. We call it design drivers that help us our decision making. And that's true for facade also. And we call it design drivers or 10 metrics, which has become our common language when we design. There is another book published on our 10 metrics design process available. Check it out. So, matrix 1, or a driver 1, we call it, integration. Fostering collaboration between all discipline systems as a unified whole. So, yes, this particular today, we are talking about facade, but there's always opportunities that you can look for before you jump into your facade design or a decisions, and I'll demonstrate very quickly how, right? See building and a facade as a part of interconnected urban system, right? There are models in terms of a density, in terms of orientation, in terms of tall to mid-rise to high-rise, in terms of a planning, that any decision within a cluster or a neighborhood or within a campus, if you are orienting your building and densities, it has a tremendous impact on overall planning and carbon emission of the development. And I'll show you how. So this is a project, Rajkot Smart City, entire new city that we have been working as part of a smart city mission, where we have to put the bylaws which are more progressive. Heights, building envelope, we have to define the FSI usage and what it does in terms of overall FSI and density consumption, and allowing the codes which are progressive that allows the freedom for design but also creates a wonderful overall care of the heat island and other measures. So as an envelope or a facade, when you are creating a building mass, outdoor comfort, daylight, energy efficiency, views, all these matters, right? So if you are designing, let's say, a cluster of a building, thinking about this before you jump into facade is very, very critical. And in this particular planning, we define the build to line differently, introduction of urban colonnades, the plazas, whether it's corner or BRTS, because that all defines the envelope and the facade itself, podiums and the green areas. And you can see how they are located in the overall master plan. So we define the guidelines on the colonnades, how they impact on the overall architecture and the facade and the overall shaded environment, right? Same way, the urban environment, the plazas, so that it impacts the overall facade and the overall architecture of it. We define those BRT plazas so that you create a wonderful envelope and a pause between the urban system. Podiums contribute a lot to the facade. Greenways and so forth. Last but not least, the overall green integration. How on a facade and the overall build site, you can enhance your green footprints. So we have created a regulation where each building will have to come up with 50% of a green area. So that's the integration. As a driver, second driver is humanism, right? Sensibility for people, planet, lives in a collaborative philosophy. So, valuing the humanism, આપણે ગુજરાતીમાં કહે ને માનવતા રાખો, right? દરેક વસ્તુમાં એપ્લાય થાય છે, ફસાડમાં થાય છે. So more sensitive we are in terms of a passive strategies before we start talking about facade is very, very critical. So this is the project Aga Khan Estate in Mumbai that we worked on in the front-end design delivery. And as part of our humanism driver, we started looking at the Ismaili community. Learn about client, learn about their society, cultural values, and so forth, and what drives them, what doesn't drive them, and so forth. And part of that, we learned there is a significance description on jalis and geometries in their culture and their architecture. So we started looking all those, and there is an underlying human story and philosophy to it that talks about journey, progress from Siyarat to Hakikat, life journey, right? So that's what we learned, and we created the facade jali systems layered with it that really becomes part of our overall design strategy. Some of the early sketches in terms of a passive strategy and how we will introduce their philosophy in terms of a jali. We did a lot of these studies and layered system in terms of a journey of life, which is layered and blended between other lives. So that's what we looked at it in an abstract way, and some of the final renderings you can see. Part of this, it's a high-rise, about 55-story plus, and we created these consciously terraced verandas and connection of a sky and green as part of the strategy, and the sea view is towards this way. So created this wonderful terraced stepped penthouses, and you can see the application of movable jalis and screens layered in overall design concept. And the other thing that they do a lot is wadi. So landscape in a way that is out of their cultural values. So we created a wadi there. Volume nahi aa raha hai. Driver 3, design excellence. Keep setting yourself for a higher bar, right? Keep pushing. Don't just stop at one option. Keep exploring till you feel that no, you have arrived, right? And still it's ongoing process. So this is a project ICT for a ITC in Bangalore. Our scope was create their main office building within their campus, which is about 50 acres. And we just did not start that this is our scope and this is the building tower that we have to build. We looked at the entire context, did the analysis in terms of our impact on the towers or the future towers in terms of a thermal sensation and the other microclimate. So that's where we started in terms of our exercise. Once you understand the overall context in terms of what it has to offer, that's where the first major impact you can do. Harness the context and the surrounding and the local nuances that offer a lot. Then we started positioning the tower in terms of morphing the overall mass and how we will create a passive strategies out of that. So we did a model of the tower different formation, right? And about 9 options. We did the solar gain modeling. Number 6 is the most efficient form. So before I talk facade, I better do this right. Orientation of each facade, angles, form, that plays a lot in a passive way, right? And then what we did is if we want to create a natural stack or a passive ventilation through the entire building as part of the strategy, we looked at the models in terms of where the voids will be, where the facade channels to draw air will be, how much we have to lift, and so forth. And we did a lot of exercise on that as well, because together, client and us, we committed that probably in Bangalore, we will only use about 1 to 2 months maximum in terms of air conditioning. So we worked hard on getting that. So channelizing, creating the terraces, creating the green buffers so that the wind blows through, all that we did. We did a lot of physical models and computer models, part of that. Now you can see the facade. As the facade angles, the mullion, the spaces, the projection of those, and the glass sizes and panel varies. Right? And where there is a dead wall in the terms of orientation, all that matters. Creating the 4 or 5 story channelized entryway, which brings lot of air and then pushes up. Second, this is a tower at Gift. So here we have a vertical campus in terms of institutional building. So research and office and institutional. We looked at morphing the 2 mass and creating terraces. So the wind channelizes, creating some of the interactive and plaza spaces in the vertical campus. And wherever south, we put the core and not too much of open windows and so forth. And then east and west, we modeled to really create an optimized scheme, and then created these wonderful screens which are angled scientifically to minimize the heat gain. You can see just a simple analysis here. Sorry. It's going just forward. Yeah. Reduced about 60% load, almost close to 4,000 trees. And we created a lot of green buffers across the towers as part of that passive strategy. These are some of the final renderings being worked. We use the terracotta rain screen as part of the jali and the overall, and then upper, there is a two-layer facade system. Now the question we always ask that we are using a lot of material, is it sustainable or double skins and triple skins and layers and whatnot? Yes, in the embodied carbon, yes. Front-end carbon, yes. So we have to do the analysis and try to minimize that. But at the end, run the life cycle model also and see the overall whole life carbon. That's where you get the benefit out of it. A lot of these terraces and stepped gardens and plazas were integrated with unique attention how the wind will blow and bring it up all the way through those towers. So a lot of terraces and overlooking landscape as part of the passive strategy was introduced here. Driver 4, performance and aesthetic go hand in hand for us. And quickly, this is a JSW global headquarters in BKC, Mumbai. Same philosophy we have done, and we have done a lot of modeling in terms of overall form as well as the building envelope, right? So systems approach, run through the model, run through the overall detailing, and a lot of analysis where you introduce double skin and passive ventilation or a atrium, a thermal comfort and wind velocity and so forth has been modeled exactly. And some of the curves in terms of thermal comfort and the daylighting modeling through the atrium and the final product. We introduced this huge atrium skylight that brings ample of a daylight in all offices. Last driver, so out of about 10 drivers, I'm covering 5. And we'll jump straight to the concluding remarks. So beautiful. I mean, when we design for architects, yeah, the aesthetic is given by default. Good architecture has to be given by default. But what's more, right? So this is where, so this is a unique project. So you may be thinking that, okay, we are just doing all this sizable project, but I think same thing can imply on a smaller project, whether it's a residential project, right? Private residential. So this is a house near Ahmedabad where it's a very simple, basic material palette. Facade is like there is just a mass going in and out, and it's a plastered cavity walls. That's about it. So the entire plan is really designed with all that purity and clarity in mind. We draw a lot of this abstract diagram to simplify our thinking so that it adds to the overall purity of the overall design sensibility, whether it's axis, geometry, structure, and elements, and so forth. And you can see it's a simple bar, but a lot of these overhangs add to the passive design strategy. And the site is contoured and harnessing the slopes of the site and doing this analysis in terms of taking mass in and out based on the shadow and other analysis. And this is the final product you can see. Asit Bhai Chair. He worked on this project. Thank you for that. So facade is not just a vertically. I mean, you can treat entire mass to do the job, whether it's a unique experience, whether it's unfolding beauty, or doing the job of shaded facade to minimize the heat gain. All is implied here. So we have bunch of skylights as part of the overall strategy and glass floors and whatnot. Yes. Often part of beautiful, most of the client that we have, I think you also experience, I want iconic. Iconic do na jara. And I say, what is it? मैं तो समझता नहीं हूँ iconic किसको बोलते हैं, because it's different for everybody. Your iconic could be different than mine, than his or her. So we said, let's work on this iconic, and we said, let's say for us, iconic is iconic journey. Discovering something together, right? Because this is a iconic in the Dubai that we worked, a gateway tower, looks iconic, we can debate about it. This is iconic in Calcutta for LIC. All underlying drivers are still the same. It's just turning into iconic. Another iconic in Mumbai. This is in Gift. This is in Ahmedabad. Again in Ahmedabad. Okay, so that's about it. I will just end to my concluding remarks. I had at least included one or two other projects with a lot of materiality, which I think, I'm sure the other presentations are going to cover very well. Yes. Concluding. So yes, would be good to go through the number crunching, modeling, but I think the first step is first. Very basic, passive strategies in harmony, use context to contribute, optimize natural energies, harness local climate, design mass carefully to do the job, play with built and void to optimize your envelope and design, form optimization, how you angle, what you do, orient, and so forth, window wall ratios, shadings, passive ventilation strategies, local materials and craftsmanship, introduce them, and select materials and systems responsibility. Pretty basic stuff, I mean, all of us know, but I think this is what the first thing we should do. Passive first is one, think CO2 emission. So when you use aluminum, keep in mind that this is a high embodied. When you use glass, think that. When you use exposed concrete, think that. And just drive your consciousness based on that, right? The three biggest impact material, concrete, steel, and aluminum, I mean, they are almost 23% of the overall embodied carbon in the construction industry. Stepwise, if we start passive, if we start thinking responsibly in terms of material selections, we will achieve and be on the path of net zero for sure. And for us in India, issues that play in are very unique. Land pricing, low rise versus high rise. Think about these options. Urban density, street weights, green cover and trees, air pollution, all that we have to deal with, which are unique to India and Indian cities. Right? वो सब अपने को integrate करना है. And try to add green as much possible. In a simple way, don't complicate. Because just one tree helps a lot, or 1 square meter of a green wall helps a lot. Last but not least, every time I ask, as a designer, as a planner, what is my role? What is my purpose? Am I a designer? Do I do architecture? Do I engineer buildings, or do I design facades? Similarly, I think we all need to ask questions to ourselves. What do we do? And the way I look at it personally is that creating and helping to create a better physical environment that helps upliftment. मैं तो एक आर्किटेक्ट हूँ, मेरे से क्या होने वाला है? कार्बन एमिशन तो दुनिया का प्रॉब्लम है. Versus take responsibility. We can make a change. All of us can make a change if we do it that way and make right decisions. I think we can add a significant value to our society and our nation. Thank you all. Apologies for more time.
Hello. Yeah. Thank you, Mr. Hariyani, for such informative presentation. Next, I would like to invite Mr. Ashwani Khanna, Vice President, Strategy and Operations from Fundamax.
Yes, thank you. And a very enlightening presentation, sir. Before we really get into thick of things, I would request everyone, because we want to gauge the emotions in this room, I would request everyone to open menti.com on their mobile phones. Once you have opened menti.com, there is a code you have to enter, which is 43421872. Our topic is fire properties and unique applications. And we would like to gauge the emotions and feelings around this topic in this room. Curious? Wow, lovely. It's pleasant, curious, good. Curious is getting bigger. So it's curious, good, happy, which is taking the center of the screen. We move to the next question. How important the fire topic is while designing the facade of the building? "32 people are saying hi, 39, 41. And thank you for this response. I can continue my presentation, it seems. And some people are also saying moderate, but largely people are saying it's high. We go to the next question. what role facade material plays in ensuring the fire safety of the building? What is your feeling about it? What is your emotion about it? Someone has said 20. Maybe I would like to connect with the person who said 20 after this presentation. Very important is taking again the center of the screen. So yes, it's very important, as the previous slide also spoke about it, critical. Thank you. And in interest of time, we'll move to the last question. What is your expectation from the facade material while making the unique design? Yeah, so it looks like cost versus the benefit. Thank you so much for this, participation. This has created a strong base for the rest of the presentation. Sustainable is taking the center of the screen. Yeah, thank you once again for this participation. Now moving on to my presentation. What is actually fire? Fire is nothing but rapid oxidation of a material. And if it is exothermic, heat and light is produced. Now based on, there are different fire classification, which is A, B, C, D and K. It is depending upon, the type of material it is. If it is solid, if the fire is because of the solid material like wood or plastic, different type of fire extinguishing is required. For example, water is good to extinguish the fire, or even, dry powder is good to extinguish the fire. Whereas if the source of fire is because of the liquids, like any flammable liquid like petrol or kerosene, then, water is not sufficient to extinguish the fire. Water will further spread the fire, whereas you just need dry powder or carbon dioxide. Similarly, C is basically because of gaseous, and D is basically because of solid metals. So a different fire you will have a different strategy to extinguish the fire. Moving on, the diagram which you see on the right side of the screen, it is talking about how the fire starts. Fire, it needs the ignition temperature. Then there is a growth stage. Before the actual growth of the fire, there is a flashover point. Now, there are materials in the building material space which are classified as A1 class material, which do not ignite, which means the fire does not start with such material. These kind of material are nothing but concrete, brick. Similarly, there are A2 class material and B class material, which will ignite, but they will not cross the flashover point, which means controlling such material when there is a fire is very easy. Then similarly, going forward, there are C class material, which will resist fire up to certain time. They come with the fire rating. They will resist the fire for certain time, and after that time period, they will cross the flashover time and they will grow. They will reach the peak. Then there are D, E and F class material, which are not so relevant for our discussion today. And as far as Fundamax is placed, we have A2 class material, which is known as M-Look, and we have a max exterior panel, which is a B class material, and we will discuss these two material in detail in the later part of the presentation. So a flashover point is very important while selecting the material. Now, as far as fire standards are concerned for max exterior as well as M-Look panels, as per NBC 2017-2017, we conform to BS 47 Part 6 and 7, and this is class 0 material, class O material. I would also like to talk about EN standards here. For the M-Look panel, which is a A2 class material, the fire standard is A2S1D0. Now A2, we spoke about what is A2. S1 is a smoke index. Smoke index is on scale of 1 to 5. When I say it is only 1, which means the smoke is very less. From my childhood, I really remember Uphar cinema tragedy in Delhi, wherein, in the cinema hall, curtains were being used. And since curtains were basically a combustible material, and when there was a fire, those curtains were causing lot of smoke. The smoke index was actually the highest. So smoke plays a very important role when you have to extinguish the fire, because dense smoke will not let you know where exactly the source of fire is. And secondly, it causes lot of suffocation. People basically, there is loss of life because of the toxic smoke and a dense smoke. Similarly, D is nothing but a droplet. On scale of 0 to 5 or 1 to 5, the droplet is only 0, which means it is safe to use even in the high-rise buildings. Suppose you have used a material which is having a property as D0, which means there is no droplet in case of fire. It will not further cause loss to the properties, or it will further not cause fire, because nothing is dropping out. So it is absolutely safe to use in the high-rise buildings. Similarly, for our max exterior panel, the property, the property is BS2D0. So it is a B class material, and the smoke index is 2 instead of 1, which is 1 in M-Look panel. Moving on, M-Look, the core of the material is reinforced glass fiber, which makes it a A2 class material. And the max exterior panel is made up of paper. There is a decor paper, and the core is also made up of paper. Now all this installation, whether it is an M-Look panel or it is a max exterior panel, the installation is done on the principle of rear ventilated facade system, wherein we leave a gap between the panel and a wall so that there is continuous air circulation. Now this continuous air circulation will provide certain benefits to the building. For example, heat insulation, sound insulation, and this facade also acts as a rain screen facade system, thereby protecting the building from the rain. Now the question can come, on one side we are talking about fire, on the other side we are talking about rear ventilated facade system. So this open cavity can further spread the fire as well. So this is what we are developing actually. There is a solution in the form of fire seal. This fire seal would be installed across the facade length as well as on the breadth of a facade. Now, this fire seal, upon getting in touch with the fire, it will expand and create the compartments. Once the compartments are made, the cavity is blocked and the fire will remain restricted to that particular compartment and it will not further spread. So, very soon we will have this system with us and we are developing it. We are on verge of finalizing a vendor for this fire seal solution. So some of the unique applications. This is the project in Lucknow, which we have done for a builder. This is a marketing office. Here if you see our panels, the max exterior panels are perforated. This is a CNC application. This will help to optimize the shading effect, and it's also a passive architecture, thereby providing a visual and thermal comfort to the occupants of the building. A similar project in Karnataka, Raichur. This is a horizontal louvre. This is a school building. And these are vertical louvers. If you see extreme right building, this is basically a project in Kerala, which is exposed to tropical sun throughout the day. And here the sun path analysis is done. Again, the objective is to optimize the shading effect, shading coefficient. and also to decrease the heat inside the building. This is a school project in Bangalore. So a curved application is also possible with Fundamax. Again, a school project. This is a M-Look panel, and this is a station project, metro project in Europe. And this is also a M-Look object, which is A2 class material. Now the beauty of this product is M-Look product as well as the Max Exterior product, which is a B class material. Both the products come with the same decors. So if there are two buildings, this face and this face can be cladded with M-Look, rest of the part can be cladded with Max Exterior panel. So this will help in optimizing the cost as well. Thank you. I think I'm in time.
Presentation on fire. So I would like to invite our next speaker on the stage, Mr. Praveen Chaubey from Façade Design Factory.
Hello, yeah, much better, yeah. So morning, whenever I come to Gujarat, let's start on lighter note. I always remember the Three Idiots dialogue. Gujarati people कितने sweet होते हैं, लेकिन उनके dishes कितने difficult होते हैं. Khakra, phandwa, handwa, dhokla. So just starting with those dangerous things, facade is also one of the most dangerous things in not handled correctly. So my today's topic is facade management. Is this the first slide? No. Technology. Yeah. Why facade management? To understand facade management, we should first understand the stages involved in the facade management. Okay. It starts with the very first stage of the conception design. Mr. Jayesh very well explained what all the stages that we go into designing of the facade. But then there is a various different angle also when it comes to designing of the facades. After the architect is done with the facade designing, to optimize the facade designing, it becomes very critical in terms of it's just like a jigsaw puzzle. One jigsaw puzzle going wrong and then the whole facade goes for a toss. It could be even a small thing. A grid change from a 1500 to a 1400 grid will cost you 28% additional glass wastage. It's only an 100 mm change in the glass grid, but then eventually if you look at the percentage, from a 0% you are actually landing up at a 28% wastage in glass. So this is the various angles through which we look at the facade design, intent, cost, quality, completion. If any of these things goes for a toss, the whole project, it becomes very painful for the end user as well as the developer, every party involved in the process. This facade management is very important when we start from the inception of the project. You need to have a very good partner. It could be the fabricator, it could be the consultant, but then you need a good partners to hold your hands through the inception stage. But then you can say the various challenges and issues in the facade management, design issue. Constructability issue is a very big challenge that we face, because when an architect perceives it, he perceives it in terms of the functionality, but then when it comes to the buildability, it becomes a big challenge for most of the people to get it executed the right way. A small change in the designability can cause a various impact in the cost as well as the future of the building. Long-term lead items, engineering issues, safety. Designing a building plays a major role in designing, like sir said, it's a very critical part. But once the architect has gone through the conception stage, then the facade consultant or the facade contractor, but then once again we say it has to be involved at a very early stage. But now if you look at the other aspects of it, when you start perceiving a design, the first stage to come on board is the architect, then is the structural engineer and the MEP. And if you look at the cost, the structural may cost up to 45 to 50% of the project, MEP cost 20 to 25%, facade may also cost you that much. Because it's now, if you look at the kinds of facade which sir has shown, Jayesh sir has shown, these are futuristic facades. These are no more glass boxes. But then unfortunately, if you look at the stage MEP, everybody comes on board very early. But then the only problem is the facade consultant or the facade contractor is the last one to come on board. Okay, when everybody has gone, everybody has designed everything. There is no scope of change or no scope of fine-tuning the whole process. These are the key performance. I'll go through quickly through this. Okay, I'll skip this. How it impacts, it looks at the design element, efficiency, right selection of the material, grid. Okay, this is a very small topic that we always like to cover. When you start talking of wind pressure, it's a very small thing. Then you start designing from scratch. You look at the project, then you start designing the wind pressure for the building. See the general 3 methods that are available for designing a wind pressure. Why I'm covering this, it looks like a very small topic, but then what impact it can create on the whole process of designing and how efficiently you can design the building. So you have an IS 875 part 3. Okay, that's by the codes that you write, that are written in the, you have in the IS code. Then you have a wind tunnel, and then you have the CFD analysis for the building. Okay, so these are the general general criteria through which the wind tunnel design looks at. So as per IS 875 part 3, the wind speed increases as the floor rises. Okay, so accordingly the wind pressure also increases as your floor rises. When you start calculating as per the IS 875, you have a slab of 10 floors, say 10 floors is 1.5, 10 to 20 is say 1.8, and beyond it is 3, 2, something like that. When you start dissolving it, it becomes, you start getting those numbers. Okay. The second drawback in this system is it's more of an assumption based. A structural engineer designing would consider consumption. When we get sometimes, the structural engineer comes and says, sir, wind pressure is 3 kPa. I say, बहुत ज़्यादा है. Client दबक जाएगा. एक काम कर, category change कर. Okay, from category 2 to category 3. So it's purely an assumption based system. Okay, this is the actual wind tunnel that you create a model, and then wind is blown through the tunnel, and then the various parameters are being measured on this. So this is a classic example we did for an IS 875 part 3. You can see here first slab is 1.8, second stage is 2.2, the third is 2.5, and fourth is 2.9. This is what the code says. Now when you look at the actual as per the wind tunnel is the most accurate data that you have. Okay, so when you look here in this picture, you can see here this is 2.5 right from top to bottom. This complete zone is a 2.5 wind pressure. Okay, it's not like unlike IS 875 part 3 where it says that the zoning is different and you get various wind pressures. This 2.75, and you can say that the strange thing is at the top what you are getting is 2.25, while at somewhere at the corner you are getting a 3.25. Okay. This is a model for the same project. We did the CFD analysis, and then here also you can see here the wind pressures are varying from top to bottom. So it is more or less the same result that you get from the CFD as well as the wind tunnel. The advantage of CFD is a much faster process. For unlike wind tunnel, you have to wait for 4 months, 5 months, 6 months for getting your results, because there are very few labs available in the market. Unfortunately, we have now one in India. So earlier we used to go to Canada to get this done, but now you have Canada or Singapore to get this done. But then still the wait time is around 3 months. But then in CFD you can have the results in say a week's time. You can actually get this done. So what you do is you construct a model, and then at every 10 degrees you can rotate the building and then do the wind analysis for the building, and the max one you can easily get. I'll skip this. CFD is also helpful in using daylight optimization, the flow of water, the velocity, the solar gate analysis. So all this can be done through this. Okay, so we'll just take some examples that how a facade management can actually impact the whole facade and the end result. Okay, so this was the design intent from Gensler London that we were given. The intent was very simple. This was a 5750 grid, and at every 750 grid, there was glass here. This center portion is glass, and then we had the GRC. The architect had an idea of building blocks and then doing a window wall in the whole construction process. Then when it came to us, then we started designing it, and then we thought that this is a very longer process. And more the interfaces, the more number of chances you are getting a leakage there. Okay. So then we said, let's reverse this up and then do it a completely glass building, and then only do the fins on top of it. And then we were still at the GRC fin. So this was the detail that was perceived in the terms of the variation. The GRC varies from 200 mm to 650 mm. So the weight of the GRC was very high. Okay. But then the advantage in this was it was easier for construction. You don't have to do too much of block work. The load on the building was much substantially reduced, and the completion time was also reduced. So eventually then we came up with this detail. You can see here the detail. The system was from Schuko. The sponsors, please note, we mentioned your name. Okay, the system was from Schuko, and then we converted the whole fins into an aluminium fin. Okay. This was the mock-up done at an early stage. We took it offsite because it was a very challenging project, and we did various stages of the mock-up. So this has a GRC, this has an aluminium, and then this even had a stone. So this was how the building looked without the fins. So you can see here we completely cladded the building with the glass first, and then brackets were left. So this was the perceived image, where the architect had actually gone with blocks and glass. This is what he perceived. And then this is the end product that we gave him. It looks exactly the same, but then the whole constructability, whole sequencing, whole material was changed. And okay, this comes to the next project of ours, where we are doing an HDFC Mumbai. This is a sawtooth facade with each facade getting angular. So you can say this was the perceived from the architect. They were going from a semi-unitized system in this, and then they were doing a cladding later on when we got on board. So the first option that we gave was 2 different systems and then cladding it in between, but again it was a cumbersome process. We had to have scaffolds and again do the flashing in between. You can see here this was again a laborious job to do. And then we came up with the system of actually integrating the whole thing into a unitized system. So you can see these are the various options in this. You can see here this complete system was created here with a single unitized panel, and then we achieved what the duration of the project, even though was at least reduced by 6 months, and everything was now getting manufactured in factory. So the process is better, and the drainage and control is better. This is one more project that we are doing it in Vashi. That's an NNMT bus stop. Again, this you can see it's a parametric facade. So this is the way the facade is inclined. So each mullion is getting turned and twisted. So here we went on with an option, the slab. They were unable to cast this slab in this position. So what we are doing is we are actually doing the whole MS framework and then integrating the facade along with this, doing a unitized system in this. This is a project that we are doing in Bombay. It's a very interesting project that how a certain change in the grid can impact the whole design. So this is a dichroic film project. Dichroic is a material that when you start looking at it various angles, it will give you a different color in terms of the glass. So this is the installation sequence of this. Now here, a small change in the design could have impacted. This project came to us at a much later stage. So here what happens is all the panels are inclined. So this being an inclined panel, the length of the panel, even though the floor height is 4.5 meters, what we are getting is an unsupported span of 6 meters. And then eventually what happened here was the end mullion. The end mullion could not give us the, you can say it was not resting at the right position. Had the project been shifted by 200 mm, the end panels now are almost 1,000 kg panels, which we could not install it without the glass. The fabricator could not lift the glass. We could not have the mechanism to having such a, since Even with the help of the tower crane, we could not lift this because it was the space was much lesser available. And then we were installing these panels without the glass. And then we had to redo the sticking of the glass from, the glazing of the glass from outside. So had these been at an early stage, a small shift in the grid by 200 mm could have saved us the whole process of doing this. So by this, we are actually delayed the project by minimum 8 months. So we'll see here. See, this is the corner panel. You can see here, this corner panels are being installed without the glass. This each corner, this is a laminated DGU glass, so the weight is much higher. Again, this project we did in Hyderabad, this came to us again at a much later stage. You can see here the architect wanted fins coming up here, and then he also wanted a unitized system for the project for the better efficiency. Whenever you are doing a unitized system, you need to the whole fun, or you can say the advantage of using a unitized system comes when you actually going continuous. Whenever you have breaks like that, it becomes really difficult for somebody to install. Because if you look at the sequencing of this, we installed the unitized panel, and then to clad this fins, we had to again erect a complete scaffold. Because the problem is this fins from zero, you can say from zero, it almost reaches this up till this edge. This is almost a 2.5 meter. So even a gondola was unable to reach the lab location for reaching that. So, and because it's varying, all the locations are not same, so drop in the gondola was unable to help. So even though the systems were used correctly, but then in terms of the installation process, we were kind of on a back foot, and the end product looks the same, but then eventually if you ask the fabricators who has done this, for him it's a big challenge. I've been asked to curtail this to a 10-minute. So these are the futuristic material which you can see here, UHPC, where people are using GRC. Just to give you an example how a small change in the selection of the material can impact your design. GRC is the maximum span that you can have is up to 1.2 meters, and then you're having a horizontal band coming here. With a UHPC, you can actually go up till 6 meters without any horizontal support. So these are the kind of panels that you can end up. You can see here, these are huge panels. This is almost this is more than a 6 meter that we installed. So material selection, yes, appearance, reduce energy consumption, self-cleaning materials, durability of materials. So the selection of material plays a vital role in terms of the designing. The next stage comes is the post-tender, even though everything is fine, but then eventually if you are involving somebody at a later stage, it becomes really risky for the facade guys to do it. So you have system engineering, submission, testness, production. So all these are very time-consuming process when you look at the whole picture. Major dependency, design, shop drawings, aluminium, glass, sequencing, installation. Now, major die development, everybody knows it takes a minimum of 4 to 6 months, but then if you go to a good processor or a good system supplier, it's more than 2 months for the die development. So whole process and everything, by the time your systems and shop drawings are getting approved, there's almost some projects even take up to 6 months, only in the design process. And then you go for a PMU test, so that adds up to another 1 month to the whole process. This is 2 minutes left. Okay, now this is one project that we are doing. You can see here the sequencing of the material, the brackets that have been installed, because the construction, the lines and everything were not in line. So we had to install, this is almost a 500 mm bracket that we had to install to take the project, to receive the panels. The holes, you can see the installation sequence here. So the bottom line is the only way of doing facade is doing the facade the right first time. If it is not done the first time, you have to live with it. Is only you have to keep on modifying it, or you can. It's only an eyewash that will keep on doing, but then eventually it will always be a problem. We unfortunately don't get a second life. It's only one thing, one time that you can get it done. Facade needs time and process to deliver. It requires a lot of management between different stakeholders. Thank you. See, we have managed our time very well. We are before time.
Thank you, Mr. Chaubey, for sharing the information with us. Now I would like to invite Mr. Arun Madappallath from Search Ferrari Group. Sir, please.
Good morning, everyone. Happy to be present here, first time in Ahmedabad, presenting Search Ferrari range of products. Thank you, Zak, for this opportunity. Okay. So Search Ferrari is a manufacturer of flexible composite material for facade applications, for different applications, and facade is one part of the applications. And this year we are celebrating our 50 years of commencement. So it's a proud moment for all Search Ferrari team. So my name is Arun Madappallath. I am in this membrane industry for the last 20 years, associated with Search Ferrari. So it's also a proud moment for me also that 50 years celebration is happening, and I am part of that for 20 years. So I'll just show you our corporate video about Search Ferrari Group. We design, we develop, and we manufacture flexible composite material, different types of materials. Polyester yarn based goods, coating PVC, PVDF. So we are leaders on 4 strategic markets. Tensile architecture, it's prominent across India nowadays. Modular structure for wide span applications. Solar protection, internal window covering and external window coverings. Furniture. And yachting applications. It's about Search Ferrari Group. So our CSR approach is plus is equal to 0. Search Ferrari is one of the company who already into recycling of the PVC coated materials. We have our own solutions for that, and now we also have products produced from the recycled second generation material. One product by product, we are introducing that to the market as well. 4 important markets: solar protection, internal window coverings, blinds, and external window coverings. Can be external blinds or awnings or pergolas. Tensile architecture, which is a key market. Roofing solutions, shading solutions, canopies. We have done a lot of stadiums across India, a lot of airports across India using tensile architecture applications. Modular structure, mainly for the wide span, warehouse, halls, etc., and furniture and marine applications. These are the 4 key markets Search Ferrari is focused today. So the subject of facade, why fabric as a facade? So we have different chapter to cover. Thermal insulation and visual comfort, the first chapter. For thermal insulation and visual comfort, if the fabric is used as a secondary skin, you can see that 4 important parameters: outside visibility, it doesn't block your vision. You can see the outside visibility very clearly because of the porosity of the mesh material. Thermal comfort, since the heat is blocked outside, you will have better thermal comfort and glare control. Because of the coating of the fabric, we have good glare control on the secondary skin application. And natural light inflow. So natural light inflow is a key parameter. As per the World Green Building Council, the working environment should be really protected so that people have a better working conditions if you use a facade material, and Search Ferrari material is one of the best solutions for the such applications. Then unique identity to your structure. So we can create Three-dimensional structures, lighting solution, and printing possibilities are there. LED lightings, day performance and night performance will be different when you use LED lighting. You can give a unique identity to your building with LED lightings. And 3D designs, many design, because fabric is a flexible material, you have the possibility to have different three-dimensional solutions, 3D designs, and the textile printing. Printing is possible on the fabric. We have a special varnish on the fabric to make the printing possibility. Okay, next chapter is energy savings. This is an important subject. We have two examples of using fabric internally and externally. In internal solution, the heat is cut outside and the fabric is used as an external solution, internal solution, and the amount of heat will be coming inside will be much more when you use externally, because when you use externally, more than 80% of the heat is cut outside and only the balance heat is transferred to the glass and to the building. So you will have much energy saving when you use fabric as an external solution. Of course, natural light and you can reduce the air conditioning by using the fabric externally. This is one case study. We have done a project in US, South Base. This is also the old building, and there are a lot of issues because a lot of heat coming inside. The working atmosphere was not good. So we have provided with a solution as an external membrane, and the whole the architecture feature of the building has changed, and definitely a lot of heat was cut inside, and you have good energy savings when you use the fabric externally. So you can see here we have some case studies. This is a real case study. The investment was $200,000 and the savings are $60,000 per year, and after 15, so it was done in 2005 until 2020. After 15 years, they have almost recovered all the costs, and now it's a savings for them. This is the building before and after. The complete aspect of the building has changed when the fabric is used externally. So renovation possibilities are possible with the fabric solution. Okay, now fire codes, it's an important regulation. We have all the international fire codes compliance with our fabric materials. We have two types of fabric. One fabric is PTFE coated, glass yarn base, which is fire resistant fabric. Then we have polyester yarn base and PVC PVDF coated fabric, which is a fire retardant fabric. So we comply all the international standards for the fire. Just an example between fabric versus solid material. You can see that the outside visibility, the porosity of the fabric is 30%, but still, it's a perforated holes, and you can see the outside visibility is much good comparing to the conventional solutions. And of course, it's a lightweight solution. Okay, this some case studies of the projects. It's a cassette panel construction, airbus hanger. You can see it's a very lightweight structure. It's a large panels. You can build large panels with membrane. Okay, and it is in written with the internal facade, and you can see the internal light coming inside and the visibility towards outside when you use the fabric as a solution. An important study, fabric can be also used as a primary membrane. This is an example, Burj Al Arab project in Dubai, more than 25 years of existence now. PTFE, glass fiber PTFE fabric was used as an external membrane, and the longevity, it's more than 25 years, and you can imagine the longevity of the fabric. Still, it's in very good condition after 25 years. And we can also have, during some festivals and all, they play with lights, LED lights on this building. Okay, so monolithic construction possibility, big panels. And retrofit, which I was explaining for the South Base building. You can see retrofit possible. Before and after you can see the project. This is just, there is no secondary structure. The facade aluminum structure is connected directly to the building, and you can see the results. It's not much expensive as well, because you don't need a secondary structure for this building. This project, glass, lot of heat coming inside. Again, we provided the solution with the facade mesh solution. So another project example wherein you have, the complete aspect of the building has changed when you use the facade composite material. This is a sports complex. The whole building was wrapped with the fabric. So different types of fabric facade we have. Breathable mesh. Okay, this is mesh fabric. We have fabric with 5% openness factor up to 50% openness factor. Okay, very good solution for energy saving, control of light, control of heat, glare control, etc. when you use this mesh fabric. Then we also have opaque fabric where you don't need the light to come inside and to wrap the building with architectural feature. You have opaque range of fabrics as well, waterproof. This is a primary skin. Then high translucent material. We have fabric from 7% translucency till 51% translucent material possibility, waterproof material possibility for the facade applications. Transparent single skin fabric. Can somebody change that? I'm not able to move them. Yeah. Transparency, 55% light transmission. It's a plain mesh. It's a new development from Search Ferrari called STFE. The high translucent for for better UV coming inside for plant growth, etc. This fabric can be used as a skylight or dome or as a canopy as well. Okay, so with innovation at its best, we have fabrics which has many characteristics, multiple fabric choice selections, mechanical resistance, got good mechanical property. You can have one single panel of 15 meter by 10 meter, one single panel, good resistance to weather, color fade resistance. We have long-term aesthetics, low maintenance, and the value engineering what Search Ferrari is give that we have in-house design support from Search Ferrari group. So these are the range of fabrics we have, PTFE, glass fiber PTFE, and PVC coated fabric, and the high transparent fabric, STFE. So Search Ferrari has an in-house design in India, wherein we give you the 3D rendering. Once the 3D rendering is accepted, then we can go to the design model. Once it is concluded, GS drawing and connection details, everything will be provided in-house to the architects and the stakeholders from Search Ferrari group to develop such kind of projects. Another important part is that we should have a solution for the framing. So we have tied up with a company called Facade Textile International, who supply profiles for this facade applications, and we have different types of profiles, and panel size from 4 square meter to 60 square meter we can cover, and AeroW and AeroLite are those kinds of profile. New development is Solar Skin, which is really an innovative product from FTI. Very cost-effective solution, huge panel construction possible with Solar Skin. And of course, it complies with all wind resistance up to 250 km/h. EPD, we have EPD certification. Green Guard Gold certification, which is for the chemical emissions for the building materials and finished products. LEED certification, and these are different key projects across the world. We have constructed key projects, hotels, Burj Al Arab. That's a Y Boutique Hotel in Mysore, the second picture, which we have done in Mysore through Dinesh Verma, ACE group of architect Dinesh Verma. Officers projects, key officers project across the globe. Different, you can see the constructions are different for each application. 3-dimensional projects, monolithic facade, printing possibilities with LED lightings, and multi-story car parks. Multi-story car parks are normally open across the building, but we can beautify that with the membrane as a secondary skin. Culture centers. education. This is Kids University. The first project is Kids University in Bhubaneswar, done with a combination of mesh and plain fabric from Search Ferrari. The whole facade of the building is covered with fabric solution and with FTA solution, the facade profile solution. And the third project is the PSG College in Coimbatore, which was completed recently. A beautiful project, around 4 lakh square feet of area is covered with the fabric, with three-dimensional structure with FTA profiles. And sports centers, possibility to do the facade of sports complex or stadiums. Stadiums, yes, we have the roofs. In Qatar World Cup, we have done 5 stadiums, FIFA World Cup recently. Facades and the roofing solution as well with Search Ferrari fabrics. Car parks, multi-story car parks. Safran is one of the project, it's a big project with big frames. And if you see that Safran logo, actually it's not printed. It is a combination of solid fabric and the mesh fabric, and patterned and welded in a way that, it is all together with the solution. Printing possibilities are here. And Search Ferrari is present across the world. Okay, we have factory in La Tour-du-Pin in Lyon. That's our headquarter and the main factory. And recently we have acquired Versadag group of companies, which is based German company, specialized in PTFE coated fabric materials. And then also we have another company called FIT, first in Taiwan, again manufacturers of glass yarns and PTFE coated fabric materials. Then we have PVC extrusion and recycling solution across the world, and lot of we are present across the world with representative office or subsidiaries or distribution ship network across the world. That's all from my side. Thank you very much for your attention. We have a booth outside. If you have anything, please come and join us. Thank you.
Thank you, Mr. Arun Madappallath. It was a very beautiful presentation. Now we shall break for the networking. The tea and coffee will be served outside. The break will be of 20 minutes, and I would request everyone to be back by 12 o'clock. So it's the start of the second session now. I would like to request Mr. Gautam Bhasin, Regional Director of Inhabit Group, and Mr. Saleem Bharti, the Dean of CEPT. Please come on the stage for the joint presentation.
Thank you, Nimit. Hi, good afternoon. Good to be back. Wearing a slightly different hat today. Normally I would walk in as a facade consultant, but today I'm an academic, co-presenting what we're doing, something very exciting exercise that we're doing at Faculty of Design at CEPT. It all started with a conversation that I was having with Saleem, I think close to about a year ago. But where it all started was here, where I think India shocked the world by saying we are going to go net zero, carbon neutral, or potentially even carbon positive by year 2070. Now it sounds really shocking with a country like India, where people don't really know where the carbon is or what carbon is, what is net zero, what is carbon neutrality, how do we actually get there? And eventually it turned out that there will be a 5-step approach that the Prime Minister preached to the world. Renewable energy to 500 gigawatts. Where we are currently, it's about 120. We have to reach 500 gigawatts by 2030. 50% of energy should be coming from renewable resources. I think we're sitting at about 12-13% at the moment. Reduce carbon emissions by 1 billion tons by 2030. Again, a very tall order. And then carbon dependence of economy reduces to 45%. By 2070, and then carbon neutral net zero emissions by 2070, which means we are actually reducing the amount of carbon that we are producing, or we are actually reducing the amount of carbon more than what we're producing at the moment, so actually reach the carbon neutrality. Now, obviously, everything is a tall order, and I think there's multiple industries that are contributing carbon to our environment at the moment, and all of us have a role to play. Where do we get there? Now, how do we get there? So essentially building carbon has close to 40% contribution, whether it's operational carbon or whether it's embodied carbon, whether it's front-end carbon or whether it's carbon during operations. Obviously you have manufacturing, factories running, spewing carbon in the air, or utilizing fuel sources which actually add to the carbon contribution. Transportations, cars on the roads, trucks, trailers, we obviously need to move from place to place. We also need to move our goods from place to place. And then there are other agricultural and agricultural dependent activities which contribute to the other 9%. But when we talk about the 39% that everybody in this room is responsible for, how does that split across? Now, between what we consume at the time we're building, between what we consume at the time we're designing, between what we consume at the time we're specifying a building, comes close to half of what the overall carbon the building will consume over the years. Because what we've been focusing on so far is the operational carbon. We are trying to use better glass, we're trying to add shading to the outside, we're being very conscious about window to wall ratio, highly efficient mechanical systems, highly efficient air conditioning systems. So yes, we are doing everything right to make sure the building consumes less carbon, consumes less energy in its lifetime. But what we're not focusing on is how much carbon we're actually consuming when we're building it. Now, what that takes us to is, how do we build? Where do we start? Now, obviously we're extracting materials. We are digging ores, extracting aluminium, using silica to make glass, bauxite to make cement. All of that is a very carbon intensive process. From extracting materials, we move on to manufacturing and actually building it. And then lastly, we move into use, where the building is actually underused. If something actually falls apart or starts breaking, not functioning as required, then we repair it. But what happens at the end of the life cycle of a building is you discard it. Buildings end up in a landfill. And for any economy to be carbon neutral, for any economy to be fully sustainable, this entire loop has to be completed, where the entire cycle is circular in a way, where we can effectively move back into the material ecosystem from use and repair and end of life. Saleem, you would like to add something to that?
Hi, thank you for having me over. I think a fair beginning, Gautam, to get a sense of the larger carbon issues facing building environments. I think I'll briefly speak about the Faculty of Design. I'll briefly speak about, Faculty of Design, just to begin how we kind of came together and why we came together. And I think this is important to understand that we are focused on developing contemporary streams of knowledge, because academia needs to push boundaries, it needs to partner with industry, it needs to engage industry, foster innovation, harness technologies, and eventually, look at the challenges of our time. And in this case, right now, and I'm happy to see in some of the earlier presentations as well, the sustainable aspects that come into various building facades and construction activities on our planet. I think that quickly, Gautam and me would work together on some other projects a few years back. We said, let's take a design studio, let's construct one, let's look at how we can engage industry, let's look at how we can collaborate and not only within the student framework, but collaborate with industry with certain aspects of what we spoke about. We'll come to the approaches quickly. The timer running over here, and I'm concerned about that. But we looked at a design studio, offering a design studio, which is actually live right now. We are in the 13th week, so it's a 16-week design studio. To the entire process, we've accessed latest global research available to us, relevant to the project. And because it's collaborative, students not only worked in a team, but they worked across CEPT, which is Faculty of Design, collaborating with Faculty of Technology, collaborating with CARBS, which is the Center for Advanced Research in Building Science and Energy. We collaborated with wood technology experts and industries, and we'll quickly talk about that. Decision-making then was not based on subjective, personal, student, I like this basis of design. It was based on fact, it was based on rigor, it was based on validation and the approaches that we set for ourselves, which I will come to. And this is very important to kind of state that because the global construction sector, and I'm glad you put it over there, it consumes significant resources, generates substantial waste because there's no concern for end of life. It's responsible for emissions of atmospheric pollutants. There is this increasing effort now, which is to transform the current linear approach to design, and I'll say the design of buildings that has one end of life, which you spoke about, which is landfill, demolition and landfill, to a circular design solution that guarantees multiple life options, and the issue of considering its systems and as products and materials. So there's a linear model versus a cyclic model, and we are now in some way looking at what happens to demolition. So the idea that your building, which is say 70 years, which is a human lifespan actually, doesn't go back into the ground. It goes back into a landfill, right? And how do you then, maybe in a 70-year time frame, what happens when the buildings in the 1970s, 60s start being thought of as too old to continue to reside as functional buildings, and then they're being pulled down? What happens to that? What happens to the material? So in some way, the act of design needs to understand, and act of design needs to kind of consider that you have to be able to think of what happens to the building when it's being pulled down as part of a design process, which means education then in some way focuses students to think not only I am designing this because I like this, because it is right for that setting, for that situation, but education then it predicts that what happens to the things I've made, the beautiful buildings or beautiful facades or beautiful systems I've made when the building is not used anymore, when the building needs to be adapted, or when the building needs to be reconfigured. In that sense, this studio, because it's in Faculty of Design, where industry and production and technology and other aspects of design come into play, we thought of using industrial processes, relevant materials, and the multiple parameters we speak about. And I'll just kind of go on to the next slide, which is then, an industrial term, which is design for environment, right? And what is then design for environment? It is a systematic consideration of design performance with respect to environmental, health, and safety objectives over the full product and process life cycle. So DFE, like concurrent engineering technologies, seeks to address product life cycle. And these concerns at an early stage, which is in the design stage. So when you integrate the idea of life cycle, end of life in the design stage, you will already plan for what happens to your building after its end of life. And therefore, DFE, design for environment, considers in some way other topics, which is design for manufacturing, design for disassembly, design for assembly, apart from which include recovery, recycling, disposal, regulatory compliances, human health and safety impact, and hazardous material minimization. Within these 6 parameters, and because we looked at energy and we looked at net zero and we looked at off-grid, this then became the working constructs of the studio. And quickly to kind of give you design for environment, very brief in words, we looked at materials, production, distribution, use, recovery. What are the concerns which impact each area? I'm not going to state them. Please glance at them. Clock is ticking. Design for environment. Design for manufacture, where modularity came in, reduction of parts, standardization of components. I'll give you a second to look at this slide. Design for assembly. Very important to understand that if you think of a building as a product, right, you will think of how it needs to be assembled on site. How do you minimize certain, whether it's time or whether it is building fasteners. and disassembly. This is where we focus on a lot, where the materials or reversible design or end of life starts taking to play. Because when you're designing for assembly, you're thinking of how the building can be put together, or how the facade, or how the system being put together. Design for disassembly is the reverse. If you make it difficult for someone to disassemble the building, they'll rip it out. They'll call some, their things to demolish and then to fill trucks and landfill. How do you disassemble a building, ensuring that most of its parts can be reused without them being melted or being recycled? So reuse case is very important, wherein we realize that perhaps you can't use then any glues anymore. If you're using wood construction, you use glue, you kind of join things, you can't really dismantle them. So quickly, this was designed for disassembly. And thank you.
So with those 4 pillars, design for environment, design for manufacturing, design for assembly, design for disassembly, what do we then translate that into? That's essentially the how and what of this exercise. How do we convert that into a product that can be designed and eventually be built? I mean, we're literally talking a serpentine pavilion here being designed and completely built, and we're about, 2.5 weeks away from completing it. So it's a habitation unit, and habitation unit has a very vague meaning. It's not a house, it's not an office. It's basically a unit and enclosure which allows the flexibility. And that also is the design brief, that you don't design it as an apartment. You don't design it as a studio. It's a space that can adapt itself, where you have components which can be switched or plugged, and then during the day it could be an office, during the night it could be a bedroom, so on and so forth. So it's roughly about 200 odd square feet. DFE, DFM, DFA, and DFD principles that we just spoke about are basically the core principles of this exercise, which is something we talk about every day. Everything we question has to be around these principles. Embodied and operational carbon is important. That's informing the choice of materials we use to a large extent. Timber is the central hero of the story, as I would like to call it, because timber is essentially a carbon sink. It actually reduces carbon, so its actual global warming potential is negative compared to everything else. Assembly and disassembly, as Saleem spoke about, it should be easy to put together, but also equally easy to pull it apart, and not in the bad sense, but sort of disassemble it in a very systematic fashion. Sustainability, because we're talking about it being carbon neutral, it should also be somewhat independent, not connected to grid, so possibly an off-grid presence as well. And what do we do with the materials at the end of life? Equally important. And what happens at the end of life when you start extracting materials back, where it can actually then contribute to an ecosystem of materials, where those parts and components can become a kit of parts of potentially another building somewhere else, or maybe a part of a different assembly somewhere else. Like we spoke about flexible units, it can't be a single use, it can be multiple use, so you don't build too many of them. And at the end of the day, it's all value driven. So the design looks like this, 240 odd square feet. We are talking about modularity in terms of grid, which is then reverse informed by the material availability. Timber is available in certain sizes, glass is available in certain sizes, extrusions are available in certain sizes, panels are available in certain sizes, and that is informing the size of the unit itself. So you don't have too many off-cuts, you don't have a lot of wastage. Future expansion possibilities where it all can expand in the grid dimensions. And then again, you have passive solar orientations, depending on where this is being built. It could be built in Ahmedabad, it could be built in Ladakh, it could be built in Chennai. The building could be oriented differently, the profiling could be different, so it also starts taking passive solar principles into account. This is a scale model in the studio. Now, materials are obviously an important part of any building conversation. When we are in a decision-making process, we talk about longevity, aesthetics, performance, so on and so forth. But I think this pyramid actually became a very central point of a conversation of how do we choose materials. As you keep going higher up, the higher is the global warming potential. So these are the values of all the materials we've considered in kilograms carbon dioxide per meter cube of the material. Obviously, we look at aluminum frames. We saw in another presentation, it probably sits right at the top, probably being the biggest criminal, but there are now products available which are more recycled, higher recycled content, and that's something we're also exploring. So wood, as I said, negative carbon, great material. Concrete comes after that. Concrete is something we're not considering for this project. Then structural steel, also not considered, glazing, and then finally, aluminum. Types of timber construction, there's multiple types and typologies where you can put a timber building together. There's different methods of putting it together. And again, keeping disassembly as a key parameter of what can we easily disassemble. A simple post and beam structure was something that we chose to move with, not cross-laminated, not lightwood frame, because these are all sort of glued together. There's a lot of chemical bonding that takes place, making it difficult to pull it apart. Low impact foundations, and this is something that we had very close to our hearts. Like we want this building to be disassembled and moved out. What happens to the site at the end of life? You don't want site to have holes dug in it, piles left in it. So essentially, what we looked at are these helical piles, which are literally driven into the ground like a screw, and the entire building is lifted off the ground. So at the end of life, you could literally unscrew those 6 piles, and the site is actually left as it is, no change whatsoever. Structural modules, again, what we're talking about is not having any wastage on site, and that's the whole principle of design for manufacturing, where everything comes manufactured, you don't cut on site, you don't generate any solid waste on site. So multiple approaches of having grids, structural grids, where you see those small overhangs is where the material is not cut, it just basically is used in the piece, in the module that it comes, so it can potentially be reused again in another form somewhere. When you're done with structure, next comes the wall. Obviously, we have a lot of laminated timber solutions, which are great industrial design, fabulous products. But what happens in this case is that timber is not in its purest form. It has glues involved, it has dovetails, it has nails involved and dowels involved. So the timber then can be used only in that form at the end of life and can be only cut and made smaller. So again, the potential of reuse goes low. So we looked at timber with overlapping joints. Shiplap was something that we chose because shiplap has the potential of changing even a single panel. Let's say something cracks or something goes bad, you don't have to dismantle the whole thing. A single module can be removed out of place. Fenestrations, currently the choice is aluminium for the reasons stated here. Obviously, we're looking at this exercise growing into something where a timber aluminium composite could be used as well. And I think Shuko has been partnering with us in this exercise, and they have some great products there. Other materials considered timber, UPVC, steel, but aluminium gives you a lot of precision in windows that we all use a lot in our buildings of late. Roofing orientation, like this building could be anywhere. This could literally be transported somewhere else, and a slightly different roof profile could make it adapted to that situation. Your glass could be slightly different, your insulation could be slightly different, but then it becomes that place, it belongs to that place. Roofing materials, we looked at a lot of materials, including steel, GI, and other materials. There's a eco sheet that basically is a recycled form of Tetra Paks, and that basically takes waste out of landfill and then is used in this form. And instead of using mineral wool or glass wool, we're looking at using corkboards and cellulose fiber sheets as insulation, which go under the roof. What happens next? Here's a site. I think most of you are familiar with CEPT, should probably see this building up in 3 weeks from now. So we've identified a site. The lining out is happening or has happened already. Material has started arriving. And yeah, the connections, joineries, bolts, templates, etc. are all in place. This is a picture from day before yesterday where the timber is being planed. We've just received pictures of timber being torched for wall panels, etc. So it's now becoming a very real thing. And this is a render overlay of what it would look like. And potentially in another 3 weeks, if any of you happen to visit CEPT, this is where you would be. This is what you should see in real life. And I'll just quickly, my last slide. It would not have been possible without the support of our industry and technology partners. Nesca Homes has basically been with us, hand-holding us through the process of how to put timber together in a building. Canadian Wood has provided us with materials. Shuko has been a very critical partner for us, giving us fenestration solutions and also helping us make windows within timber, which is very uncommon in India. Guardian Glass for providing glass, Hetic for interior fittings, Faculty of Technology and Carbs, which is a part of CEPT itself. They've been providing us with technological assistance and engineering assistance. Rotoblast for fasteners. Tata Power is providing us with solar panels that go on the roof, and Bhuj Polymers for the piles. And with that, I'll end my presentation.
Thank you, Mr. Bhasin and Mr. Bhatri, for the wonderful presentation. We would now proceed with our next presentation from Shuko. I would like to request Mr. Omkar, Dr. Omkar Powar, Mr. Kushagra Awasthi, and Mr. Pratik Doshi on the stage. Thank you.
Go on.
Good afternoon, everyone. Hello. Yeah. So my name is Omkar, and I take care of innovation activities for Shuko India. Today I want to explore with you all what are the megatrends, especially the megatrends which are driving the construction or building industry for the innovation or pushing the boundaries. What are they? I want to emphasize on that, and then I will come to the point or highlight the points how Shuko comes into picture and how we are driven to contribute through our innovations and cutting edge technology into all these megatrends. So, yeah. So innovation starts with imagination. So first of all, I will request you all to imagine. Let us imagine that you have reached a new city, say Mumbai, Chennai, Bangalore, any new city. You just stepped out of your train or a metro. What do you see? A vast expanse of population, right? And what else? The concrete jungle to accommodate this vast expanse of population. Yeah. So these are nothing but the first mega trends which are there. Nothing but the urbanization and high-rise structures. Okay. These are the first mega trend which are there. Now, currently, building industry consumes around 40%, as Gautam focused. Like 40% of the natural resources and the energy currently is used by our building and construction industry. To expand in this type of a fashion is not very sustainable, right? So that's where I'm coming to the next mega trend. That is the necessity-driven mega trend. That is the sustainability. Now, as I requested you to start with imagination, you are still in your imagination. I would say you have reached a city, you need to go to your hotel. With the mind and thought of sustainability, you decide to take a walk to a hotel which is nearby. Now you feel, or suddenly you realize how real is the impact of the global warming today. All the sweatiness and all, you feel that impact. The global crisis which was down the lane is already reached your doorstep. So that is the third mega trend which is driving or pushing us towards the innovations. Any product which our building industry has to be designed for this mega trend, because it's not only impacting the temperature rise, it is uncertainties into the rainfall, intensity of the cyclone is increasing. So all the specifications are driven by this mega trend. Finally, you reach into your hotel, you step in. What do you see? What do you see? You are mesmerized by the beauty of the form, sheer form or the shape of the building which is there. That is nothing but the mega trend driven by the architecture, which is the free form and bionic design. So this is the mega trends which are there. Oh, by the way, I missed out. When you reach inside your hotel, your wristband pings you. Congratulations, you have taken off your calories for the day. So that is nothing but the AI and the real-time data. So these are all 5 mega trends which are there and which are driving us today. And I want to emphasize that Shuko is working in and contributing in all of these 5 trends. We are there and we are taking or working towards each of these mega trends. Today I will be focusing on the sustainability aspect of the mega trends. Now this is another topic. Sustainability is a very hard nail or hard concept to drive on. One can argue it is a circularity, what we are discussing. At the end of the life, what happens with the material can be define sustainability, whereas one can argue the amount of energy consumed or amount of carbon emitted defines the sustainability. So there are various factors. And I want us to rethink today what happens about the timber. Gautam has very nicely put and laid a pitch for me actually. So let us think how we can assess the timber on these parameters. Okay, so life cycle assessment. This whole life cycle assessment and tool, which is now available in hands of the engineers and architects, is playing or is become very important and gaining very importance nowadays. I would like to say that this initial operation part was considered or given very high importance earlier, but nowadays the research has shown that not only the upfront carbon, which is from cradle to the practical application part, the energy or carbon, whatever during that particular part is important, which contributes around 30%, as well as the lifespan in the use to the end of the life. That also plays a very significant role. So it contributes up to around 50% or 49% that sound of range. And at Shuko, we are not only striving to reach to this, we are trying to reach from this cradle. Sorry. It's going only front. So at Shuko, we are trying to not only reach from cradle to practical approach or cradle to grave, we are trying to complete the circle from cradle to cradle approach. We are trying to go, or we have the aim towards that. So what is the status of timber in this aspect? Timber is the only material which is carbon neutral or carbon negative. This happens because of the process of carbon sequestration. Timber actually entraps the carbon which is there during the photosynthesis process and stores it during its whole lifespan and keep it aside of the whole life cycle environment. That gives it a very unique advantage over all other building materials you can see. It's the only building material with negative carbon, embodied carbon. Then what about the embodied energy? Timber lies somewhere around 12 megajoules of energy per kg is required, whereas its counterpart are somewhere lying in the range of 5 to 20 times of the energy required. So that is where the advantage of timber which we are having. It's more easy for a designer to compare when it terms of meter per square instead of meter per kg. In that terms also, if a timber elevated floor is constructed, it is around 2 times, means any other concrete slab is 2 times the energy required for the timber flooring. So that's where the timber stands. It's only renewable material, primary building construction material. And another question asked from the sustainability, can it be engineered? So for any material to start its value chain or starts the acceptance journey, starts with it being used as a aesthetic for the purpose of aesthetics, then it switches towards it being used for the secondary primary structure or secondary structure, secondary load bearing structure, and then finally goes into the primary load bearing structure. So what is the status of current timber? Or the latest versions of timber, I would say. The latest versions of timber like glue lam, CLT, cross-laminated timber, they are already running. The earlier slide which I showed, they are already learning. They are already being used as a primary structure. They have initially, or timber is original from because of its cell structure. It has the anisotropic properties which will make it, which it takes the load more in one direction and another direction is kind of weaker. But these new versions of CLT, it's strengthened in other direction, so it can take for the another directions, or multi-axial loadings also can be taken with this type of structures. And this brings structure, these type of versions of timber also keeps alive the CO2 and all other factors, energy efficiency. Also it makes the structure, whole structure almost 80% lighter. So that all factors are also there. So this is also the, it's not that it was being used Kerala mein ya kahin pe it is only used for single residential story building. It's being used for bespoke industrial designs nowadays. This is another example where the CLT columns and roof slabs are present. This is an example of a timber hybrid structure where this is a Schuko product where the hybrid structure means primary structure is of timber and envelope is of aluminum. It was brought, this particular project, like the material requirement was brought down by 40% and carbon emission was brought down by almost 80%. So that's the impact. This is another multi-story structure. This is the second tallest structure. It's almost 80-meter high. So this is the inside of the structure, inside of that particular building in Sweden. You can see that not only the primary structure, the secondary structure here, the hand railings are also being used used for this thing. So what I'm trying to drive in, okay, there is timber, which is sustainable material. It's being used for primary load-bearing structure, secondary load-bearing structure, and we are not far from it being demanded for being used as into facades. And what do we do for that? Or this at Schuko, we have sensed it, that this may come, this need may arrive. So towards that, we have Schuko AOC system, which is Schuko AOC 50 Ti, which can accommodate or timber into the construction of facades with face widths of 50, 60, or 75 mm face widths. It can accommodate various thicknesses of glass. It can take the glass weights of up to 1100 kgs. It can take. It is specially designed glass carrier weights are there, which can take that high load of structure. So this is the product which I was trying to correlate with the trends, how we shifted from trends, we come into the necessity-driven things, and then we have this kind of a product which is already there. The sample is already outside. You can visit us and discuss more about it. So that's about the trends. These I will reread. These are the mega trends which are there. And the mega trends, we define it as which are related to us. Every one of us should be able to correlate. Then only we define it as a mega trend. So these are the mega trends which are there today. And Schuko is there in all these mega trends, innovating and using its futuristic technology to help us move forward in all the aspects which we strive for. So I will hand over now to my colleague Kushagra, who will discuss on freeform structure. He will primarily focus on what are the complexities brought in, and more importantly, how these innovations which we have envisaged, how it is connected to the reality, or how it is brought into reality. So he will take care of that particular aspect. Kushagra.
Hello. Yeah. Thank you, Omkar. Yes, so Omkar spoke about the innovations that is happening in real time in these mega trends. I will be speaking a little about how these innovations are getting converted into engineering reality. So we actually saw, like, there is a huge shift of people from tier 2 cities to tier 1 cities, and there is a lot of urbanization happening. There's a lot of tall buildings which is coming up, wider buildings which is coming up, and there is a lot of developments happening in the architectural field itself. So it's very progressive, and we will see how we at Schuko are innovating for these megatrends and how we are converting into engineering reality. So the story was actually built up in the morning itself from Mr. Jayesh, like what happened in the past 40 years. The architects which had the good bank and knowledge and principles, everything documented and then converted into reality only by doing some site experiments with the materials and the construction itself. The trend is changing. It is more getting digital. People are realizing that a small change that was supposed to be, if you were like 40 years ago, if you want to do a small change in the grids and lines of a plan or a building or a structure, then it was very difficult to anticipate how actually it will look like. But with the digitalization process itself, we saw that a small change can be incorporated really fast. Now the tools are available. The architects are really progressive in this field, and they can experiment, visualize, and then take a decision, conscious decision. And this is the reality what is happening. That's a Monte Carlo building. I would like to also specify a good example here, which is a parametric tower exploration by Nor Nicholas. Here you can see that each and every part, it's modular, right? And the architect has the freedom, all the freedom to play with it. So when they start playing with it, it becomes really complex for us, the engineers, because they have come up with so many options, which is possible, right? Looks great on 3D, on a screen or an artificial world, but is it really possible to execute this? That's the question, right? So we have a thought about it, and this is the background that happens. This is the Python script and the Grasshopper script. So the architectural world is moving really fast, and we, in the engineering field, we have to catch up really fast along with them. Now, AI has come into picture, right? And there is chat GPT and all those stuff. So what are we doing as engineers? So this complexity, what we were talking about, this has already reached the Indian shores. So we already have an example, right in front of us here in Ahmedabad. It's the IPL building, where the complexity was the angles in the facade system. So this is a Shuko building, by the way. And then there is another building on the right side, which is the Hilton Kathmandu. There the complexity was, it is convex and concave in the same facade, and the structure is progressive. It's convex and concave. And the challenge there, the complexity there, was to address this concavity and convexity in the same facade system. So that was complex. Then we also have another example which we are working right now. By the way, Hilton Kathmandu is under execution. The center building that you see is the new railway station, New Delhi railway station. The complexity there is it has geodesic domes, right, which is converging to a centric point. And that's the challenge. And that is what we are addressing right now. The thing is, again, I would like to point out is architects have the computational horsepower to innovate for the megatrends, right? The 5 megatrends that we spoke about. How do we engineer real-world systems for these designs, right? So things have become really complex, really advanced, very futuristic, very fluidic, I would say. So what do we do? So there was a good point mentioned by Mr. Jayesh in the morning that simplicity is the answer, right, for complexity. So what we at Shuko do is we see complexity from a different perspective. So what do? We basically do the same thing. We simplify the system. We break down the entire complexity, which is in a render or a model, and we break down into basic, simple systems. So these systems, and we address to these systems with the same intensity, like we are, working on all the systems in parallel. So the most important part is we saw the complexity that even Praveen mentioned in the morning about the wind zoning, right? So there is a building and there is a structure where we have done a calculation using IS 875 part 3, and when we did a wind tunnel analysis, the reality was very different, right? So the challenge is from the engineering side itself onto us, right? So there is a challenge from the architects to develop a system which is very fluidic or very freeform, very bionic, and the other one comes from us itself, maybe from a different department, right? So we need to look into each and every aspect and develop systems for it. This might correlate to what even Praveen was saying in the morning, like the wind zoning was done. So every part of the same building, even the most critical area can be the center part of the building, and the least critical area can be the top part of the building, right? So what do? How do we design a system for it? So there has to be a continuity or a flow in the designing process itself, where we are addressing the entire building structure as one, right? We cannot have different profile systems for different parts of the building, because aesthetically it has to look the same, and the depth of the frame has to be the same. Maybe the glasses will vary because of the various thickness coming after calculation for those typical areas. So in Shuko, what we have a large range of modular systems design that allows for customization and that are cost optimized. So we get into the each and every integrity, every node, every element, and we design the profile accordingly. This is another example of the same Hilton Kathmandu that we are talking about. The convexity and the concavity was addressed in the same system. And this was, by the way, designed for DFM and DFA that we were talking about, even Saleem and Gautam mentioned. not for DFE, I would say, because that was not there, and DFD not, because we didn't plan for it. But point noted, we will also look into those aspects as well. So this is just to emphasize, like, this is how we break down the complexity into really simple forms, and then the second system comes in. So we addressed one system, the second system comes in. Accessories, gaskets play a very major role in facade optimization and the performance, and it has to match the tender specification, the change in the environment that can happen after 50 years. So it has to have a long life, right? So here is one example of one complex structure, which we actually did an analysis. Mr. Mitul is also here. So this was done for his project. And then we found that, if the facade is inclined and then, converging at a corner condition, then how the drainage will happen. So we got into the integrity of that part. We modeled it, we analyzed it, we saw how the water is behaving in a controlled manner, right? We have to control the water, right? So we designed the entire system, where in worst case scenario, even if there is a mistake that has happened in installation, so it can be accommodated. So everything has been thought through, and then we go into designing of it. In the last, what happens is we integrate everything. So this was also one topic that came in the morning, that integration has to happen, right? This is exactly what we do. So we integrate all the different clusters that we have already addressed the complexity. We have simplified it, and then we are summing it up. So this is a basic integration that is happening. In order to assist the consultants and the architects, it's really important for us to do some visualization, right? So when this integration has happened, so we have solved some geometry for a skylight, for a corner condition, for a critical area, non-typical area, then what we do is we visualize it so that we are in concurrence with the architect and the consultants and agree, like, this is what is happening and this is what is being controlled. This is a system that will perform as per the requirement, and get a concurrence from them. Now, we saw something which is already existing, but we are talking about something which is really bionic. This is already an executed building by Schuko, and it's called Grid to Shell. And this is something which you might think like it's a facade, whether is it a skylight, but it is Grid to Shell. You can call whatever you want. So this is an already executed system. A sample of it is kept right outside, and we'll be more interested in having more discussions in this. Right, so now, that's the end of my presentation. I would like to hand over it to my friend Pratik. Sorry for the extra time. Thank you.
Hello, good afternoon, everyone. Thank you, Zak World of Façades, for arranging such a great event, and thank you, audience, for being present over here. Since my colleague Kushagra and Omkar already explained about the innovation trends and about the engineering capability of Schuko, I would like to discuss with you about how Schuko is capable to execute complex project on ground. So I would simply go and, as I have limited time, I will go and discuss about while we have too many outstanding buildings on the ground executed with complex designs, I have picked one of the project which is close to home, from close to Ahmedabad. Okay, the project is HN Safal's corporate office. This project looks elegant. It's a small building. Firstly, when the project inquiry came, I'm thankful to Blocher Partners and Facade Engineering Services, Mitul Gajjar, for trusting Schuko on this project. And then we met the client. The meetings happened in the COVID time, just one personal meeting, and we closed this order. And thank you for trusting us. Firstly, when we got this inquiry, we just saw that what is the project all about. It's a corporate office. It's a build-to-own project. They have sun shading fins. Fins are very long. The side hung openable required is to be inside. There were 9-meter tall opening, 9-meter tall facade, 6-meter tall ground floor facade, and all of that. I would just like to discuss the top 3 challenges which we faced and how we were successful in actually converting the architect's dream into reality and handling the complex design on ground. Okay, so this was the first challenge which we had, this designing the fins. Fins were 500 mm deep. The basic thing when we plan to design, as Kushagra explained, was we designed something which can be executed by the fabricator. So we designed the fin in two parts, we developed different dies for it and made it in two parts. The next requirement was it should be screwless. So we designed a cover cap in such a way that when the horizontal and the vertical fins are joined together, the caps are making it look elegant because the screws are not visible. And such a way we executed a great fin-looking project. The next challenge was to have a 9-meter unsupported facade on the top floor. Now, this was required to be having a fluid approach with the facade. So you cannot change the element completely. But yes, you had to integrate the unitized facade along with the semi-unitized facade. We imported the profile, a 250 mm deep profile. The insert profile is also supplied by Schuko, which can house an MS insert properly to achieve the right IXX and matching the complete facade concept. These are the raw pictures at the site at that time. You can have a look at it. This facade was executed by us. Then the next third challenge was a 6-meter facade at the ground floor. Now these days, 6-meter facade at the ground floor, making it in a 32 mm DGU glass with a toggle facade was a challenge, but the architect required the sleekest mullion possible. So we developed a sleekest mullion, which was 30 mm for the face width, and properly managed this facade, and it is installed. These are the pictures you can see. These are the picture on the left side. You can see the picture from the outside. On the right side, you can see the picture from the inside, and this was executed. The project is close to home. Same way, I just have 2 projects to show that how we have developed the profiles and everything. Here we had 2 challenges in this project from Pune. The curved facade along with that. Here we designed the mullion and transom in such a way that it could be bent. Okay, and the glass curved was possible. It could be bent, and the curve was made possible along with 25 mm stack movement. Now this movement is a very, very critical thing which people don't take in account, but we had a PMU to be done. We designed this profile, and now as we have ample amounts of design available, this is now a standard system available in Schuko's offerings. So we have already executed 2 projects with the same system. This project is very, very close to you, close to me as well, because it was my first project. I thank you is a very less word to INI Designs and FES for giving us chance in this project, and we proved our thing. Since 8 years, the building is standing tall, and we are so proud that we are associated with this project. The challenge was inclined facade, and we solved it. And the stall is outside, and you can anytime come and meet me and discuss about the AOC 50S timber, which Omkar discussed. We have the sleekest facade FWS 35 PD down also there, and the free form facade sample is placed over there. Please come and meet us at the stall. We are there and very happy to solve your queries. Thank you so much. Thank you.
Thank you so much, Dr. Powar, Mr. Awasthi, and Mr. Doshi for the presentation. Now I would like to request our next keynote speaker, Mr. Qutub Mandviwala from Mandviwala Qutub and Associates.
Hi, can you hear? Hi, good afternoon, everyone. Thank you for giving me this opportunity for this presentation. So I think we have seen a lot of technical presentations which have happened here. I will just run through what as an architect, the fenestrations, facades of different mediums, facades which can be of different perception from the exterior as well as the interiors can be perceived, and how these facades kind of make a piece of architecture different in different purposes and different climatic conditions and in different scales. So we start with a very small building in Ahmedabad, which is just on the outskirts, not very far from here. And here we see that this is a very small building which has standalone office building, which has been designed with the exposed concrete and with the facades which have been created as the simplest elements of facade, creating a play of light and shadow. So here we have just taken the exposed concrete and the glass, and we have taken this and started playing around with this to create a clear kind of a play. So the play and the facades, what we have been seeing from the last so many days is all about the exterior. But we also feel that the same facades and the perception of these facades from the inside plays a very important role. And depending on the scale, as I said, we have and we can create and use different mediums to create these different plays in facades. So this is how we have done this office, and this is how the facade plays. The facade is nothing but a composition of glass and concrete, and it has been played in such a way that throughout the day, none of the office areas require any light or use of any kind of power to work in these spaces. Then we have a beautiful building that we have executed in Dubai. So this is a corporate office for Vora in Dubai, where the building was facing dead on towards the west. Considering the heat and considering the climatic condition, we still wanted to have a landmark building, but the scale was such that we just had to create a horizontal kind of a play which was very interesting. So we created this facade which was of glass, but in front of the glass we created a jali which was created out of metal. And with the play of courtyards and the play of light and shadow which started getting inside, we started getting this kind of a beautiful building which had a very Indian look with the color that was used in standing in Dubai, and also had the concepts of this courtyards and the play of light and shadow inside. So we created this beautiful facade as a kind of external elevation, but with a perception of how this facade is going to react towards the inside spaces and to the office which is there inside. Then we also worked on a mosque in Kanpur. So mosque on the Kanpur was a very interesting small project that we had. And here we had a twisted cube which was there, twisting towards the west side. But on the north and the south, we started taking the light which started coming in. So here we use a different composition. Here we got the inspiration from one of the Islamic buildings in the country, and taking the jali which was there, but not able to replicate it in marble, we used the GRC as a facade element out here. So at some place it is concrete, some place it is metal, at some place it is an element like GRC, which resembles or which looks very close to what it looks when you look at marble and gives a semblance of that. But the feel is very different. And here on the north and the south facade, we use this beautiful jali to allow the natural light to come inside, and the play of light and the reflection of light with this beautiful perception towards the inside. So this is how we kind of created a facade where the east and west was totally solid, so as to block the light and the heat which was coming inside, looking at the extreme conditions of Kanpur. And then on the north and south, we use this facade as an element of design and also to create natural light inside the prayer areas. This is a school that we have done for Vora at Aurangabad. So here the elements and the concept was getting inspiration from the chiseled architecture of Aurangabad, which is the famous caves at the Ajanta and Ellora. And then taking this forward, we created a master plan. And we placed all the elements of the classrooms which were facing towards the north and the south. And we created the courtyards onto the east and the west. So here we took the nature, how to take that, how to capture the wind, and still how to capture a lot of natural light which was coming inside. And as you see, we chiseled the concrete again here and combined that with the glass to allow a play of light and shadow to happen inside. The concrete forms the good element of the facade out here, but the glass plays a very important role because all these classrooms, all these elements, or all these places require a lot of natural light which happens inside. So this is a classic classroom that we have created there, where you don't need any light throughout, but also the classroom does not have any sunlight directly coming in. So there is no need to cover off any of these windows, and there is no shadow happening inside the classroom. So this is how fenestrations, this is how facades are worked so as to create not only a look at the exterior, but the perception of the facade from the inside to add value to the spaces that you create inside on a functional and a spatial manner. Here is the admin building, and we had this beautiful ceiling where we punctured the concrete. Now the puncturing of the concrete gave us a new fenestration and a new facade. It became a dial throughout the day. So at every day when you walked in at different hours, you found different shadows which were falling down onto the ground. It created an interest. It created a digital program which was there on the floor, which became very interesting for students to work on. As you can see the admin building again, and you see that there are hardly any light fixtures because a natural light taken from the north and south without any direct sunlight makes it a good and a comfortable environment inside. This is a project which we have recently completed, and this is a government building. ECGC is Export Credit Guarantee Corporation of India, and we are a site where we have part commercial and part residential. And we have completed the commercial building, which is, it was a competition which we had won, and this is what we had perceived, where we had a building which was standing in the part of Mumbai at Andheri in a very prime location and facing towards the main road. Just like many important Indian buildings, the building was placed on a pedestal, and luckily we had a facade which was facing towards the north. So we had this whole north and south side facade which was created in glass, taking a lot of natural light coming inside the office complex. And the east and the west is all made up of these small fenestrations, creating a play of light and shadow inside. So this is what and how it looks as it is completed. As we see this building, and we see a parametric facade which is created here in this place. And the glass which you see in a very small area which is here in this place, this glass is a part of the atrium which stands on top. And we see this glass wrapping around from the north side, going over the ceiling, forming the skylight over the courtyard, and wrapping back onto the southern side. The east and west, as I said, is made up of these small fenestrations, blocking the heat that is coming in, but allowing a lot of light, and still a play of light and shadow on the inside spaces. And this is the atrium, where the glass starts from the north, goes up, and gets turned towards the southern side. This makes it a very interactive space, the whole office as a very interactive space. A lot of natural light taken inside, and making it a sustainable development without doing much on creating sustainability. So this is how we have created this parametric architecture, a piece of art on a government building, which is going to be listed as one of the iconic buildings in Mumbai in the recent times. This is Ahmedabad again, where just next to the Swati, we have done a building which is a small commercial of 45 meters height. So here again, we wanted to create a little play. So the play was created by creating these vertical black panels. These black panels are no cladding. So the building had a basic composition which was made out of stone and ACP, which was the cladding. But the glass was having this graphical panel where the dark panels are nothing but printing done on glass. So to cut out the heat again and to create a play inside the offices, we started creating a graphical panels where these panels, vertical panels, were all prints which were created, which gave an effect of a fabric sandwich between the glass. This was my first project in Ahmedabad, one major one, where I had done for Venus, the Venus Atlantis, which stands at Prahlad Nagar. I had an opportunity to create a glass facade. So here I used the metal as calzip, and along with calzip, I created this glass building. Again, I was very lucky that this long facade which you saw was facing towards the north. So looking at the climatic condition, it gave me an opportunity to create a glass building in Ahmedabad with the glass facade on the north side, making it comfortable for the people to work inside, not covering the glass with newspapers, curtains, and Venetian blinds, but allowing a lot of natural light to come inside. And then, since the building was long, I wanted to break it up into different parts. So I took this opportunity of slanting the facade down and creating the 2 blocks up front towards the road. This is a project which we are proposing, or we had proposed for KSIDC, another government building in Kerala. So here the idea was that looking at the heat and looking at the conditions, we thought that there was a play which was happening. And so we created a facade which was there in metal and glass, but the idea was more of a graphical design and to cut off the heat which was from the out to the in. This is a small club that we are doing where we are using the metal as zinc and creating a small clubhouse in a part of northern Bombay. So here we have the metal which is zinc. With that we have the metal jalis and we have the basic glass with claddings in Fundermax of wood. This is an interesting project which we have just started as work in Mumbai. This is the Liberty Towers, which is there at Mahalakshmi. This is going to be one of the tallest towers in Mumbai, approximately 300 meters and 150 meters. So here we are working on a facade, which is a simple building, but the glass as a concave glass, which is going to be there at the facade. This is a residential project that we are working on. This project is coming up again in the southern part of Mumbai, where we have a 270 meter tall building and a 220 meter tall tower here. So here you see that how we have worked on a residential building, where we have grouped the residential building into different parts. So in Mumbai, you have something known as the refuge floors, which come at every certain levels, and certain service floors which are mandatory at certain levels. So here is a composition of taking light inside, but still looking at the climatic condition of making a building which is there in stucco and simple glass with a glass windows which come in of good quality, and taking it and giving it a feeling of the tallness and the height which is there. We have commenced this project. It's already on the 10th, 11th floor, and we are looking at to go towards the sky. Similarly, we have a project which is coming up in South Bombay, which is the 2 twin towers. Again, here we have a 45-odd story tower building, where we are planning to clad the buildings in all the overall areas. And again, the grouping of the buildings have been done. So the fenestration has been worked out, looking at the functionality of the buildings and looking at how to break the buildings and the verticality in this manner. This is one of the interesting projects that we are doing. That is the redevelopment of the Bindi Bazaar, which is a cluster redevelopment of one of its kind in South Mumbai, where we are rehousing 3,200 families and 1,200 shops inside this. And in this, it is going phase-wise. So we have done the master plan. And the next that we are working on is the individual towers. Since these buildings stand in the southern part of Mumbai, and they are in the area where there is a lot of cultural importance. So here the facades have been done very differently. Here the facade has got your stone cladding, the GRC jalis. Again, very contextual to the surrounding that is there in that area. So till the height, so as the buildings there are in existing buildings were all around 24, 25 meters or 30 meters, we worked around the facade, which was very like connecting to the stone facades of the old buildings of Mumbai. And we took the again patterns of the architecture which was prevailing in that area and started working. So while the towers on top remained very simple, what happened at the level till 30 meters was very contextual to the surrounding areas and got connected very well to the city and to the scape which was around that. So you started getting something which is there where the facade on the top was a simple residential facade, but the lower facade was a dry cladded facade where we used stone, GRC and elements different to make it contextual and make a nice feeling to the building. Thank you.
Thank you, Mr. Mandviwala, for the beautiful presentation. We would now like to move forward with our panel discussion. I would like to invite Mr. Ashit Vora, who also is my father, to introduce the panelist.
Invite Mr. Kunal Patel from KMP Architects, Mr. Harshad Mistry from HM Architects, Mr. Tejas Kathiria, Mr. Vimal Limbard from Venus, Mr. Munir Shah from High Tech Engineers, and Shailesh Bhai from Patwa and Associate PMC. Please come on the dais. मेरे को मैनेजमेंट की ओर से बोला गया है कि आप तीनों लैंग्वेज में लोग कंफर्टेबल है, यहाँ हिंदी, गुजराती और इंग्लिश जिसको जिसमें बात करनी है कर सकते हैं. तो आई एम प्रिफरिंग हिंदी. मैं आपसे हिंदी में क्वेश्चन आंसर करते हैं. थोड़ा जो डिस्कशन अपने है वो सबसे पहले हम लोग टाइम को देखते हुए थोड़ा फास्ट इसको आगे बढ़ाते हैं कि फसाड कंसल्टेंट, what are the criteria for appointment of facade contractor for the project. कोई भी प्रोजेक्ट में फसाड कॉन्ट्रैक्टर को जब आप हायर करते हो तो उसके लिए क्या क्राइटेरिया होना चाहिए. तो मैं शैलेश भाई से बात करता हूं कि जरा एज अ पीएमसी आप कुछ डिस्कस चालू करें उसके ऊपर जवाब.
एवरीवन, आई थिंक ऑल आर टेक्निकल पीपल हियर. मेरा अभी पीएमसी का रोल रहता है कोई भी प्रोजेक्ट में. तो जो मैं फील कर रहा हूँ वो जस्ट आपको ब्रीफिंग कर रहा हूँ. कोई भी अभी जितने भी आइकॉनिक बिल्डिंग्स आ रहे हैं, जितनी भी हाई राइज बिल्डिंग आ रहे हैं, फसाड इज मोस्ट इम्पोर्टेंट. नाउ वी आर जो भी फीलिंग कर रहे हैं अभी, तो कोई भी प्रोजेक्ट में आर्किटेक्ट्स कोई बिल्डिंग डिजाइन करता है तो उसमें फसाड बहुत बाद में आता है. पहले स्केलेटन डिसाइड कर देते हैं, एक थॉट प्रोसेस में आता है. जब हम लोग एग्जीक्यूशन करने जाते हैं तो फसाड कॉन्ट्रैक्टर से लेके हमारा भी मतलब बिल्डर की तरफ से भी हम लोग जो अपेंड होते हैं उसमें कॉस्ट और सेफ्टी मेजर सब कुछ देखना होता है. तो आई थिंक मेरे को ऐसा लगता है कि आर्किटेक्ट्स से पहले मतलब जो आर्किटेक्ट जब बिल्डिंग डिजाइन करे तभी फसाड कंसल्टेंट ऑन बोर्ड होना चाहिए. तो फसाड इज मोस्ट इम्पोर्टेंट ऑफ द बिल्डिंग. बाकी तो हर्षद भाई और आर्किटेक्ट बता सकते हैं क्या इसमें इम्पोर्टेंट रोल रहता है.
मैं आर्किटेक्ट को भी अभी पूछना चाहता हूं कि भी डज द आर्किटेक्ट हैव अ रोल टू अपॉइंट द फसाड कॉन्ट्रैक्टर.
See, again, building is a kit of parts, like many people earlier said. और ये kit of parts को एक final form देने के लिए there are lot many agencies involved. When there are multiple people playing multiple roles on a project, so you need one person who acts as, like we used to say formally at HCP, कि एक कंडक्टर चाहिए पूरी ऑर्केस्ट्रा के, हर एक अपना बाजा बजाएगा, but you need one conductor, and I think that one conductor, the conductor's role is best performed by the architect. So, and the architects must also see themselves as a facilitator, as a negotiator, and a mediator sometimes for the appointments of these various agencies. So yes, architect का एक बहुत महत्वपूर्ण role रहता है, कोई भी, not only facade but कोई भी agency को identify करना, select करना, criteria set up करना, so that selection ठीक से हो.
लेकिन अनफॉर्चुनेटली हमारे सिटी में तो ये नहीं है, अहमदाबाद में.
हेलो.
यस सर भाई.
मैं मेरी ओर से अगर बात करना चाहूँगा तो एटलीस्ट सी बेस्ड ऑन माय पास्ट एक्सपीरियंस, शायद पिछले 3-4 साल में मैंने कुछ ग्लास बिल्डिंग डिलीवर किए, और लकीली जिनके साथ काम किया, जो कॉन्ट्रैक्टर थे, जो फसाड मेकर थे, रादर जो इम्प्लीमेंटर थे, वो सब मेरे साथ बैठे हुए हैं, राइट. तो यू नो आई एम श्योर इधर से मैं कुछ बोलता हूँ तो सामने जो लोग बैठे हैं, यू नो, आफ्टर ऑल एवरीथिंग इज ऑल अबाउट यू नो आर्किटेक्चर. तो जब फसाड या स्किन या यू नो एस्थेटिक डिसाइड होता है तो सीधा ही आर्किटेक्ट है ना, उसका 3D विजुअल्स लेके एक इम्प्रेशन क्रिएट करता है कि ऐसा कुछ बिल्डिंग बनेगा, ऐसा कुछ यू नो उसका एलिवेशन आएगा. लेकिन उसको रादर मेरे को एक अंदर एक डाउट रहता है कि व्हाट इफ रेंडर्ड में जो आ गया और वो अच्छी तरह से इम्प्लीमेंट नहीं हुआ, तो आई एम श्योर आप सबको भी पता है कि ना अपने सराउंडिंग में जो रेंडर्ड इमेज में बिल्डिंग दिखता था वो एग्जीक्यूशन के बाद वो इतना अपीलिंग नहीं लगता. तो जब भी हम कुछ कॉन्सेप्चुलाइज करते हैं तो एटलीस्ट एक अंदर से एक डर तो रहता है कि ऐसा क्या इसके अंदर यू नो सबको सबकी हेल्प लेके, रादर पूछ के, रादर यू नो 3D के अंदर डेप्थ में कुछ ऐसे इम्पोर्टेंट कंपोनेंट डाल दूँ जिसके कारण है ना मेरा बिल्डिंग एटलीस्ट जब मैं उसकी ओनरशिप लूँ तो वो जो जैसे बनने वाला है ऐसा ही दिखेगा, वो मैं एटलीस्ट बोल पाऊँ. तो उसके हिसाब से देखें ना तो जैसे स्ट्रक्चर, इलेक्ट्रिकल, प्लम्बिंग कंसल्टेंट को बाय डिफॉल्ट हम लूप में रख के चलते हैं. तो नाउअडेज यू नो आर्किटेक्ट का खुद का एक जजमेंट होना ही चाहिए कि वेदर वो क्लाइंट अपॉइंट करे या ना करे, राइट. डे 1 से फसाड कंसल्टेंट, रादर फसाड फैब्रिकेटर, रादर इम्प्लीमेंटर, रादर मेरा तो ये प्रैक्टिस है कि एक बार फसाड कंसल्टेंट ने अपनी स्किन दे दिया तो उसको मॉडल में डालते हुए मैं फाइनली उनको अच्छे कॉन्ट्रैक्टर को भी पूछ के यू नो दोबारा कंफर्म करके उनके रिवर्स फीडबैक लेके यू नो फसाड कंसल्टेंट को चेस करता हूँ. और आई एम श्योर मतलब नाउ ऑनवर्ड्स मेरा तो ऐसा है कि बेस पे वो क्लाइंट यू नो फसाड कंसल्टेंट को हायर करे ना करे, बट यू नो फसाड मेकिंग रादर आर्किटेक्चरल स्किन को मार्केट में लाने से पहले उसकी खुद की रिस्पॉन्सिबिलिटी बनती है कि यू नो ये सब एक्सपर्ट को इनकॉर्पोरेट करके साथ में चले.
हेलो तेजस भाई, मैं ऑडिबल? Yes. Okay. All right. So when we design buildings and when we be it ground structure, G+1 or the high-rise buildings, facade is something which speaks our design. So जो building के अंदर का जो planning वगैरह जितना भी रहता है, so facade is something a sort of a skin basically. It is a skin which communicates with the outer surrounding, outer world. So to ensure that what we have designed inside should be translated and transmitted correctly, we need these measures. कि facade consultants होना चाहिए, जो हमारा जो idea है, it needs to be translated properly the way we have imagined with the stakeholders के सारे जितने भी opinions लेके what we have designed, जब वो बार बनता है, so that objective को achieve करने के लिए we need consultants, we need apt contractor, and that is why we as an architect feel that we should be involved, and we are. I mean, it's not as if we are not involved, but we are equal stakeholders when we design or when we decide the facade fabricators and the contractors?
अभी तीनों आर्किटेक्ट की हमने राय जानी। नॉर्मली फसाड कॉन्ट्रैक्टर हमारे सिटी में जिस हिसाब से फाइनल होता है तो बिल्डिंग ऑलमोस्ट आधे से ज़्यादा ख़त्म हो जाने के बाद उसको इनवाइट किया जाता है। ये नॉर्मल प्रैक्टिस है, लेकिन मैं बात करता हूँ केबल नेट पीटी केबल वाले स्ट्रक्चर है आपके पास, तो कास्टिंग चैनल वगैरह बहुत शुरुआत में डालनी पड़ती है। तो जो कॉन्ट्रैक्टर बहुत शुरुआत से जब सिविल का आप अवॉर्ड करते हैं जिसको भी, उसके साथ आप फसाड कॉन्ट्रैक्टर को भी साथ में अवॉर्ड कर देते हो तो ये प्रोजेक्ट बहुत इजी मोड में जा सकता है, ऐसा मेरा मानना है। आप क्या रसद भाई बोलते हो?
नाउडेज अहमदाबाद में काम करना मतलब ऐसा है कि आर्किटेक्ट को भी वो टेक्निकल नॉलेज ध्यान में रखते हुए जाने का, पीएमसी एक्सपर्ट साथ में, लेकिन है ना वो आके एक बार तो पूछते हैं कि साहब आपका क्या ओपिनियन है, आपका क्या राय है, तो एटलीस्ट एक बार वो कंफर्म करते हैं कि इन्होंने पूरा ढांचा जो बीओक्यू में डाला है और जो एग्जीक्यूट करने हम जा रहे हैं उसमें उन्होंने ऐसे कंसर्न और केयर या इंजीनियरिंग को ध्यान में रखा है कि नहीं। यू राइटली सेड पूरा का पूरा ढांचा क्लियर हो जाता है, लेकिन एक छोटी डिटेलिंग भी अगर कॉम्प्रोमाइज़ कर दी ना तो वो नेवर एंडिंग प्रोसेस बन जाता है। तो आई स्ट्रांगली रिकमेंड, फाउंडेशन की तो बात छोड़ो, लेकिन जब उसकी है ना फाइनल स्ट्रक्चरल सिस्टम इस्टेब्लिश भी होती है तो उस टाइम पे जिस तरह से हम बिल्टेबल कंपोनेंट को ध्यान में रखते हुए कॉन्ट्रैक्टर को लूप में लेते हैं, सेम विथ फसाड कंसल्टेंट या फैब्रिकेटर को भी अपने फिजिबल फीडबैक को इनकॉर्पोरेशन के लिए उनको लूप में रखना बहुत ज़रूरी है।
Hello, I am not an architect nor a PMC guy, but from my experience I can just tell, while designing the building, normally the critical portion is the openings. So while you are, if you have designed opening, you should have the basic knowledge from the facade consultants, which are the limitations in sizes. So accordingly, you can plan your elevations or designing. So I think the role of consultants, facade consultants, is with the start of the project is very essential according to me.
I think it is largely dependent on how we think as architects also. We think if, as architects, we should think of the building in totality. Once you think of the building in totality, पूरा building को एक ढांचे में देखते हैं, so then you will also think of all the components. सभी components का आप पहले से सोचें. Primarily right now, facade is seen, and even in the way we speak right now, it is seen as a skin. It is seen as something that is coming on at a later stage. That is why it is ignored in the earlier stages of design. It is not a skin. A critical component of the building, as important as the columns, the slab, the beams, the foundations. And once you start thinking of that, you will ensure that just like you bring the structural consultant on board, you will also think about the facade consultant, the facade contractors, the materials, the systems, everything. So I think as architects, we need to think differently. And as clients also, I think that demand should also.
Yeah, can I summarize the developer's perspective on this? At Venus, we have been delivering buildings, iconic buildings with great facades. Recent example is the Stratum, where it can serve as a gallery for different kind of facades. So we firmly believe that we need to have a proper facade consultant on board to transform the vision of the architect, what he has done, and understand the costing and the technical aspects of the things also. And while going for the facade contractor, we all have the standard PQ for contractors, but beyond that, we need to see at the capacity to deliver and the local availability. So I think now the Gujarat has started seeing the local vendors who have their own factories and who can deliver and who can match the quality of the national and international standards. So that is a one added advantage now. And the other thing, the developers also need to start developing some in-house capacity on the facade system so that they can get delivered from the architect consultant and the contractor, what exactly their vision is.
Thank you. हेलो या डेवलपर लोग भी साथ में जो कॉन्ट्रैक्टर लोग भी है, सिविल कॉन्ट्रैक्टर, मैं एक क्वेश्चन पूछना चाहता हूँ कि यार प्रोजेक्ट मैनेजमेंट टीम की अगर बात करें तो वो डेवलपर के स्कोप में प्रोजेक्ट टीम होनी चाहिए डेवलपर के पास, या आउटसोर्स करना चाहिए पीएमसी जैसे शैलेश भाई और बाकी लोगों को हायर करते हैं वैसे?
At least you need to have one person who understands facade. So then only he can be a mediator or a person who deals with everybody, architect, facade consultant, contractor. And of course, for the implementation of the facade or the construction of the facade, definitely you need a PMC who expertises in facade, or a resource from the facade consultant himself, so that all the technical aspects and the QC aspects are taken care of. And you need to do a lot of testing also. Sometimes a lot of people do a lot of facade, but testing is always forgotten. That's unheard of things right now. But going forward, we need to give proper attention to the QPC part of the facade also.
I think the developer's person should be there for the coordination, sequences, and the technical person should be from the external PMC or from the facade consultant. So he can look after the sequences which will come first. Accordingly, the developer person can resource other agencies, resources and the other requirements like RSP, everything. So it should be in the sequence. Otherwise, it will be redoing and that it will be waste of the time. So external agency or the expert in this particular subject should be there, either is outsourced or from the facade consultant or hired by the developer.
Thank you.
Yeah, इसमें again in-house, if one has in-house teams, there is always वो एक either एक specific aspect के ऊपर focus ज़्यादा रहता है. So if you have, for example, if the developer has their own in-house team, so perhaps cost pressure to deliver within the cost, time pressure. So काफी चीजें वो दो specific चीजों पे ऊपर focus रहने की वजह से compromise हो सकती है. In the sense that, it's if an external agency is doing the coordination or the supervision, then the aspects of that particular component gets its due focus. Whether it's the quality, whether it's the the appropriateness of the engineering, the testing procedures. Of course, cost and time also the PMC is supposed to look at. But in-house there is a tendency of leaning towards perhaps one particular aspect rather than the whole thing in totality.
Yes, Vicky.
Hello. So I'll add, if we have, let's say, a PMC which is in-house with the developers, so with the past experience which we work with different developers and consultants, we figured out if they have in-house PMC, they have direct control over, or maybe they have this culture. I mean, they know the culture of that organization, the way this developer has the vision and how his engineering and PMC team will be in sync with that vision. So that is a good part. But the moment when you want to scale up your team, that is added load or added, how can I say, time you have to spend to train them, to hire those kind of engineers and PMC guys with certain expertise. If you outsource it, so then it's a different window altogether. We have different expert in PMC where you don't have to invest. I mean, you just hire them and they'll do the remaining part. So for me, if we hire somebody from outside, it would be always an added advantage with, as Vimal Bhai suggested, it's somebody in-house who will monitor everything.
पीएमसी को बाहर से हायर कर रहे हैं तो उसका क्या रोल होना चाहिए फसाड के लिए पर्टिकुलरली? और शैलेश भाई आप भी जरा बताएं कि नॉर्मली पीएमसी आप करते हो तो आप क्या क्या क्वालिटी मेजर्स वगैरह स्टैंडर्ड्स देखते हो और किस तरह से आप फसाड को इवेल्यूएट करते हो?
एक क्वेश्चन है ना, बिल्डर के लिए था। बाकी तो मुझे तो ऐसा है कि मैं एज ए पीएमसी कोई भी प्रोजेक्ट में हूँ तो मैं बेस्ट ऑफ बेस्ट देता हूँ। तो उसमें क्या है कि वैल्यू इंजीनियरिंग से लेके बिल्डर के स्कोप में, इवन आर्किटेक्ट के जो भी थॉट प्रोसेस है उसको हम कैसे कंप्लाई करें, वो हमारा रोल रहता है नॉर्मली। और जो कॉन्ट्रैक्टर एग्जीक्यूशन कर रहा है, जो भी एप्लीकेटर है, उसके साथ डे एंड आउट, मतलब 24 आवर्स जो भी उसका जो भी प्रोजेक्ट में काम है, कुछ भी हडल्स है, तो हम लोग ऑन साइड रहते हैं। अदरवाइज आप कोई बाहर से हायर करते हो तो आई थिंक रिजल्ट नहीं मिलेगा। जो मेरे अभी 5-10 साल का जो भी फसाड का जो भी एक्सपीरियंस है वो मैं समझता हूँ, शायद आपने भी फील किया होगा, बरोबर। तो बाकी तो बिल्डर का स्कोप है, कैसे नक्की करना है, पहले करना है बाहर से करना है। मैं तो बोलूँगा हमको पहले से बुलाओ, ठीक है
विमल भाई?
I think what I said कि मैंने जो बताया था कि see from builder side I said that you need one person or somebody who understands the facade, not the you need experts to execute, you need experts to monitor, so that is without doubt. But sometimes you have to check that the people don't go overboard in terms of design also and in terms of cost also. So for that the developer will definitely like to intervene, not to compromise quality.
अर्षद भाई, आपको स्माइल कर रहे हो, कुछ बोलना चाहते हो ऐसा लग रहा है।
जैसे अभी ये डिबेट चल रहा है तो मीनवाइल मैं भी सोचता था कि कोई मेरा डेवलपर भी है, मेरा कॉन्ट्रैक्टर भी है और मेरा फसाड एक्सपर्ट भी सेम प्रोजेक्ट पे, मैं आर्किटेक्ट हूँ, इस तरह से साथ में बैठे हैं। तो एटलीस्ट मतलब इस चैट में मैं अंदर से यही अपने आप को पूछ रहा था कि बिल्डिंग डिज़ाइन तो हो गया, बाहर दिख भी गया, लेकिन मैं और मेरे अलाइड सपोर्ट सब साथ में मिलके जो बताया ना उसको किस तरह से लेके आए ना, उस हंट में लगे रहते हैं। कभी कभी वैल्यू इंजीनियरिंग आती है, कभी पीएमसी आती है, कभी कॉन्ट्रैक्टर के कंस्ट्रेंट आते हैं, और इन सब हंट में साइड पे देखा जाए तो स्लैब पे स्लैब लगते ही जाते हैं। तो एक डायलेमा ये रहता है कि ये लोग कहाँ अटकेंगे, कहाँ कंक्लूड करेंगे, कौन कोई क्लियर बात बता नहीं रह सकता। सब एक दूसरे की रिस्पेक्ट करते 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 आगे डेवलपमेंट स्लैब टू स्लैब लगता ही जाता है। एक चिंता अंदर ये रहती है कि ये लोग कहीं अटक के विदाउट एनी हिपोक्रेसी डिटेलिंग इंजीनियरिंग को अगर कंक्लूड करे और एस्थेटिक या आर्किटेक्चर के साथ उसको फ्यूज आउट करके वो क्लैरिटी मतलब वेल इन एडवांस पहले से ही दे देते हैं। तो आई एम श्योर राइट, वो क्लैरिटी के देने के प्रायर स्पैन के लिए जो कोई एक्सपर्ट्स अंदर इन्वॉल्व करने होते हैं ना, वेदर इट इज सिमुलेशन, क्रॉस चेकिंग, देन विंड सिमुलेशन आता है, इंजीनियरिंग आता है, मटेरियल टाइपोलॉजी आती है, ग्लास सिलेक्शन आता है, इंसर्ट्स आते हैं, गर्डर्स आते हैं, राइट। वो बहुत डे वन से अगर डिसाइड करते हुए देन उसको एक साथ में ग्रेसफुली आगे बढ़ाया जाए तो शायद मैं मेरे नेक्स्ट प्रोजेक्ट से ही इसको चिंता से फ्री होते हुए उसको इम्प्लीमेंट करने का क्राइटेरिया एस्टेब्लिश कर पाऊंगा। अभी इस डिबेट में एटलीस्ट मैं तो ये एक्सपेक्ट करके जाता हूँ कि यहाँ से उठ के एटलीस्ट मेरे को एक क्लियर थियरी रहेगा कि फाउंडेशन से स्टार्ट होते पहले पीएमसी, डेवलपर के साइड से एक्सपर्ट, फसाड कॉन्ट्रैक्टर, फसाड कंसल्टेंट, वो सब कुछ एक साथ में होते हुए कुछ ऐसी गाइडलाइन इस्टेब्लिश करे कि जो हम सबके लिए काम आए, राइट।
गुड सजेशन, वेरी गुड सजेशन। ये फसाड्स फेल होती है तो उसके लिए नॉर्मली रीज़न क्या होना चाहिए, और ये शैलेश भाई आप भी बहुत अच्छी तरह से बता पाओगे कि उसमें लैक ऑफ सुपरविजन है कि इनकरेक्ट डिजाइन स्पेसिफिकेशन है।
अभी आपने लगभग आधे घंटे पहले डिस्कशन यही बात पे हो रहा था, तो मेरा मानना ऐसा है कि जो भी फसाड फेलियर होता है उसके पीछे बहुत सारे पैरामीटर्स है, या सिविल वर्क में होते हैं या जो एग्जीक्यूशन हुआ उसमें भी हो सकता है। पर ओवरऑल हमारे पास इन अहमदाबाद कोई लैब ऐसा नहीं है कि अपना टेस्टिंग पैरामीटर मिले। आपका मटेरियल कितना भी अच्छा हो, उसका फिक्सिंग कैसे करते हैं और उसके पीछे जो भी फिक्सिंग आरसीसी के ऊपर हुआ है या एमएस फैब्रिकेशन पे हुआ है, उसका क्वालिटी पैरामीटर का अभी यहाँ ऐसा कुछ है नहीं। जैसे कि अहमदाबाद या हैदराबाद या बेंगलोर में शायद होगा, मेरे को ऐसा पता है, मुंबई में तो है। तो वो सब पहले लाना पड़े, इसके बाद अपने पैरामीटर चेक कर सकते हैं। अदरवाइज हमारा एक्सपीरियंस बोलता है कि भाई इसमें ये करो तो अच्छा है, अदरवाइज नहीं करो तो अच्छा है। तो वो जो भी है ड्यूरिंग कंस्ट्रक्शन ही होता है, उसमें फेलियर का अभी कुछ स्पेसिफिक नहीं बता सकते।
I think failure, two types. One is design failure, second is execution failure, workmanship failure. Design failure, if we consider as architects and consultants together, I think that can be minimized. And for the execution failure, currently the play for say 100 meter, 120 meters, what is play? 30 to 40 mm?
50 meters
50,
max.
50. So the structure should be proper in plumb and line, so that they do not have to make more adjustment. So according to me, the structure should be very much in proper line and level, first point. And then the major failures are for the operation failure, means after in the monsoon the leakage failure is there. If you want to change the glass later on, how you will do it? So that is at the item design we can rectify it, or with proper workmanship. But how to check the workmanship, that just Shailesh be told. There are no proper guideline for that and no proper laboratories for that. So that should be we can even opt for that also.
I think I'll add something here. So I mean, as we mentioned about the failure of the facade, I think I would categorize into like 4 or 5 segments, where one would say the poor design is something which is the biggest concern which we see in facade failures. If it is not designed according to the environment it's going to be sitting in, or the kind of joints we are not aware of, kind of openings, as he mentioned earlier, if as a designer, as a consultant, we are not aware. So a lot of self-education needs to be there as far as the consultants and the designers, architects are involved. So that needs to be there. Then sometimes we select, as a design thrive or design drive, we select inadequate materials. So that is one of the biggest concern which I have seen over the time, where the facade is termed or is tagged as a failure facade. Lack of maintenance. We forget that we build, we design, we sort of make buildings with very fancy facades, but at the same time, they are not maintained properly. So it pani aa jata hai, leakage hota hai. So those all kind of issues should be taken care of. And probably the poor project management while the execution part. I mean, I would categorize in a way that these 3 or 4 concerns, if we can take care of, I'm sure there will be lesser chances of a facade failure.
Kunal bhai?
So again, as architects, we have to understand that the building is still, majority of our buildings एक wet process of construction में follow करते हैं. So it is a on-site, in situ kind of process, which will have its own tolerances, errors and sequences, onto which this large component, a very important component, comes prepared, manufactured, factory manufactured, precise, with its own joinery. So like you were saying that at the design stage, the architects and the consultant structure need to come, and the facade consultants need to come together to ensure that appropriate detailing and tolerances are built in design. That is the first aspect. From the client side, timelines are always a pressure. So sometimes, abhi to plot aaya nahi hai, or, foundations chalu karne hai. So that also puts pressure that the due time or due diligence on critical aspects the consultants don't have. So we don't have it, and we don't allow our sub-consultants to do it. So that is another aspect. Third is that when the appropriateness of choice, so whether ye building, ye orientation, ye scale of opening ke liye ye right technology hai, ye right choice of the system hai, वो भी एक सेल्फ एजुकेशन की भी बहुत important aspect. So all of this needs to come together for that. And then of course the maintenance, I think as an industry, forget the facade, as an industry, whether it's roads or buildings or anything, we don't believe in maintenance. So as an industry, we need to start looking at maintenance also as a very critical component of the life cycle of design, especially now if you're talking about not the linear and landfill process, but a cyclic process. So to ensure that the degeneration of materials don't happen, I think maintenance will play a very, very critical aspect in that also.
Last very important question also is there. How can a project be delivered on time?
और कैन बी कंप्लीटेड ऑन टाइम, क्योंकि 2-3 बड़े एस्पेक्ट है. सबसे लास्ट में आ रहा है फसाड वाले का काम. और काफ़ी कॉन्ट्रैक्टर मेरे क्लाइंट्स हैं, मैं फसाड कॉन्ट्रैक्टर तो मैं बोल सकता हूँ, हमको देखते ही बोलता है फसा कॉन्ट्रैक्टर, वो बोलता है फसा, क्लाइंट भी बोलता है फसा, कॉन्ट्रैक्टर भी बोलता है. फसाड को फसा हिंदी वर्ड में बता रहा है वो, कि ये स्टेज आ गया तो या हम फंसेंगे या आप फंसोगे. तो ये टाइमली डिलीवर्ड करने के लिए क्या होना चाहिए, मैं मेरी राय भी बताऊंगा. मैं शैलेश भाई से भी पूछता हूं कि आपको क्या लगता है कि कैसे ये प्रोजेक्ट को हम एक्सपर्ट फास्ट कर सकते हैं और फास्ट ट्रैक पे टाइमली कंप्लीट कर सकते हैं.
जो अपना पहला क्वेश्चन था उसका ही आंसर मैं देता हूँ कि आर्किटेक्ट जब भी ये थॉट प्रोसेस स्टार्ट करता है तो फसाड कंसल्टेंट ऑन बोर्ड होना चाहिए. उसी टाइम अपने वैल्यू इंजीनियरिंग करते हैं कि भाई कैसे मॉड्यूलर में डिजाइन हो कि इजीली काम स्टार्ट हो सके. उसका जो भी मटेरियल है, जैसे कि ग्लास है, उसका इजीली अवेलेबिलिटी है कि नहीं, वो सब चेकिंग पैरामीटर के बाद अपने जब स्ट्रक्चर खड़ा होता है तो ही टाइमली कर सकते हैं. अदरवाइज अपने यहाँ मल्टीपल एजेंसी काम कर रही है, डेफिनेटली इधर फेस्टिवल भी ज़्यादा है तो वो तो टाइम लाइन में एक्सटेंड होता ही रहता है. पर ओवरऑल मैं ऐसा समझता हूँ कि आर्किटेक्ट जब डिज़ाइन करता है उसकी थॉट प्रोसेस चालू होती है, तभी फसाड का फाइनल डिज़ाइन कंप्लीट होना चाहिए, तब मॉकअप फाइनल होना चाहिए. अदरवाइज ये पॉसिबल ही नहीं है इन इंडिया, इन अहमदाबाद.
प्रसाद भाई.
राइटली सेड, इट्स रियली डिफिकल्ट टू से कि ये कितने टाइम में ख़त्म होगा. अभी आपका स्टेज आया, अभी उनका स्टेज आया. बीइंग एन आर्किटेक्ट हम लोग जब 2 स्टेज फ्यूज होते हैं, स्किन और सिविल स्ट्रक्चर, तो मैं इतना बताना चाहूँगा कि एटलीस्ट आर्किटेक्ट का वो सोल रिस्पॉन्सिबिलिटी बन जाता है कि जो भी कंस्ट्रेन या जो कुछ भी अभी एस्टाब्लिश होकर सिनारियो सामने आए, तो उसके अंदर वो खुद की डिटेलिंग को एनहांस करते हुए किस तरह से उसको सक्सेसफुल बनाए. तो आई थिंक उस क्लैरिटी पे ज़्यादा डिपेंड करेगा. दोनों सोल एजेंसी को रैपिडली एफर्टलेसली काम करके टाइम फ्रेम पे मैच होना. एंड શૈલેષભાઈની વાત સાચી છે કે ડે 1 થી કદાચ એ ક્લેરિટી આર્કિટેક્ટ આપી શકે, રાધર એ કન્સ્ટન્ટ આઈડેન્ટિફાઈ થયા પછી એ સોલ્યુશન આપે અને પોતાના આર્કિટેક્ચરલ પરસેપ્શનમાં એ એડિટિંગ કહો કે પછી એડેપ્ટિવિટી કહો એ ઇન્કોર્પોરેટ કરતા ચાલે, ડેવલપરને કન્વિન્સ કરે, તો આઈ એમ શ્યોર ઘણા બધા પેરેલલ સ્ટેક હોલ્ડર્સ માટે ઇઝ નો પોઈન્ટ બની રહે.
हम लोग अगर ये बात करें कि उसको टाइमलाइन में कैसे फास्ट हो सकता है, तो मैं सबसे पहले बोलता हूँ कि अगर क्लाइंट ने फसाड कंसल्टेंट को हायर किया है तो फसाड कंसल्टेंट ये रोल बाखूबी निभा सकता है. उसको पता है कि फसाड लेट क्यों हो रही है, क्योंकि बीइंग ए कंसल्टेंट उसके एक्सपीरियंस से वो बोल सकता है. हमारा जो आज तक का एक्सपीरियंस है, सबसे ज़्यादा वेराइटी ऑफ ग्लास की साइज़ वगैरह में अलग अलग साइज़ के पूरे फसाड में ग्लास दिए. नॉर्मली एक फसाड है तो स्टैंडर्ड साइज के ग्लास देके रेसिड्यू देना चाहिए, लेकिन बहुत अलग अलग साइज के ग्लास आते हैं. तो तभी होता क्या है कि हमको आगे बढ़ना है, बीच में एक ग्लास की साइज कहीं मिसिंग है या ब्रेक हो गया लास्ट मोमेंट, तो उसके लिए 10-15 दिन रुक जाते हैं हम लोग. तो ये जो स्टैंडर्डाइज कर सकते हो, क्योंकि नॉर्मली अंदर की आपकी जो ऑफिस का लेआउट है वगैरह की वो भी वो हिसाब से डिज़ाइन करना पड़ेगा. क्योंकि ऑफिस छोटी बड़ी है तो मलियन ऑफिस की वॉल के सामने आना चाहिए वगैरह वगैरह रिक्वायरमेंट रहती है. तो उसकी लिए अगर ग्लास की साइज स्टैंडर्डाइज हो गया तो कोई भी फसाड प्रोजेक्ट मिनिमम 30% टाइम सेव कर सकता है. ये नहीं, रेसिड्यू तो आएगा ही आएगा.
हेलो हेलो
या सॉरी फॉर इंटरप्शन। ग्लास की साइज सेम होने से क्या होता है कि ड्यूरिंग कंस्ट्रक्शन हमको कोई भी ग्लास चेंज करना है या कुछ भी मेंटेनेंस है वो इजीली होता है।
ये एडिशनल एडवांटेज है।
अदरवाइज हम लोगों ने अब 1-2 प्रोजेक्ट किया है, बहुत फेस किया है, और यही फसाड में मतलब सेम मॉड्यूलर टाइप के ग्लासेस साइज निकलता है एज ए आर्किटेक्ट थॉट प्रोसेस में, तो सबसे अच्छा रहता है। तो कोई भी बिल्डिंग डिजाइन मेरा सजेशन रहेगा अरशद भाई को एटलीस्ट साइजेस एक रहे, तो मतलब इजीली हम लोग
अरशद भाई, तेजस भाई, दोनों को
I think what I'll like to respond the way the discussion is going on towards the standardization. हम जब standardization की बात कर रहे हैं तो architects का एक हाथ ऊपर होता है. I mean, it's a red flag for architects because we don't like standardization in certain sense because we have variety of users. I mean, unfortunately, we are not talking about users right now. End of the day, a guy is going to work in that office. A guy is going to be living his life. उसका घर बन रहा है, उसका ऑफिस बन रहा है, so वो स्पेस की रिक्वायरमेंट के लिए so basically the facade is a tool or is a I mean we all are the facilitators. So standardization of course from an engineering perspective it is very much it is very essential, I would say. But when we think about design is something which is there for the users to use. So when we think in this model, B2C model, rather than B2B model. So the customer, the end user needs to be taken care of when we design the sizes. कहीं पे कितनी साइज कितनी अप्रोप्रिएट है वो शायद हम जब रिफ्लेक्ट करते हैं तभी जाके क्वेश्चन आता है कि यहाँ पे बड़ा क्यों है, यहाँ पे छोटा क्यों है, क्योंकि ऐसा है कि अंदर जगह ही इतना है, जगह इस पे बड़े ओपनिंग की जरूरत नहीं है, यहाँ पे बड़े ग्लास की जरूरत नहीं है, बड़े फसाड की जरूरत नहीं है. एंड दैट इज व्हाई आई मीन वी नीड टू चेक फ्रॉम द बोथ द साइड्स.
I also agree with him. I think that delay is not, it should not be connect with the design. It is a poor planning and poor execution. If you are knowing in the very first day or say after 1 month, these are the sizes of the classes, these are the numbers. So after knowing the lead time, you can place the order accordingly. And at the right time, the material is there, contract is on board, but the major failure for the time not matching is the lack of resources and lack of planning. This is my observation.
मुनीर भाई, सिविल में बाकी सब मटेरियल है ना, आप उसको कैसे भी थप्पा मार के या मिट्टी का डगला कर सकते हो
दिन पे
या सीमेंट की बैग्स डालनी है तो डाल सकते हो. ग्लास में अलग अलग साइज को साइट पे या फैक्ट्री पे किसी के भी वहां अनलोड करके रखना कि 15 साइज के ग्लास है, एक प्रोजेक्ट में ऐसे 10 प्रोजेक्ट कोई कॉन्ट्रैक्टर कर रहा है तो उसके लिए पॉसिबल ही नहीं है. कि हमारा सबसे ज्यादा टाइम कहाँ जाता है, ग्लास छांटने में लगता है. उसको जो हिंदी वर्ड प्रॉपर वर्ड है छांटना, वो ग्लास ढूंढना कि ये ग्लास कहाँ पड़ा है. वो फैक्ट्री में चला आधा दिन निकल जाता है वो 5 ग्लास छांटने में, काफी टाइम ऐसा हो जाता है क्योंकि अलग अलग साइज के थप्पे हमने लगाया कि यहाँ एक बारी पड़ी है, दूसरी पड़ी है. तो और ग्लास में कोई भी प्रोसेसर 10 दिन से पहले नया ग्लास दे नहीं रहा है. डीजीयू की अगर बात करें तो उसको ऑर्डर देते 10 दिन, वापिस ग्लास में ऑप्टिमाइजेशन देता है. एक कांच चाहिए तो भी हमको पूरी सीट का पैसा देना पड़ रहा है. वो क्लाइंट तो ग्लास का एक एक्स रेट फाइनल करके बैठ गया. तो ये सब चीजें हमारे को क्या है कि प्रोटोटाइप के भाई आपकी ब्रिक सब एक साइज की है तो कैसे आदमी फटाफट काम करता है, ये प्रैक्टिकली पॉसिबल नहीं. अलग अलग साइज को ग्लास को लेके हम लोग को ढूंढ के लगाना तो टाइम तो जाता ही है.
नहीं एग्री, लेकिन हमारे सामने एग्जांपल भी है स्टैच्यू ऑफ यूनिटी का. 7,000 पीसेस डिफरेंट साइजेस के थे, फिर भी वो टाइम पे हुआ. सो जगह चाहिए आपको, स्टैकिंग के लिए जगह चाहिए, अकॉर्डिंगली प्लानिंग प्रॉपर होगा ना, यू कैन मिनिमाइज द डिले.
और पर्टिकुलर ग्लास और स्टोन, अगर आप स्टोन की भी बात करो तो उसको बहुत केयरफुली हैंडल करना पड़ता है, इसीलिए प्रॉब्लम है. अदरवाइज बाकी रॉ मटेरियल है ना, कहीं भी आप पटकोगे कोई प्रॉब्लम नहीं है.
आपको स्टैकिंग प्रॉपर करके पहले से जगह चाहिए साइट पे है.
इतनी जगह नहीं साइट पे मिलती, नहीं किसी की फैक्ट्री में रहती है. साइट पे भी इतनी जगह एलोकेट नहीं की जाती है. थोड़ा टाइम कंस्टेंट भी है. हम लोग इसको यहाँ कंक्लूड करते हैं. ऑडियंस में से किसी को कुछ क्वेश्चन आंसर है तो हम लोग उसके लिए श्रद्धा या सबको भूख लगी होगी तो मितुल मितुल भाई.
Hello. There is no question, but I will say that whenever you make a building, you hire a RCC consultant, MEP consultant, right? And then why not the facade consultant? He is your exterior facade person who is going to make sure that your building is going to stable, your glass not going to fall down. And I'm sure all the consultants are sitting here. Whatever that they will charge, they'll definitely give it to you back to you by saving so many things that optimize design. You know, glass wastages, the optimal design, calculations, all this thing, handing over the cleaning systems and everything. I think it's a teamwork. Everyone puts together. Even I feel that when you are concerned, even you should all appoint a fabricator to on a board, because they are the right person, but they have they are maximum face the site problem. What yes spoke currently that we have these issues and that issues. So if you have facade consultant board and if you have some known as a contractor who is very near to us, take the advice from him also. That I'm doing this facade, whether it's correct or wrong. So I think it's a joint venture. I think it's like everybody's like architect. I think sir, Arshad bhai, you made one design and we had one presentation, and he said whether it will happen or not, the cost is apart. And eventually we made the design and give it to him, and we had a presented. Eventually it did not work out because of the cost. And eventually what is the thought process was there, and eventually it was implemented. That can be done. So that was the thing that yes. The what architect is thinking, it can be done. Cost is apart, because that is up to the client's call whether he will do that cost or not. So I think it's fair deal. I think you can appoint a consultant, because now is going to be high rise. You are not now 70 meter no more. No, you are going 100 meter, 150 meter. So who is there are lot of wind pressure. There are wind tunnel tests going on. So I think looking at now 20% facade is your almost the cost of your building. મિતુલભાઈ આપણે હું એક બિલ્ડિંગની વાત કરું WTT, તો કદાચ એ મોસ્ટ કોમ્પ્લેક્સ બિલ્ડિંગ હશે ફસાડમાં કહેવાય, અને દર 12-13 ફૂટે એક સ્ટેગરિંગ કમ્પોનન્ટ અંદર એડ ઓન થતા હોય. સેમ બિલ્ડિંગમાં મેં લેન્ટન પ્રોપ સાથે પણ ઘણું રમ્યો છું. ઘણા ટેરેસીસ છે, એમાંથી રેઇન વોટર્સને બધું નીકાળી છે. ફસાડ કન્સલ્ટન્સી એ સ્કિલ વર્કઆઉટ કરતી વખતે આઈ થિંક મેં તમારી હેલ્પ લીધેલી એમાં, રાઈટ? અને વેરી સક્સેસફુલી આશિષભાઈએ જે કેરીડ આઉટ કરેલું છે. અને હમણાં જેમ વાત કરી સરે કે છે ને, એક આર્કિટેક્ટ એક મોડ્યુલ સાથે પ્લે કરે ને, અમદાવાદમાં સ્ક્વેર ઇંચની પણ ઘણી વેલ્યુ છે, રાઈટ? તો સ્ટાર્ટ વિથ સ્ક્વેર ઇંચ, ફૂટ, 2 ફૂટ, 3 ફૂટ, 4 ફૂટ, 8-4ની શીટો મળે છે, તો મોડ્યુલર પેલામાં કામ કેમ ના થાય, રાઈટ? એટલે આઈ થિંક છે ને એ આર્કિટેક્ટની રિસ્પોન્સિબિલિટી છે કે પ્લાનિંગ લેવલે પણ મોડ્યુલર ફોર્મમાં કામ કરે અને ફસાડને પણ મોડ્યુલર ફોર્મમાં ફેબ્રિકેટર યા કન્સલ્ટન્ટના ફીડબેકને ધ્યાનમાં રાખતા કરે, તો આઈ એમ શ્યોર ઘણું બધું સ્ટેન્ડર્ડાઇઝેશન થઈ જાય અને ઇઝ ઓફ એક્ઝિક્યુશન પણ રહે અને બિલ્ડિંગ પણ ઘણી એફર્ટલેસ બની જાય.
Anyone?
Hello. Hi, I'm really sorry. We are actually pretty late on the time. So we would have to conclude the second session now. So I would like to call upon the next speaker, Mr. Vatsal Joshi from AAPL Architects. Sir, please come on the stage.
All right, good afternoon. And I think there are people around having lunch, but I guess we can start. So this is about a topic which is very challenging actually. And when Shraddha called me for this presentation, I was really intrigued by the aspect of facades. And let me begin by understanding of our practice, which is a collaborative practice in nature, and we started this in 1992. So deep skin or skin deep is a constant challenge that we face while conceptualizing any project. And we at AAPL have taken up this issue with the understanding that the project comes first, followed by the user and then the designer. So we put ourselves not in the front, but the project has to be in the front. And our mantra for appropriate architecture has given us opportunities to work on more than 2,500 projects in the span of 30 years. And we are still counting. So this is the result of collaborative practice which was started in 1992 by a group of friends. And this is our hostel photograph. So we are all friends rather than kind of partners or directors to this company. And we came together on the moral grounds. Rizwan Kadri, Bhavik Nandi, Mayank Gedia and me, Vatsal Joshi, started this journey with common ethics and lots of dreams. As we speak today, the firm which now works in 5 countries with varied projects ranging from assembly in Africa to healthcare and real estate in Ahmedabad has come a long way. And at the core of this is working together, coming together and growing together. And that's our journey for 30 years now. And that's the way one grows. We are taking it slow and steady, but yes, on the positive. And that is the philosophy that we follow as a firm. And as I said, we put the project first and we call it appropriate architecture. This is the kind of understanding that we have cultivated amongst ourselves of how the team comes together, where 4 principals, all architects are working on a lot of different and varied projects, and ultimately converges to a project which is appropriate for that particular requirement. And that's the team, 50+ team, which is keeping us going. So now let me run you through the brief glimpse of the diverse work this team has done till now. Can you move on to the video, please? Can somebody? Go ahead. Yeah. So these are all the glimpses of our works done till now in a very short span. But this is just to showcase the diverse work that has been happening. There's some quality issue in the video, but I think it gives a fair amount of understanding of the diversity of the works that have been happening at AAPL till now. Okay, I think that's done. Can you stop? And can you move on to the part 3, please? Okay. So now on to the topic. So these are some selected works that we have showcased here. And again, this is to show the diversity in the firm that we have been working together for a long time now. And we are just cementing the fact that our mantra for appropriate architecture is followed. So I'll start with some real estate projects and then move on to some corporate and institutional and residential projects. So this is one project called Maruti Arcade, a real estate project and Ahmedabad. And I'll essentially talk about the facades in terms of the materials, the purpose, and the characteristics. So curtain glazing, aluminum composite panel in a curve form, and the purpose was to enhance the curves, and characteristics was to doubly curved surface that was designed in this building. So that's the plan. The curved section, the elevation, and that's the building. Again, a small real estate project that needed to stand out on the prominent road in Ahmedabad. Aditraj Architect, this is in 2004, and curtain glazing, aluminum composite panel, and purpose was to wrap the facade, and the characteristics were a triple height volume which was contained by a false floor. So that's the plan, the elevation, and the building. This office building needed itself to shield from the west and south sun, and which was done efficiently by the vertical aluminum fins, which doubled up as the hiding screen for the outdoor AC units also. So aluminum fins were the primary material. The purpose was to protect the sun and hide the AC units, and the sun was broken by that. Again, a real estate project in Ahmedabad, the elevation and the building. Okay, so this is in Surat, and a very commercial with very small size shops, but on a prominent road of Surat, which is Gordod Road, and it needed something kind of prominent to stand out. And what we did was that we introduced a facade which was of metal and a Ferrari structure, and it kind of added a very unique value to this whole building, which was otherwise mundane. So metal and stretch fabric, the purpose was to be a showstopper, and characteristics inspired from the nature. So that's the building, very small shops, small atrium, the section, the elevation, and that is the actual photograph of the building. Then moving on to commercial, again, a real estate project in Ahmedabad, very long one actually, on the SP Ring Road of east part, and this elongated building needed to be broken down into fragments. So we kind of introduced the round edge cuboids intersecting with the mass. Again, glass and facade illumination was also a part of this design. And this is the building, the plan, the section, the elevation, and that's the building on the SP Ring Road in Vastra. The next on is again a real estate project in Mehsana, Shiv Ganga Parisar, aluminum composite panel and glass, and the fluidity of this building was a characteristic in itself. So a very typical real estate commercial building. That's the section. That is how the building kind of comes out in terms of the shape and the form. After the real estate projects, I'll move on to some corporate offices. The next one is in Governor Office. This is in Kolwezi, DR Congo, Africa, west of Africa. And the office of the governor was of the province of Lualaba. This needed kind of the governor, to give the governor stature. This was done in a canopy which were supported by triple height columns, a ferro cement canopy, and it was an extension of the actual built form. So that's the plan, the section, the elevation, and that's how the building stands out. Next to the governor's building was a president's building. So this was for the president of the country, and it had a cylindrical column-free space, a proper cylinder actually with a column-free space, and only RCC structural columns were on the periphery. This kind of also was to highlight the stature of the president, and so it's sitting next to the governor's building, and that's how it is. There are no internal columns. All the black lines that you see are the columns, and internally it's column-free space, and that's how the building looks. So this is again in DR Congo. Once again, we have a corporate office building for a prominent bank of DR Congo, and as a facade that kind of highlights the characteristics of a bank itself. A small project. There's the section, the elevation, and that's how it stands. From corporate, we move on to some institutions, and next on is a school here in Ahmedabad, which was done in 2008. This was facing south, and to protect from the south sun, we had a blank wall, which was like 16 meter in height and 52 meter long, and that helped the school cut down on the sun and shield the children also. So that's how the plan is, and there's the section, and there's the blank wall that I was talking about, and that's how it stands. Next is a business school next to the school that we saw. This again was south facade, but this was treated differently, and being a school, we introduced a lot of colored glass here to bring in kind of vibrancy in the atrium that it had, and also the characteristics of this building were highlighted because of the glass and the fins. So that's the school that has an atrium and a long staircase. It was also featured in one of the Gujarati films. And that's the section, the elevation, and that's how it stands, and how you can see how the colored glass fills up the atrium with the light. All right, and moving on to the last project of this presentation. This is a residence that was done recently, not so recently, but finished recently actually. It was a symmetrically planned courtyard house with an open north-south axis, and this was punctuated. It had a punctuated facade with which was cladded in wood and also cotton steel. So this is the plan of the building, and it's very symmetrically done. The courtyard is in the center, north-south, and that's how the section works, bringing a lot of natural light. And the building, and that's the actual photograph. So, I mean, I'm done for this presentation. Thank you for having me here. And what I want to kind of again say is that, as you saw, all of the projects were of different nature. All of them were of different characteristics, and the diversity of this whole portfolio that at AAPL is because that we focus on the project first, and that's what is reflected in our projects. Thank you so much.
Okay. Thank you so much, Mr. Joshi, for the beautiful presentation. Next, I would like to invite Mr. Akshay Prakash Rahate from Kinlong. Please.
So, good afternoon, everyone. This one is my first presentation I am giving outside, so I am little bit nervous and more excited also. So my name is Akshay Prakash Rate. I am working as a technical head for Kinlong India and Sri Lanka. So the topic of my today's presentation is selection of facade structures and the challenges in it, digitalization and commercialization in facades and aesthetic facades. So I think the panel discussion which we had just right now before lunch, everyone was discussed regarding whom to ask to come on board first, whether PMC, architect, facade consultant, structural consultant. So I am little bit discussing on the same points again in my PPT. So these are some curtain walls which we can see outside the market: stone curtain wall, ceramic plate curtain wall, metal curtain wall, and photovoltaic curtain wall. But today I am going to speak only about glass curtain wall, because Kinlong is majorly dealing in glass curtain walls, providing the structures which are related to the glass. So here are the structures in which we are dealing: steel structure, fin facade structure, cable structure, tension rods, and then mixed, that is nothing but the hybrid structures. So here you can see the images like how the structure of MS structure will look like. Then second one is fin facade structures. This project we have just completed in Mumbai Dissect. And third one is cable structures, which the project which we have completed just in Hyderabad. So you can see the height of the fin facade structures. It is, I think, more than 15 meter, around 15 meter. But what we suggest from our side, whenever we are going to proceed for any kind of fin facade structures, then there are certain height limitations. So what we recommended, if your structure, fin facade glass structure, is going beyond 12 meters, then definitely we have to involve so many other complex items in it, which makes the visibility of the facade little bit complex. So I suggest from my side, if you want to create a facade with good transparency, and if you want to get a good natural light in your project, then cable structure is the best structure. This is nothing but the hybrid structure. You can see here the projects which requires MS structures to install the glasses of the facades. But if we install so many vertical members nearby each other in vertical directions, then definitely the look of the whole structure will not that much beautiful. So what can be done to reduce the consumption of MS and then to give the more transparency to the facade? What we have done in this project is we have incorporated some tension rods. So there are, you can see that less vertical members, the center to center distance between two vertical members are far away from each other. So how to start the process of selection of any kind of structure for the facade? The main factor on which it depends is what is the stage of the project. I think that in that panel also they discuss. Many times what happens, sometimes facade consultants and some fabricators are on board when the structure is ready. So I think in that stage, you have to do a lot of compromisation for design of any kind of facade. So what we prefer is starting phase. Whenever you are going to start any kind of project in designing, what you have to do is involve all the parties together. Let's discuss on that particular project and what loading capacity is required to make that structure possible. That is very important. Second part, which is happening everywhere in India, everyone is discussing about the facade design after the main structure is ready, almost, for the vendor part, because I am from Kinlong, that is manufacturer. So we are getting inquiries most of the times after the structure is ready. Okay. So how we proceed? If the structure is ready, we are having some following points. Support is structure bearing capacity, because structure is already ready. So how much load it can take? Second point is what is the distance of glass from the main structure? Third point is vertical and horizontal span of the facade opening. What is the actual opening of the facade? Fourth point is glass grid sizes, which are already specified by consultant or architect. Fifth is conceptual structure, steel structure, fin structure, and cable structure or hybrid structure. Definitely, if your structure is already ready, then you have to do some compromisation because of your structure capability. Sixth, the major thing is wind speed, temperature difference. What is the temperature difference of that particular area? Buckling analysis and earthquake zone, whether your zone is coming under earthquake zone or what. How we proceed? Whenever we are starting the structure selection process, first we are taking care of glass part. What is the actual glass of size the client is asking us to analyze, or the client is asking us to consider in this project. So how we started is, first we are checking the deflection of that glass, stress, whether this glass is passing on 4-point support, 6-point support, or do we have to increase the point of support for the glass, and then the reaction checking, because definitely to hold the glass we have to use certain kind of hardware for it. So the reactions, if the height of the glass is more, and if the reactions coming are more, then definitely the back support structures should be more strong, and definitely it will become more rigid and more, the section size will be more big actually. So everyone wants sleek structure. So what compromisation we have to do is, sometimes we have to change the grid sizes of the glass, or sometimes we have to change the thickness to reduce the dead load of the glass, or maybe if it is failing in deflection, then you have to change the lamination process. Maybe instead of PVB, you have to use SGP. After that, by considering the glass which is passing, we are checking the whole cable structure. This one is the first preference which I am giving whenever I am getting any kind of inquiry and client is asking me to suggest what you can give. Okay, this is my favorite structure actually. So what we are doing, we are creating model, we are checking the deflection of the whole facade, and then what reactions coming on the main structure. Okay, so what problems generally we are facing is the sagging of the top beam. Many times because of PT structure, what happened? The PTB structure, after a certain period of time, there is a sagging of beam at the top of the side. So in that particular place, you can't use cable structure. You have to go for another structure. So here, maybe you have to compromise. Second part is sway in vertical column. As much as you are increasing the height of your building, might be at the top of the building, there is a sway in the vertical columns. So what can be done for that? So I'll tell you in the second slide. Before that, there is one video. So I think in this video you have already seen that the diameter of cables in vertical direction and horizontal directions are very small. So the transparency of the whole facade is very good, right? And this is what we all require from our side, and even for client, they require the same thing, more sleekness of the facade. But if you are worried about cable part, if you are worried about what will happen if there is more loads on the cable, then definitely Kinlang have solutions for it. The first one is overload protection. If the load on your cable is increasing, this first device will work. And second part, if you are worried about earthquake zone, if there are certain motions in vertical up and down directions, then this pretension keeping device will help us to keep a proper pretension in every cable. This one is one project which we have done in China by using this pretension keeping device in the cable. The next part, if architect or the main developer don't want to compromise on this cable, something like that, then you have the second option, what is rod. You can use tension rod because the reactions coming from the rod on the main structure is less as compared to cable. But still, the reactions coming from the tension rod is still high, then you can go for self-balanced structure. You can see at that side, the whole load is taken by that vertical member, and all the tension rods are connected to the main MS beam. So don't worry about the reactions coming from the main facade. It is directly transferred to MS beam first, and very less reactions are transferred to main structure. This is the hybrid structure which we have just completed one project in Dehradun Airport. The client's intent was to make the whole structure with the help of MS vertical structures. So what we help them to reduce the use of MS and to increase the vertical distance between the vertical members. So here also we have used some tension rods just behind the vertical member. So the benefit of this tension rod introduction is the vertical member size got reduced so far. You can see this one is the cantilever structure canopy. This project we have done in Hyderabad, in Telangana actually, Telangana Police Headquarters. You can see the design, how it looks. Instead of using MS structure, it's always good to use something new, which is not already done in India. This one is one project actually which we have completed in Ahmedabad. This one is in Gujarat, it is first cable structure, cable net structure, for which we have given a good support. For cable calculation, for glass calculations, we are working on this project from 2018. But finally, in 2021, we have completed with the design and execution of this facade. With the help of HiFab team, actually, we have done the successful execution of this facade. This is the outside part, and this is the inside part. So second part, after making so many facades, we are generally we are making so many dead spaces. After making that facade, there is no use of it. just from outside you can see that it is good to see, but from inside there are a lot of big structure members are there. So how to use that space? So we have another brand that is Next Novo, that is nothing but the digitalization in facade. There are shop fronts also, only glasses are there, but how to use that dead space? So here is one video. So I think from this video you can see that this dead space you can use for the advertisement purpose or for any kind of revenue generation purpose, because there are lots of brands they want to do their advertisement. So you can use that dead space. Even in the malls, there are a lot of railings are there, baluster railings. For that also we are providing the glasses along with LED film, so which can be used as a media or to generate a media or to create more awareness about any kind of brand, or if developers are there in their own facade buildings, they can use such kind of facades or such kind of LED screen to show their own projects. So what is the uniqueness in this Next Novo is, it is having 3D SMT technology. So most of the screens which are available in the markets having different type of mounting. So what is the best benefit? Because of having face mounting, it is very strong. Whenever you are applying any kind of load on it, it can take 4 kg load. That is the main thing. Second is the working principle of this LED. In the single LED, it is having 3 extra LEDs which can give any kind of color which we are showing in your media. And you can play this particular screen by using any kind of system like mobile, laptop, anything you can play. So it is very easy to use such kind of application. Pixel pitch. Now how to decide what kind of facade or what kind of LED you have to select? It completely depends upon from how far you are going to see that facade. For example, if it is mall, then definitely viewing distance will be more. If it is shop front, viewing distance will be less. So based on that, per square meter, you have to decide, means definitely Kinlong will help you in calculation of all these kind of pitches. You can see here, if you are very near to the screen, then you have to go for a smaller pitch. Pitch is nothing but the distance between each and every LED, which is coming in that per square meter. These are the features of Next Novo. Actually, I have to explain third topic, so I have to wrap up here. Larger viewing angle, color distribution is very good in these LED screens. Best color balance, no mixing of any kind of color, which are having different pitches and which are soldered besides each other. Lamp impact, you can see 4 kg load can take. IM9 technology. Based on the environmental temperature, humidity and smoke, this detector can operate or monitor and control the brightness of this screen and every LED, which will help you to reduce the energy cost. These are the screens types which are available. You can visit our stall. We will definitely explain you all the things. The last part is aesthetic facades. There are some structures which are not actually which are not going to take more structural loads, but that is only for creating your building more beautiful. Okay. So just by using our natural resource wind, you can implement such kind of structures at the periphery of your building. That is nothing but skin facade. How it works? Just by using some vertical cables, some aluminum panels or SS panels based on your requirement, we can manufacture for you, we can design it for you. Definitely we will do all kind of calculations on SAD, SAP, everywhere. This is the working principle of this dynamic facade. Some other facades which we have already done in overseas market is, this point is very important. If your structure is not able to take any kind of cable loads, then they can use steel structure to mount such kind of panels in your facade. Types of plates, it completely depends upon the architect demand, what kind of shapes or profiles he want to show. With the help of normal cables, you can see how they created a skin of this particular building. These are some projects which we have already done overseas market. So what I wanted to say is, whenever you want to start any kind of project, you try to involve sometimes some vendors also, those who are going to manufacture that product, because sometimes you can complete the whole structure, but the reactions actual coming from the main structure, like cable is there, tension rod is there, fin facade is there, MS structure is there, that they will define you how much load is coming actually. So if you guys are working together, then definitely the working efficiency and the project completion time will be less. Okay, thank you.
Hello. Yeah. Thank you so much, Akshay. It was really innovative and very informational as well. Now I would like to call upon Mr. Mitul Gajjar, Director of Facade Engineering Services.
This one? Okay. I think I'm audible. Good afternoon, everyone. I think after lunch, the speeches I have to shorten as per instructions. So let me try how I can shorten this. First, thanks Zak to provide me this platform. This is my first speech ever I will giving to any platform. So anyway, it's fine. Second thing, congratulations to Kushagra and this doing your carbon footprint. So it was very nice and showcase some of my projects which has been done in Ahmedabad. So thank you very much. And small, I think the INI design already started some carbon footprint doing the IPL, where the aluminum has been very minimalistically used, and the most of this everything goes on the steel part. And I think project has come very nicely. Thank you, and your efforts in Ahmedabad, it's very appreciated. Anyway, my topic is today for the future challenges going to come in Ahmedabad. Now, in few years, I just started coming in Ahmedabad 2012 onwards, and I had to see that 10 floor building, 8 floor building. Slowly in 2016, it started that 20-story building. Now, then last 2 years back, then the government is allowed to 70-meter height building. So around 22 floor, 23 floor. And I think recently, last 1.5 years, I think the speed has picked up very like rocket. It starts for 100 meters allowed, and then suddenly they've gone up to 150 meters. So if you see in that 2024-25, you can see around 50 buildings which will come up more than 100 meter height, which may be either residential or the commercial. So which we see that after 2024, or you come down 2027, you can see like all the buildings which is almost around 100 meter and above. So now there are challenges that when we do our facade design, we have a responsibility to make sure that we take care of the fire safety, and these are because. So what should follow? That's the first thing. So which I have norms. So there are some. The one is NBC 2016 is the guidelines which everybody can follow. That is, and second most important is local fire authority. Now in Mumbai there are MIDC. There is a rules and regulations are different. BMC rules are different. New Mumbai rules and different. So if you see none of the fire. I think anybody from fire authority over here. I don't think so. If you see that none of the fire officers, they on one platform on the fire norms, how to, they have over generic fire norms related to building, not specific to the facade. So this is a challenging for any consultant or any developer to, to give the full satisfaction that we are meeting all the requirements. So I'll request, I think Ahmedabad also, I don't think so we have some specific guidelines for facade. And I think they say that you follow NBC 2016 norms. I think what we do, which follow in GIFT City and Ahmedabad so far. I just give you one a simple one example. Okay. What is NBC 2016 says? You should have openables at every 10 meter. Up to, that should be openable, should be allowed up to 1.2 meter, 1.5 meter height. And the openable should be of 1 meter of 1 meter. That is the standard rules has given it. It's not that you have a compulsion, you have to follow it, but that's the minimum because it's NBC 2000 guidelines, it's not compulsion. But if you see that vice versa of a person, I'll not give you who has given this. These are local fire safety norms. He has given that the openable when a minimum 2.1 of the floor area. How can it decide a floor area and then how to make openable in facade? So he has given this generic statement. And whether this is really going to be applicable, God knows only. So I'll not say who has given this, but we have to implement this. That's a comms. He says, I don't know NBC, and you follow what I want to say that. He also said the refrigerator crowded glass facade shall have the openables or from both sides, inside outside. He says again a refrigerator should be openable. How it's possible? And it's a normal glass facade allowed. So absolutely, when say the fire officer, they are struggling. They find very difficult when high-rise facades are going down, and they take call according to their experience. I have seen so many buildings, metro cities like Bangalore and Hyderabad, there are 40,000 square meter and no single openable. And I asked them, do you have any other solution to extract the smoke? You have a smoke extract system? Well, no. So then how you given you got the clearance from the fire authority? So what they got the answer I cannot tell here, so it is leave it. But it's very surprising. And then the building has got a foreign investment. And then this guy say, no, you make openable, I cannot invest in your property. So what he's doing now? In 40,000 square meter of facade, now he's implementing 800 openables. So what the cost is going to the running building? The cost is what he has done. So what he had done a mistake in 6 years back, now he's doing, the cost will be more than double and triple. This happens also I seen in Pune. Like the entire building has no openables, no open systems. That's really it. So the challenging, there are systems that how to make. Luckily, positive notes in Ahmedabad, Baroda, I didn't see in such kind of building. So far, must have seen, because we do some audits after a certain years of building. So we found out during those stages. But so recently, whatever we done facade, I think, which is after 2015 to 2020, we didn't see any facade, such kind of things which is happening over here. I'll just go back to how many openables kind of type facade. I'll skip this. This most important is, of course, openables can be openable top on, pop up, open in, open out. That's, I think, 2006 is open out openables. Someone is given that you can do with the mechanic system, smoke veil system, you can connect it. Of course, there is a cost to that. But make sure that wherever the openables has been given, you make sure that you give a sign of this openable. I think that is, positive note, we should do it. It may look maybe aesthetic a little bit, but in a case of fire, if you consider if you have laminate DGU glass entire building and there's only the openable vent, you have a DGU glass, so you should know which glass to break, because your laminated glass will not break. So these are norms then followed by in Bangalore. I have seen positive, it's very good somewhere. I seen in Bombay also. So they say, and I'll show you this. These are the photographs which has been shown. Okay, just so what will be taken care of when you say providing the openable vents, so that operative opening shall be provided considering guidelines given by local authority in NBC 2006. Make sure opening is for exterior facade element as well blockages. I have seen so many buildings given openable vents on every 10 meter to 15 meter, and interiors has been blocked, the openables. No one can open that. So if I go to customer and say, what are you doing? No, he's a tenant, he's paying me, why should I block him? Please, we are playing with the humans. So you are the owner of the building, you should say that my openables, panels should not be covered with any of the interior furniture. So that's one thing. Type of openable recommended by, I am surprised that Kushagra, I don't know how a far person on a 150 meter height can evacuate the person from the openables. I'm not sure. One of the guy told, I want side-on openable window at 150 meter height. And I told him, whether you have that ladder to go back and you have to evacuate. So that is not my problem, you provide me the openable. But he doesn't know that any of the system supplier will not allow the 90 degree to open it. He will allow only 15 degree to open it. So how will you open that time? So there are very, the gap between the fire authority and I think for the facade. So I think overall we need to discuss with the fire authority on stage wide and bring them all on one platform. Because I see that working on Pan India, these issues are very high and there is no solution we are finding out here. So these are the recommended openings, degrees, yes, consider, no one will allow. Suitable hardware, as I think Kinlon given 2 minutes back only, that you should have a suitable hardware that should take the wind pressure in an opening condition also. So that can be. Positive the detachable handle. Yes, this is the last option is more for your hotel projects, right? Most of the hotels are not in a favor of providing the openables because of the societal cases which has happened and bad the name in the hotel. But eventually he has to also get the fire NOC from the authority. Someone will agree with non-providing openables. but somebody agrees, then you can have this open detachable handle and you can do this. Samples, okay, let's skip this. Of course, this is a nice way to show that difference. This is one of the biggest I've seen, that detachable handle is kept at near the fire institution. You can open it, so it has been very nicely done. So this is so this used to be done. I think none of the project I have seen so far. So this is the sample he has been shown the paper, and so that he's used the handle to open it, open window. So in an emergency case and everything. I think I'll come back to that later stage. This is side angle. See this in Bangalore, Hyderabad, Chennai, Delhi. All NNC companies do this. Remove the handle, fix the openable with the screw, permanent locked. This is the technique they follow. अब किसको क्या समझा है? I can't explain Google, I cannot explain IBM, I cannot explain the other multinationals. But they do this, and we give them non-conformity, and then they do that. This is the excellent advantage what you had given this. God only save. Who can only open it? Need a ladder. So I told at least pivot a ladder over there, so at least someone can open it. So this is the faulty techniques that people we follow. Yes, on a facade we say we are, I think in India 50-60 consider they are to take the help of them. They give the right solution for you. We always support for the building. Now they say, just now we had a panelist says that whether you need a facade concern. Yes, you can avoid all these things. And of course, your 20% of the facade, your project value goes to the facade nowadays, or maybe more than that also. Fire penetration, I think it's very easy to, pokey effect, chimney effect. This is, I think people knows about it. Still, I'll just highlight this. Leaf flow effect. The basically two, which I'll three of them are more important. First is more related to the MEP, which is compartment to compartment. Of course, I'll come back to that point also. One is floor is the first major point. This you should not have any smoke which is going from floor to floor, which is because the maximum people die because of smoke, not because of the fire. That's the first point you have to understand. And second, the fire when the glass breaks and then the fire comes out, then goes over. The typical design which is there. I'll just skip this because the time is not implemented. These are two cases. You can have one of the which is the side rise, which is also there. You can see the outside which is they have done, and one of the this is one of other method which we are doing it. Make sure you do this on a right way, and it must be implemented. This is also to be done on a now this before going to compartment. This is more related to MEP, but yes, it is also related to facade. When it's a say compartment to compartment, you should do this also, because you have done everything here, but you have forgot to fill up the gap between the compartment. Because on a building where the small offices are there is a gap between the office to office. So if the MEP is taking care of their cables and all those by sealing it properly, and there's no smoke and going in other compartment, I think we should close this area also, which is I think very rare of the rare cases people follow this. But yes, we instead if you have smaller offices, we should implement this also. This is the code which we said NBC will skip this. This is a full sprinklers, this is flow to floor slab by which I covered it. Now this is refuge area. I have a very discussion on this horizontal effect. The refuge area, basically the best possible way to get out of the building, either you go by staircase and get out of the building, or you go to the refuge area. This is the most important when you do talk about the 150-meter height building. This is the most important which has been done. And they says very specifically you should have a solid wall or maybe 120 minute fire rated any product. You can glass facade or maybe a wall. Our challenge is this, whether we can call this as a refuge area. I cannot say this is a refuge area, but people say, government says refuge area, I'll accept. I'll say it's when the facade is, your refuge area is open from three sides, that will I'll call is the refuge area, not this one. This anything will go on fire. I think you cannot rescue any people from there. But still, people will say this is refuge area. We will accept this because we don't have option. because eventually building has to happen. But yes, this is quite, every building you can see this. Now this is fire rated facade. This is like the same thing, 120 fire. There are a lot of products that's come down in India. Of course, it's, at the moment it's very expensive, and I think slowly we'll have a solution on this. 2 are fire rated facades in the glass and everything. So basically that's the person is moving out, but there is no fire is coming. So basically here this is implement where the refuge area has also office area. That time they want area, I want to see the glass, what are you blocking me, everything. So then because of saleable area, he'll give the glass facade. When he forgets that there is a next is a refuge area. So that time we recommend to do for 128 fire rated products. And there is a typical steel design. We have done this for many projects. Recently we are doing it. There is a specification which I'll skip this because again going discussion will take some time. Fire rated retarded products, and I think a lot of people have spoke about it. 30 minutes, 60 minutes. Fire rated product and fire rated. I'll go back. Of course, make sure that whatever ACP used, there's a common problem in Ahmedabad. A lot of ACP we use in that, but please make sure that it is FR grade product, grade B or A2 product. We can recommend it. Don't use it. What has happened to Surat, which is a live example, which has happened a few years back. So many people have died, kids have died because of the ACP which has got a fire, and there was smoke, because most of them died because of the smoke. Of course, fire rated is there. So this has smoke. Now no one has done this. I think I've seen these things are happening in Mumbai. The periodic maintenance has to be done. Necessary have periodic maintenance for openable vents. I have seen more than 100 buildings. I do audits in a year around 100, 200, 200 buildings. Most of the openables are not working. Is anybody's system because it is never opened. So eventually it's a mechanical product. You also need some maintenance. So it has to maintain. When really, like your firefighting system, you maintain it, you try to do that, try to open it. No one. I have seen mechanical system which is not open for 2 years. When they try to open it, they're never going to open. So I think periodic maintenance is much needed over here, which we forget to do that. Check for their hardware. Of course, it has to be checked that whether lock or not lock. Regular advert confirms to. Yeah, this is also need to check by the owner that if he has given a property on rental basis, whether the openable vents are obstructed or it has been done by something. So you have to check because eventually the owner is going to be at stake. So that has to be taken care of. Regular fire drill. Yes, this is must for in a futuristic project after 2024. This things has to also needs to be implemented. Yes, that fire drill is happening. Bombay, many high-rise properties has a fire drill. Once in 2 months they do it, and they will do also surprise drills. So this is also must. I think overall I will have complete with that. We have to have a balanced approach. MEP, facade, everybody should come together and find a solution. One more thing which I have to. I have got 2 minutes, so I'll take 1 minute. Please, when you do a double skin facade, please make sure you take the approval from fire authority. I have seen one building which has got a fire, and fire tender took 36 hours to control that fire because of double skin facade. Because that double skin have a perforation sheet, and the water it was throwing on the building, the 80% of the water was coming back because of the perforated sheet. So, and that building is totally gone in a bad shape, and when the individual structure also. And now they are into the rebuilding that structure and doing the facade. So, to make sure that you make a double skin facade, we are not against a double skin facade, but make sure that you take facade consultant help to make sure that how if in case of fire, how will the fire tender will approach the fire area, and you can take the control of the fire. So I think balanced approach is needed. Sprinklers are there, fire exits are passive are there. Of course, second thing which is that people says one more thing, one of related to facade. The staircase which is pressurized. Still someone recommends for the openable panel, because in case of mechanical system failure, what will happen? So that is the question mark which I recommend. I think Gujarat, Ahmedabad doesn't have such kind of rule. I think it's an open staircase concept which is going on. But a lot of projects which is in Mumbai, Bangalore, Hyderabad, have pressurized staircase, or most of the hotels has a pressurized staircase. But still, if that failures, there is no answer to it. So if you have a openable one panel, which can be come and which can emergency can be open it. So that I think Marriott's does it, which is they provide one openable for their pressurized staircase also for emergency. I think with end I will end my this topic. Hopefully we'll do a good fire facade take care of in 150-meter height building. Thank you very much.
Thank you so much, Mr. Mithul Gajjar. Now I would like to invite Mr. Faizer Ali Dastagir from Viva Composite Panels. So please.
Good evening, Ahmedabad. I think so. Give me a good evening back here. Come on. You know, this is a very challenging time to present in a Zak, but I've got used to it. Now it's been 2 years of field training on this because you know the food is digested, the melatonin is coming through, nice sleep, nice AC. I'll try to keep you guys interested for the next 20 minutes. I'm Faizer. I'm National Head Projects for Viva Composite Panel. Basically, today's presentation is aimed at actually enhancing your perspective at ACP as a building material product or a cladding product. Second is the reliability you can have on ACP as a product in terms of safety and aesthetics and longevity on your facade. And third is the technology that is available today in India where we can make world-class product which was not available before. So these are the three main agendas. Before I start the presentation, I would just like to start it with a little introduction about Viva. We are into this business for the last 2 decades, and the first 10 years of our business was mainly into importing of 1 mm ACP that's substituted to laminates. We set up our plant in the year 2014, and it's been 9 years we have our plant. Today we are at a production capacity of 7 million square meter per annum. That is almost 20,000 square meter to 25,000 per day, which by God's grace is now going to be climbing up to 40,000 square meter per day. So we become Asia's largest plant from the month of April and May. It's like we got the 3rd coating line getting commissioned. So we already have 2 coating lines. We'll get the 3rd coating line commissioned as well. So except China, we become the largest plant in Asian continent. That allows us to give you warranties from 10 years to 30 years, which was not a possibility before. So we can make your warranties flexible. Our strength is our customer service points. We have offices throughout India at 20 locations. Also, we have our distributor locations as well. At some places, we do not have our warehouses. The biggest plus point is we make all the 3 FR grades, that is class B, A2 and A2 plus, which is an innovative product, which I will speak about a little more. All these products are tested and certified, which is going to be one of my focal points of the presentation. 8 state-of-art production lines, that is 3 coating lines and 5 lamination lines. And the biggest strength we have is 300 plus shades and textures, which is ever growing, apart from the customization options that we can give you as well. So a little insight into history. ACP basically was founded in 1969 in Alusingen, BASF, 1969. It was a collaboration then, and ACP was not a material that was supposed to be on cladding. It was a signage material. But eventually in 1980, the industry discovered that we can use ACP as a cladding material. In 1990, we saw a rampant use of ACP starting everywhere in the world. It reached India a little late, into the early 2000s. It's been a popular material worldwide now for last 2 decades. And from a signage material, it has grown into a wall cladding material, an architectural material for exterior and interior purposes. It's also used in aircraft building, shipbuilding. It's used in railway coaches building. We supply a large quantity to ICF every year. It's come a long way. ACP, what strikes your mind is basically solid metallic, silver metallic, champagne gold, but it is now moved. We are moving towards the metal composite paradigm. We are moving forward into making ACP look like a metal cladding product rather than an ACP. So there is a flip side. When a product is used excessively, it becomes monotonous. So people start seeing every building to be the same. There's no difference between 2 buildings. So every building is either silver, champagne, gold or white. Now we need something different. And this was a challenge that came up to us when we also started manufacturing, that over a period of time we've seen stakeholders losing interest in the product. So this challenged us to see what new we could bring. And as a serious venture, we took it up with our R&D team. We spoke to stakeholders throughout the globe, and we found what could have come up. So a building like that now has a stone cladding ACP. That's a stone ACP. If it's so done so well that you will not feel it like an ACP at all. So our series is range from a natural stone series, a metal abstract series which is inspired by cotton steel. Now this is one of our path breaking series which we launched 5 months ago. This is called the Tarnished Metalum series, where we've taken a metal like copper and then given it 5 different fields. Then we've taken steel, we've given it 5 different fields. So what we are trying to do is we are moving towards the metal composite material paradigm and making ACP look very, very interesting. So this is come from a lot of inputs that we had from architects, stakeholders throughout the country, and then we formed the series. Okay. That was an introduction about Viva. Now let's address the problem we have on hand and the solution for it as well. So this is a building fire that happened that Mitul sir had referred in his presentation. This is a non-FR ACP in a textile showroom. So what you observe here is there's a lot of fire, smoke, and the droplets of fire that are falling down, which is the biggest challenge of a non-FR ACP. So this is a small experiment we did at our lab with a non-FR ACP. You can see it is combustible because it has LDP, that's plastic. So plastic is going to burn. It is going to emit smoke that is toxic. So in a case of a fire, we need to understand that what kills more is not the fire, but it's the smoke. The smoke is what kills people. The casualties in terms of human is in terms of smoke. Evacuation becomes a challenge. Okay, now that was the problem. Now we needed to find a solution. Not only Viva, but any ACP manufacturer had to find a solution. The industry had to find a solution because otherwise the product would not be considered safe. Now what we did is, you all agree that the skin is aluminum. So both the skins are aluminum. It is pretty safe. That's not going to be combustible. But the core had the problem. So the core had to be replaced from an LDP core or a plastic core to a mineral core. Now if I split the mineral up, it's magnesium hydroxide and aluminum trihydroxide. Basically hydroxide compound that when it comes in contact with fire, it basically gives out the oxygen and water remains. So it retards fire. It doesn't participate in fire. When there is no fire, there is no smoke. And obviously there is mineral, so mineral will not release smoke. So this is how ACP is now made into a safer product where we have fire retardant capabilities. With different ratios, we mix the mineral core to give you different classes of fire rated products. So the first class is class B, that is 70% mineral core and 30% virgin core. Now, the 70% mineral core is the same, referring to the last slide, as the hydroxide compound. This class B is not a nomenclature that is given by Viva. It is a standard that mentions EN 13501 is a standard that says that if a class B product is made, it should have a 70% mineral core. Then we have an A2 core, which is a 90% mineral core with 10% virgin. Now again, the A2 is also given by EN 13501-1, which is a standard, a European standard for classification of fire products for cladding. Now this is a small lab experiment we did at our plant where we exposed the class B and the A2 to fire. You can see that there is no combustion. It has not caught fire. It's just the core is getting heated up. That's it in case of class B. You will see a minor release of smoke which is non-toxic and it is okay as per the standard because it is S1 D0. So when you come to A2, the next sample is the A2 sample, you will see there is absolutely, this is the class B. So when you come to the A2, you will see that there is absolutely no combustion at all. It is completely safe, it's non-combustible, so you can be sure that you're using a very safe product that will not participate in fire. The very important slide in this entire presentation which I want to highlight to all of you is that you need to understand that, okay, as a manufacturer, I am claiming that these are all products that are certified and tested, but how do you know that? Now, now that's where the certification comes into play, where we've worked with Thomas Bellwright to get the certification for the EN standard, the NFPA standard, and the factory is under a production control. That means every 3 months there's an audit from Thomas Bellwright to check whether the products have been made as per the standard. So this is very, very important that a factory has to be under FPC so that you are assured that you get a product that is adhering to the standard. So this is the EN 13501 certification here for the class B. EN is basically a standard that, as I told you, fire classification for cladding products. This is an NFPA 285 certificate for fire propagation, where you're sure that the cladding material is not participating in fire. So we also got the certification for A2 very recently. So we are the first manufacturer in India to get an A2 certification for NFPA. These are a few clauses that are there for the NFPA standard to be cleared. Now you see there are a set of 8 clauses which the NFPA demands that if every clause is cleared in terms of flame height, width, spread of flame, temperature is when the test is passed. So it's a pretty stringent test that is not easy to pass. Only if you have all the clauses going well, then the test is declared a pass. Moving into innovation of ACP, we took ACP a little further. Instead of having a mineral core, now we also have a core that has an aluminum in between, so corrugated core. So it's an ideal replacement for a solid aluminum sheet. So if you have a solid aluminum sheet project, you can look at this as an alternative material because it is easy to install. It's light in weight. It is an A2 rated product. It can be routed and fixed. So workmanship and installation is pretty quick. And it's a single bone warranty from Viva. So we stand warranty for the color as well as the delamination as well. So this is the structure of the ACCP. So a small test here that is happening. You can see absolutely there is no combustion. We also make solid aluminum panels as well, 2 mm solid aluminum panels for MAU, and we'll be moving into 3 mm solid aluminum panels in another 6 months as well. Another product that is currently being manufactured at our plant is a 12 mm and a 25 mm honeycomb panel, which is a high performance cladding panel that can be used in public spaces like metros, airports, auditoriums, wherever you have a lot of traffic and you want to enhance the performance of the wall cladding material, then honeycomb comes into play. This is also manufactured at our plant in Umargaon. Very quickly, this is where all the magic happens. This is a 13-acre facility. I use the word completely integrated facility because we have a paint manufacturing unit there where we do the entire paint formulation in collaboration with big paint brands like Nippon, Spectrum, Asian PPG, AkzoNobel and Monopole. So we formulate all the paint. That's why we can customize any color, any shade, any stone texture. Then we have our first color coating line, which is a 4 feet color coating line. We have a second coating line, which is a 5 feet plus color coating line, which is a 2-coat, 3-bake system. And we're going to get the third one, which is a 3-coat, 3-bake coating line, which is getting installed just next to it. 4 lamination lines and 1 hybrid line for A2, A2 plus and honeycomb panel. So 1 single line making 4 advanced products. A few projects that we've done in this part of the country. In Bharuch, we did the Hayat for 6,000 square meter. This is our metal abstract series. FR Class B. Raghuveer Scarlet. We've done some very good projects in Surat. This is 10,000 square meter. Again, the shade BC means it's a customized shade. So we've customized the shade to the client's liking. A residential project where we've done 15,000 square meter, again customized shade with Surya Heritage. This is one of our signature projects in Mumbai where we did Kohinoor with A2 plus, the corrugated core panel. It's a RAL color 7035, 16,000 square meter. And this is city center bus stand in Bharuch again, 6,000 square meter. It's a textured shade, it's a customized shade. A few projects in Qatar. We've been doing a lot of work overseas as well, and we want to scale up the exports. So we're exporting almost 20% of our turnover, which we want to scale up further. Very interesting project we did with Big Architects New York, where we had to develop a customized bamboo shade for a panda enclosure in Alkur Zoo. I always take a lot of pride in explaining this slide because this is not day-to-day stuff, and working with these kind of professionals is challenging by itself because they demand perfection. So they had even given us dimensions how the bamboo should look. So we went ahead, we didn't secure the project at that point of time. So purely R&D experimental. We went ahead, we developed the shade, we did 3 variants, and then we came up with this. And God's grace, they liked it. So I would end my presentation by saying that's what the commitment we stand at. We like to be challenged, and we like to provide the best of services possible, and working towards changing the perspective of ACP to be a reliable and safe material for the industry. Thank you all.
Thank you so much, Mr. Dastagir. It was a beautiful presentation. Now I would like to invite Mr. Bharat Suvarna, Marketing Head from Stone Lamp.
Thanks. Check. Hello everyone. So again, even more into the depth of post-lunch. So to begin with, some of you might know, but for those who don't, Stone Lamp is a joint venture between the StoneX Group, which is one of the largest marble suppliers in India, and Laminum from Italy, which are the pioneers in porcelain ceramic slabs. So to begin with, what is a general expectation that people have from facades? So a lot of presentations happen throughout the day wherein people were discussing the percentage of money that is allocated to facades. Somebody spoke about how it's the last thing that comes into people's minds, and all the consultants are involved at a very late stage where they really can't make any changes to the facade. So more or less in India, it has been a very, very neglected side of the buildings, especially in residential. Commercial, obviously, they need to take care, but from a residential and housing point of view, it has always been the whatever is left, we'll put it on the facade, and then eventually it used to always go towards paints because that was whatever people could afford. So some standard things that people can expect, do really expect from facades is that it needs to be elegant. It really showcases, because it's the skin of your building. So you can say that people have this saying, never judge a book by its cover, but you can definitely judge a building by its facade. So also being distinctive is something that people look forward to. It has to be functional as well. It's not just something about aesthetics. It has to serve a purpose. There's a reason why it's there. It's supposed to do a job. Also, looking at from different things that people said, that facades are going towards futuristic. There are facades which are also on the lines of regenerating electricity for the building and so on and so forth. So innovation is always there. So people are also wanting their buildings to look more futuristic, being sustainable, being compliant to all the different norms that are there, while also being very, very eco-friendly. And aesthetics plays a very, very, very important part, because obviously you're trying to make your building look good. Because if you look at it from an architect's perspective, it is a calling card for him, because when he designs something and that really clicks for some people, people will start asking him as a referral, okay, who made this? And that becomes his visiting card for that particular area. So talking about these are the things that people expect from facades. Now coming to a different topic, what are the challenges that current facades materials they portray in terms of from the architect's point of view, from the design point of view, or even from facade consultant, MEPs, all of those. So the current materials, they are either very, very prone to scratches, stains, chemical reactions. They fade because of the UV. India is a very, very, very unforgiving kind of a climate. So some parts are super hot, some parts are super cold, some parts there's extreme rain, some parts there's extreme dust. So you need a material that is going to battle all of this. It's not just something that does some things and something that does something. Because what happens is, as I mentioned, that the overall cost of facade that they keep, the budget is very low. So they try to pick something that works for now, because even architects have a tendency that up to 2 years I will take guarantee of whatever I have put up, and post that it is natural wear and tear. That is the claim that is given to the building owners and so on and so forth, that these materials will wear and tear. So people are looking at longer lifespans. If you are building, if you're creating buildings that will last for 50 years, why shouldn't the material that is being put on that also last that long and provide that kind of warranties? So that is one: stains, scratches, chemicals, UV, fade, fire. Everybody discussed fire. One topic that was kind of neglected, I felt, was water. Because considering the entire west coast and even the east coast, we receive a very, very, very huge amount of rain. So all the standard materials that have become commonplace right now, they really are, if not affected by fire, they get affected by water. So that is another thing that needs to be taken care of. So fire, water, stain, scratch, chemical, UV, and also in terms of the longevity, because if the colors also don't stay that long, the entire look and feel of the building dies out. So you're looking at something that is going to remain looking new for at least 20 to 25 years. That is what people expect from facades. Now, when I say Italy, what is the thing that comes to your mind? It's generally something like this. People imagine your supercars, or some people might actually think about all the different architecture like the Colosseum. Some people might think about a vacation. Some people, food, obviously Italian food is really great. Different sightseeing opportunities. And for some it is a city of love and romance. But who thinks of Italy in this way? A lot of people might not know that Italy is one country in all of Europe which has active volcanoes, and it has always been a volcanic center in all of Europe. It is one of the live ones. So why am I showing you this? Why a lava in front of, in this topic of facades and all of that, and especially porcelain and all of that? So there is a reason why I'm showing this, because I want to take you to the origin of how porcelain became one of the materials to be chosen as a facade material. So once these active lavas dried out, all the magma and all the material that was there, people tried using that. Like it had all the fire resistant properties, it was resistant to water, there was no staining that happened to it, it was very, very hard, it had very, very strong grit, it had a very, so the intermolecular distance, because of the heat and the pressure that used to come out of this lava, used to be so tight that nothing used to be able to penetrate it. So staining also went out, it was resistant to chemicals also. So some people tried to replicate what was available over here, and that is how it came to being that people eventually came to using clay as a base material and then adding different materials to eventually arrive at porcelain. Now, when you talk about porcelain, the first thing that comes to your mind is your crockery and bartan and plates and all of that. But and you will say that it's a very brittle material, how can we use this in facades and all of that. But there's a process that is being used to make this, and I'll take you through that. So I talked about the history. So the process that is being used is called sintering. It is the same process that is used to make American diamonds, wherein there is a mixture of different components. So from the volcanic rock, very similar, we have metamorphic rocks, we have feldspar, we have granite, we have clay, and some marble dust, granite dust and chips. All of this is converted into a sort of a slurry and passed through conveyor belts and subjected to extremely high heat of over 1250 degrees Celsius, and then compressed at 6.5 bar pressure at the same time. So what this does is it really removes intermolecular distance between the elements that are present in that. So we are able to achieve a 3 mm thin slab in large format, that is 3 meter by 1 meter. So you have lesser number of joints, and it has all the properties of stone. It has all the it is as strong as metal. It is 30% harder than granite. So that can be achieved with this, and it is, because of all this process, it is also automatically hygienic, because there is no organic pigment that is present in all of these raw materials. So at the back end, we've done a lot of testing in terms of, when we say stain, we've taken white porcelain slabs and we've literally put wet haldi on it, because when you're trying to see outdoor facade, it's going to see rain, sun, and mud, and God knows what, even pan spit, there could be anything that can stay in the facade. So haldi is one of the strongest colorants. So we've taken haldi, wine, pomegranate, oil, and all of that, we put that on the slab, on a pure white slab, and let it set for 48 hours, and then use a cleaner and clean it, and even the white gets clean. And the beauty is that all the ingredients that are going into it are 100% natural. So I'll take you through, this is the basic process. All the raw material is then put into a compactor, baked. Then we also have a glass fiber mesh at the back. So what happens is, if you know, in maybe a 40-story building, even if a screw falls down from there and hits somebody, that person is gone. At least he'll be hospitalized. So we don't want that. So the glass fiber mesh acts like the windscreen of your car. Even if something comes and hits it, it is not going to crumble. So you have enough time to replace that particular slab, even if some accident does happen. So this is just a video to encapsulate all of that. It will give you a sense of what is happening. So I think that was a very self-explanatory video which encapsulated all the features of the product. So I want to just reiterate, a very famous brand once said, "Daag achhe hain," but I don't think that really applies to facades because we really want it to look new even after 25 years. So apart from, so this is a product that is so versatile that is limited only by the imagination of the architect. Although we are in a forum for facades, I will just take you quickly through some of the applications apart from that it can be used for. So we have commercial, obviously, residential, retail, showrooms, healthcare, malls, stairways, receptions, even elevator insides, because it's a 3 mm thick product. It can fit literally anywhere. So your lift lobbies, even your entire countertops and shutters, interior walls, even swimming pools, because it has a water absorption of 0.1%. So you can use it in swimming pools as well as flooring. These are the 3 different sizes that we have in terms of thickness. One is a 3 mm thick, one is a 5 mm thick, and one is a 12 mm thick in different sizes. We can show you samples at our stall outside. So just to end, I would want to just summarize by saying it's a very, very, very versatile kind of product. So think ahead of all the traditional materials because the future is here. Thank you. That's it for me.
Thank you so much, Mr. Suvarna. Now I would like to call upon Mr. Shalin Shah, who's the director of IPH Glasses, and following that, Mr. Ashit Vora, who's the managing director of Hi-Fab Aluminum Private Limited.
Hello, check. Good afternoon, everyone. And namaskar. How are you guys? Where's the energy? Can't hear. Presentation. So first of all, I'd like to thank whole team of Zak to arrange such an amazing event. City like Ahmedabad really need this kind of event. The facade in Ahmedabad is not grown so much, but in next decade it is going to go in a huge way. So we need more of events like this where people can collaborate, they can discuss and take this forward. So kudos everyone for making it over here. It's such a lovely thing that everyone can make it over here. So without wasting much of the time, let's go to the facades. So let us say, how can you get a flawless facade? So biggest challenge in the time is to have a flawless facades. So imagine I have 2 papers in my hand. Now can you tell me which looks better? Yellow one, right? So guys, imagine this paper is not a paper, it's an annealed glass. If not tempered properly, your building is going to look like this. So just imagine your building looking like this. How would your building look if the glass is like this? Would you like this or would you like this? So let's look over here. So these are some problems with the tempered glasses. So these are the problems which do come in the tempered glasses. If you look at the buildings, you will see this kind of distorted image, endulances, which are not usually nice for the buildings. So let us go through the problems and the solutions. So when you look at this, this is called an oil can or a bistable distortion. However, if you have seen the buildings, right, the huge buildings, a very nice facade scheme, a nice envelope, and at the end of the day, what you see is this. It's an oil can or a bistable distortion in which you can see an image which has been distorted into 2 parts. It's because the glass has been overheated. The next over you see is a hammer or a pocket distortion. The typical problem in this is that once you do once you hit a glass more at the center part, the center of the glass has been heated more and the image which comes out is like this. And roller wave distortion, in this case, when the glass is in the furnace, the edges are being heated more. So what you see is more of a edge kink or a roller wave distortion. Same is with the edge lip. When the glass gets warm at the edges and it's not tempered properly, you will see the edge lift on the bottom or the sides of the glass, where you can typically see over here. This is the problem. The iridance. Iridance is also known as the leopard marks, usually seen when there is uneven quenching which is happening in the tempered glass. So when you look at the buildings, you will see all kind of effects. These are defects, but they are there in the buildings. So how to get solution for this? So with this, we have a state-of-art machinery. It's a European machine where what we do is we do a very precise hitting. We do hitting with convection along with the radiation. So in order to get a very, very precise quality, and along with that, what we do is we have a very nice quenching. So the glass is tempered in such a way that you can see a very less edge tip or very less roller distortion. So the product which comes out is very stable, it looks very straight, and it gives a nice look to the building. And for that, we also do continuous monitoring. A glass has to go through a rigorous testing process in each and every cycle. So in a way, when the glass comes out, it comes out in a very, very nice way, and the flawless or the spotless building look has been achieved. So these are some things we should take care while having a building which is going to have a less distortion, or a building which is going to look flawless or sinless. So first of all, we would suggest that if whenever you tell the glass has to be processed, it has to be processed height-wise, because when you process the glasses, it will go on the rollers and you can see the roller waves or the roller marks. So when the glass has gone in the furnace vertically, you cannot see the roller marks. But if the glass has been installed horizontally, you can easily see the roller waves. So that will not give a good look to your buildings. Selecting the proper thickness of the glass. This is the most important thing. Nowadays, in order to cut corners, what people do is people select the glass of a lower thickness. So in that lower thickness, it would be okay according to the standards, but the biggest problem is that the deflection on the facade. So if there is a deflection on the facade, the view of the building is not going to be the same. What you will see is a deflection on the building, and you will see a deflection like this or this. So ideally the deflection, the active deflection on the building should not be more than 4 or 5 mm. If it is more than that, the whole look of the building would be distorted, and the look is not appropriate. It's not spotless. What I would suggest is that you should usually use heat standard glass in facade instead of toughened glasses, because the heat process of both the glasses are same. But once you do fully tempered glass, there is a lot of air which is going to blow on the glass, and there could be a lot of edge distortion in the case of that. So if there is a facade, you should usually go for a heat strengthened glass for a better optical quality. And equalizing the pressure in the glass, it is the most important thing. If glass is made at a certain altitude and used at a certain altitude, what will you see is again an unequalized glass. So in order to equalize the pressure of the glass, we have to put argon in the glass. So if there is an argon filled in a glass in appropriate way, the final result would be a very, very flawless glass, and the total look of the building is going to be amazing. Just like this, you can see the reflection of the building with no or minimalistic distortions. So now let's come to coming of the age technology. It's a digital printing in the glass. So new technology nowadays, what we are doing is a digital printed glass. So initially we used to print on a glass, but it was with a UV ink, which was not exterior product. But now what we do is we are printing on a glass with a ceramic ink, and it's a pre-heating process. So we print on the glass and we then do the tempering process. While doing so, the ink becomes part of the glass. It's amalgamated in a glass in such a way that it becomes forever. So for exterior, it is a very good product. It is a coming of the age product. So let me take you through some of the advantages of these inks. So basically what we can do is we can play with the opacity, and we can also have it in jumbo size. We can have a single glass of 2.5 meters by 4.5 meters. That's a huge, huge size of glass. We can have an amazing kind of accuracy. It can go up to 1440 dpi, so it's very precise. We can do almost any color on the glass, and it's very easy. Whatever the design is, we can easily incorporate that. So it's a very easy process. It's done very precisely. So I'll take you through some of the projects which are done internationally with this technology. So this is an hospital done in Texas. So outside the building, you will see a tree branches, but eventually they are written the name of the donors. So this is again a building in Holland. What they have done, they have printed a glass, but it was done in such a way that you don't feel claustrophobic. There's enough light and view coming up. Still, it will give a very nice look to the building. This is a building in which typically the light is given from inside. So this is again, the possibilities are endless. When we are talking about printed glasses, we can literally do anything with printed glasses. So these are some of the building in France. It's an origami building where they've printed onyx on the facade of the building and they have used it. So onyx can be used in a second skin. So whatever the surfaces which you want to incorporate can be easily incorporated by using glass as a substance. And again, the life of this ink is more than 25 years guaranteed. So there is no problem whatsoever in using this glass on exteriors. This is again a project from China. So these are some of the projects been done by us. So this is a project done in Surat where we have installed a digital printed glass for a clubhouse in a residential building. So the challenge of that building is they just wanted a 50% VLT. So what we have done is with the design, we have allowed only 50% of visual light which is going to come inside. And there's a logo which is nicely incorporated at the center of the building. So this is a building in Gift City. It's a Bombay Stock Exchange building. It's done by Morpho and we have done the designs for these buildings. So the sun path analysis of the building was done in an appropriate way and the designs, the printing in the glass was done in order to incorporate the sun shading, and the south and the west of the building had the deep designs and north and east had the light design. So we can play with the designs in a way that we can give a spotless look to the building, we can give a nice aesthetic looks, plus it's also functional. So these are some of the projects we have done, but this is just the beginning. We are about to go much longer because this is a new technology. We will need all your support. Let's build it together. This is just the beginning. Picture abhi baki hai mere dost. Thank you.
Zoom in. Apachadaan. Good evening. Yeah, little bit confused. थोड़ी देर पहले मिस्टर वीवा में से फजील ने बोला कि गुड इवनिंग, बाद में माय फ्रेंड स्पोक गुड आफ्टरनून, तो मैं सोच रहा हूं गाड़ी रिवर्स में जा रही है क्या? पर्टिकुलरली आज की इवेंट में वी आर वन ऑफ द स्पॉन्सर, तो कुछ ऐसा था नहीं कि भाई मैं मेरी कोई प्रोडक्ट दिखा सकता हूं, लेकिन बाद में श्रद्धा वगैरह बोल रहे हैं कि भाई आप स्पॉन्सर हो, आपको कुछ तो आपको आपकी जर्नी के बारे में बताओ. तो लेट्स स्टार्ट विथ माय सम ऑफ द कॉम्प्लिकेटेड प्रोजेक्ट डन बाय हाईफैब, और उसमें क्या क्या कॉम्प्लेक्सिटी थी उसके लिए मैं बात कर रहा हूं आपसे. These are some we are sharing some challenging facades in my journey of HiFab. This is Mahatma Mandir, which we have done in 2010. Particular this facade, we have done this facade. This is 40 degree, 15 degree incline. At that time, कंसेप्ट ऐसा बनाया था कि महात्मा गांधी ने जब दांडी कूच किया था तभी उसका जो लकड़ी पकड़ा था वो 15 डिग्री पे था, तो पूरा बिल्डिंग 15 डिग्री टिल्ट करके बनाया था. ये कंसेप्ट था, और तभी ये प्रोजेक्ट में सब रॉ मॉड्यूल ग्लास थे. ये पहला बिल्डिंग था जिसमें हाईफैब ने एल्यूमिनियम और ग्लास स्टील दोनों स्ट्रक्चर के साथ, क्योंकि एल्यूमिनियम 40-45 फीट की हाइट पे स्ट्रेंथ नहीं दे रहा था, तो पूरा स्टील बिल्डिंग पे पहले फसाड बना, उसके बाद एल्यूमिनियम और ग्लास लगा था. उसके बाद हम लोग वेरी कॉम्प्लिकेटेड स्ट्रक्चर वाज देयर, और ये बिल्डिंग हाईफैब ने सिर्फ और सिर्फ 45 डेज में कंप्लीट किया. एलएनटी ने ये बिल्डिंग 180 दिन में बनाया था, जो वर्ल्ड रिकॉर्ड है, आज भी वर्ल्ड रिकॉर्ड है. जो साइज का बिल्डिंग 180 दिन में एलएनटी ने बनाया था, बिकॉज तभी मिस्टर नरेंद्र मोदी का ड्रीम था कि मेरे को वाइब्रेंट गुजरात यहां करना है, और 12 जनवरी को उसका ओपनिंग हुआ था 2011 में. उसके बाद एक प्रोजेक्ट की हम लोग बात कर रहे हैं जो 2017. हाईफैब हर 3-4 साल में एक प्रोजेक्ट ऐसा करते हैं हम लोग, प्रिफरेबली के जो पैशन है कि जो नॉर्मल बिल्डिंग फसाड से वो बिल्डिंग में कुछ नया है. ये बिल्डिंग फसाड भी हमने इस तरह से लिया था. मैं शिवालिक शिल्प की जो बात कर रहा हूं, तो ये बिल्डिंग में बहुत चैलेंजेस है, क्योंकि नॉर्मली हम लोग जब भी बिल्डिंग बनाते तो फ्लोर टू फ्लोर हाइट की वजह से आपकी हर एक बिल्डिंग की पैनल की साइज लेंथ फिक्स हो जाती है। ये बिल्डिंग में अगर साउथ साइड आप देखते हो तो साउथ साइड 10 डिग्री फसाड थी, ईस्ट साइड 7 डिग्री फसाड थी, नॉर्थ साइड 0 डिग्री थी और वेस्ट साइड 30 डिग्री थी। और सबसे बड़ा चैलेंज था ये प्रोजेक्ट खत्म करने में हमको आया कि कॉर्नर में 7 डिग्री, 10 डिग्री और 10 डिग्री और 0 डिग्री वो फसाड के कॉर्नर कभी मैच ही नहीं हो रहे थे। ये प्रोजेक्ट खत्म करते करते हमको बीयू के हिसाब से ये पहले हमने टेम्पररी स्ट्रक्चर करके भी ये फसाड बना दिया। उसके बाद अलग अलग पैनल का हमने 3D मॉडल पे बनवाया और उसके बाद काम किया। इसके बाद हम लोग ने एक अच्छा वापिस 3D फसाड का एक प्रोजेक्ट किया था मोटेरा स्टेडियम। मोटेरा स्टेडियम में ये पूरे जी एल्यूमिनियम शीट की क्लैडिंग लगी है, 3 डायमेंशन सीट्स है और ये सीट हमने नीचे स्ट्रक्चर बनाया, उसके बाद पूरे स्ट्रक्चर पे सीटिंग किया, उसके बाद हमने क्रेन से लगवाया। अगेन चैलेंजिंग जॉब। ये सीट हमने चाइना में बनवा नहीं पड़ी, इंडिया में कोई बना नहीं पा रहा था, ये हिसाब से पूरे शेप में देना था। इसके बाद अभी रिसेंटली एक प्रोजेक्ट किया इंडियन प्रीमियर लीग, इंडियन पोटास लिमिटेड, सॉरी आईपीएल चल रहा तो इंडियन प्रीमियर लीग जल्दी आ जाता है। इंडियन पोटास लिमिटेड, ये हमने सुको के साथ किया, वेरी गुड। इवन शिवालिक शिल्प भी हमने सुको के साथ किया था। बहुत चैलेंजेस थी, उनके सपोर्ट भी अच्छा था, हम लोग ने काम खींचा। ये काफी चैलेंजिंग प्रोजेक्ट था जिसमें ओपनेबल भी ट्राइंगल शेप में पूरी की पूरी पुश आउट विंडोज है, कुछ 100% चीजें कस्टमाइज बनानी पड़ी। उसके बाद मैं अभी एक ऐसा प्रोजेक्ट की बात कर रहा हूं जो विनस करके, विनस स्ट्रेटम, जो हमने लास्ट में जो प्रोजेक्ट किया, जिसमें हमने लाइफ फसाड इंडस्ट्री में ऑलमोस्ट एल्यूमिनियम और ग्लास में जितनी भी आइटम आती है वो सब है ऑलमोस्ट इसमें आ गई है। वो प्रोजेक्ट की अभी हम लोग बात कर रहे हैं। सॉरी, बीच में ये पैलेडियम मॉल, अगेन उसमें भी 3 डायमेंशन सीट्स बनाया था कि जिसके अलग अलग कॉलर थे, उन्होंने लगाई। रिसेंटली अभी उसका ओपनिंग हुआ है। हाँ, अभी मैं बात कर रहा हूं विनस। विनस में फ्रंट में और ईस्ट वेस्ट, फ्रंट मतलब नॉर्थ फेसिंग और ईस्ट वेस्ट तीनों साइड यूनिटाइज फसाड था। साउथ इंटरनल फसाड था, 4th फ्लोर से ऊपर तक एक एट्रियम बना हुआ है, वो सब फसाड सेमी यूनिटाइज था। फ्रंट में इवन नॉर्थ फेसिंग में केबल नेट सिस्टम भी है और उसमें क्या क्या चैलेंजेस है उसकी भी बात करता हूं। और साउथ में हमने बनाया था स्लिक फसाड, जो इंडिया में फर्स्ट टाइम 70 मीटर हाइट में किसी ने बनाया है। अच्छा, विनस की बात करें तो विनस में हमने ये प्रोजेक्ट में फर्स्ट टाइम अहमदाबाद में कोई भी रियल एस्टेट डेवलपर का प्रोजेक्ट में टेस्टिंग कराया, तो ये प्रोजेक्ट में टेस्टिंग हुआ था। टेस्टिंग में ये टर्बाइन फैन से 200 kPa तक विंड प्रेशर देते हैं। उसके बाद जरा एक टेस्टिंग का भी छोटा सा वीडियो, शायद वीडियो निकल गया है, नो प्रॉब्लम, चलेगा। चलेगा, नो प्रॉब्लम। तो वीडियो में बेसिकली जैसे रेन वाटर टेस्ट और विंड टेस्ट कैसे किया जाता है उसका एक छोटा सा वीडियो था, जिसमें थोड़ी देर पहले डिस्कशन में भी मैंने बोला था कि कास्टिंग चैनल वगैरह जो पीटी स्लैब था, तो कास्टिंग चैनल वगैरह शुरुआत से लगा था। बिल्डिंग जब से स्टार्ट हुआ तब से हम लोग ने, हमारी टीम साथ में पैरेलली वर्क कर रही थी। उसके बाद ये यूनिटाइज फसाड है, जो इंस्टॉलेशन के भी कुछ फोटोग्राफ्स है। साइड में ईस्ट और वेस्ट साइड यूनिटाइज फसाड के ऊपर फिन लगी है। फिन के लिए इतने सारे ड्राइंग्स हमको बनाने पड़ते थे, हर एक फिन डिफरेंट साइज की थी। एक फिन का अगर जूम आउट करें तो ट्राइंगल कॉर्नर एक के ऊपर एक बिठाना है। आप वो बिल्डिंग को ध्यान से कभी रोड पे से निकलो तो आपको आइडिया आएगा कि ये टाइप की फिन थी। और एल्यूमिनियम 2 mm 3000 एलॉय की सीट लेके हमने ये बेंड करवा के काम करवाया था। उसके बाद ये इंटरनल फसाड है जो पूरा सेमी यूनिटाइज फसाड है। अच्छा, ये बात करें तो ये केबल नेट स्लिक फसाड है। स्लिक फसाड 70 मीटर हाइट पे इंडिया में फर्स्ट टाइम हमने इंस्टॉल किया है। इंडिया में कोई भी कॉन्ट्रैक्टर ने आज तक स्लिक फसाड नॉर्मली डबल हाइट ट्रिपल हाइट में यूज करते हैं, लेकिन वो ज्यादातर ग्राउंड फ्लोर पे ही लगती है। ग्राउंड से फर्स्ट के एट्रियम को थोड़ा सा ज्यादा रिचनेस देने के लिए बनाता है। लेकिन ये प्रोजेक्ट में एमएस के स्ट्रक्चर हर 10-10 मीटर पे स्ट्रक्चर लगा हुआ था। वो स्ट्रक्चर भी हमने लगाया था। ऊपर का जो गेबल वाला स्ट्रक्चर है वो 16 टन का स्ट्रक्चर था, वो भी हम लोग ने इंस्टॉल किया था। ये फसाड में पर्टिकुलर बात करें तो ये एल्यूमिनियम एलॉय 6061 हार्ड एलॉय से हम सेक्शन बनाया था। उसके ऊपर एसएस के फिटिंग लगे थे। उसकी एक थोड़ी सी टेक्निकल डिटेल साथ में दी है। ये एसएस के ब्रैकेट्स उसमें लगे थे। अगेन एक सबसे अच्छी एक्सपीरियंस सबके लिए कुछ नया एक्सपीरियंस था। ये केबल नेट फसाड हम लोग ने जो की उसमें हमारा जो 100% एक्सपीरियंस हमारा और किनलॉन को काफी कुछ सीखने मिला। क्योंकि ये लगाते के टाइम हम लोग ने किनलॉन से चाइना से टीम आने वाली थी। वो लोग ने बोला कि हम लोग इंस्टॉलेशन में आपको हेल्प करेंगे, लेकिन बिकॉज ऑफ कोविड वो लोग को इंडियन वीजा मिला नहीं, आ नहीं पाए। वीडियो देख देख के हम लोग ने ये इंस्टॉल किया। ये सब केबल टाइटनिंग मशीन वगैरह में जो ये केबल लगता है उसके साथ ईयर प्लेट वगैरह कैसे फ्लोर में इंसर्ट किए उसके साथ लगाना है वगैरह, उसके टाइटनिंग मशीन के टाइम एक चीज ऐसी हुई कि जो नॉर्मली आज सबको ध्यान में लाने के लिए खास ये पिक्चर हमने रखा है कि ये केबल नेट स्ट्रक्चर यहां आना था, फिक्स था। क्लाइंट ने दिया था कि आप प्लेट इंसर्ट कर दो। कंस्ट्रक्शन के टाइम प्लेट इंसर्ट किया था, लेकिन जब इंसर्ट किया था स्ट्रक्चरल इंजीनियर वगैरह ने जो लोड कैलकुलेट किया था, वो डेड लोड कैलकुलेट किया था, वो हिसाब से प्लेट लगाई थी। जब ये केबल लगाना पड़ता तो दोनों को सामने खींचना पड़ता है। उसका टाइटनिंग मशीन से हम लोग ने केबल को जब टाइट किया तभी प्लेट कंस्ट्रक्शन में से निकल गए, उसके सलिए टूटे हुए ये फोटोग्राफ में दिख रहे हैं। तो ये टाइटनर मशीन से ये निकल गया। तो नेक्स्ट टाइम अगर केबल नेट स्ट्रक्चर किसी को भी बना, बहुत ही प्यारा स्ट्रक्चर है, लेकिन उसमें ये सब चीज ध्यान में रखनी पड़ेगी कि जब आप इसको फिट करते हो तभी इंसर्ट के टाइम आपको थोड़ा सा ज्यादा प्रिकॉशन लेने पड़ेंगे। दैट्स ऑल। एक छोटा सा वीडियो हमारा जो इंफ्रास्ट्रक्चर है उसका मैं एक आपको जाएगा।
1 मिनट आप मत।
Thank you.
Thank you so much, Mr. Vora, for the beautiful presentation. I would like to just conclude on the third session. And now I would request everyone to move forward for the tea break and the networking session. The principal architect of Studio Upkarma, sir, please come on the stage.
Are we good to go? Come to Jagrut bhai. So we're good to go. So first of all, it's Upakram. That's okay. I thought I would correct you on that. The first foremost thing where I think instead of my introduction, I would just rather focus on the questions which were put up. And I think the future of existing building, or rather I would say in a way, how do we look at our designs? And that being one of the questions, I have selected just 3 projects which I can probably discuss further in detail and cover those aspects. So beginning with one of our upcoming residence projects. So 3 different scales, 3 different applications, and which could cover the kind of thought process or the design ideologies we follow. Keeping that in mind, this is one of the very densely located locality of Morbi, where client wanted something really properly accommodating their requirements, but that being on a dense located site, the concern was also about providing them with natural light and ventilation, of course, with the larger size openings. But at the same time, since this is on a right junction, how could that be given privacy, number one, also to cut down on the natural light, where we could actually make it more interactive and dynamic for the people who are moving around as well. So starting from there, we thought, first of all, accommodating all the requirements were in place, and then seeing how we actually can make it more interesting from outside without making the internal quality of space compromised. So the first thing was that the openings right on the corner, how could that be covered with some sort of a screen which could actually have that dynamic approach while person is moving around, cannot look through the windows directly, but at the same time, people inside can actually have a very nice view outside. So this is what the overall perception was there when we are doing this, that it has that statement, it has that overall language, which is of course setting it different from the surrounding buildings, but at the same time, in itself, it has some good open spaces where they can spill out. This being on the junction, also the treatment towards the facade was more challenging because the parking being on the ground floor and the actual living is happening on the first floor. So when we are seeing the overall language in this house is very much prominent when we have all the parking spaces covered with the jalis. At the same time, the living spaces, which are the main areas, are having those opening and spillovers. They can overlook the surrounding areas. At the same time, the upper floor, where they have more of balconies with the bedrooms, are having some punctures and screens to have that open and closed look. So this is what we see in the, while we are at the corner, while we are approaching the site. And this is right opposite, giving an idea that there is enough of light and ventilation happening through. And this screen is kind of making this overall form bind together instead of making it kind of a broken pieces. So this was very interesting exercise because Morbi being one of the very challenging clientele base, because then having them accept this overall language of contemporary architecture was very difficult. But then yes, when they understood the concept and this fulfilling the requirements, they agreed to it, and that's how this is. And the current stage, the civil work is over and we are in process of finishing it from the outside. Coming to another exercise which I think was in my probable this whole span the most challenging exercise ever. Client came up with a requirement of having an existing building where the foundation of the building is completed, basements are already executed, the building is at ground floor level, and we were supposed to redo the planning. Now that was something which was one challenge, but other than that, the idea was that they wanted to make it also a very interesting building because it has a very prime location. So this is what the earlier planning was, and clients were not having their, of course, the sellability was one of the criteria, but at the same time, the overall planning was not being able to get that acceptance from the customers they were having. So number one, they wanted to change the planning, but not by demolishing or scrapping off the existing structure. Now this being said, for a G+1, 2 or 5 story building is still understood, but this is a 70-meter building with 22 story. And having this whole 2-meter raft constructed at the basement and changing that was not making the project feasible. And this is what we came up with: simplifying the spaces, retaining the actual grid, and still trying to maintain that openness inside the layout. What we were trying to do here is that this being one of the tall buildings on the very upcoming locality, might as well provide them with plenty of view and spillover areas again as balconies or terraces, and then have some way we could engage with vertical gardening to make it more sustainable in terms of since Ahmedabad being very dry, hot climate. And then this is what we did to make it more controlled in terms of sunlight penetration inside the building. At the same time, kind of giving it a different language than what exactly is happening in and around these tall buildings. So number one, this is partially ventilated facade system, partially because it already has certain loads and certain specifications to follow, but at the same time, the building having large openings was one of the concerns when we are talking about a 4-bedroom house with such large openings and the balconies directly letting the sun penetrate through the building. These were pretty much necessary to control the overall heat. So with the simulation and the heat penetration diagrams, we could actually come up with those vertical panels, which are actually the perforated panels, which cuts off the glare, at the same time the direct sunlight, at the same time it also provides a very nice overall skin, a character to the building. Zinc being one of the prominent material, because this overall application required something which could sustain for long. As a Upakram, we strongly believe in sustainability and believe that the zinc should be the only material which could complement this whole idea, or the kind of very precisely fulfill the requirements of a high-rise building with a structure which would last for long. So of course, these all parameters being covered, further comes the areas where one can actually enjoy that cup of tea, but at the same time, not blocking the whole view. So there are series of images put together. The first one is, of course, the balcony keeps changing as per the overall graphic changes as per the facade. At the same time, when we give a close look, is when there is a very nice play of solid and perforated translucent surfaces. So that is what makes this overall building come out really nice as a play of translucent and solid. That's the montage the artist tried with. Yep. So even the bedrooms having cross-ventilated areas at the same time, they're having those fenestrations again being controlled with those perforated screens, which could play a very significant role in cutting down the heat. Going further, this is one of the commercial projects where we had very simple understanding of having a commercial floor plate, which is just repetition of floors, one above another. The idea was that, of course, when we are looking at the building, the play of floors and the breaking the volume comes into the picture. But when we are dealing with certain feasibility and statistics, we can't overrule the mathematics here. Doing that, we still wanted to challenge the overall character of the building, and we wanted to break that monotony of having the repetition of the floors. So what we did was we just started with the basic, broke the grid, and then fragmented them in such a way that it actually loses that understanding of scale. So when we are looking at the building, it should not have a very distinct floor levels demarcated in the building. And this is what we did further. So the grid is basically a kind of an envelope which allows floors to be combined at certain level and broken at certain level. And when we are seeing at them as a completed building, this is what the impression would be in the end when the building kind of has that fragmented, deconstructed overall grid, which has a very playful element in the front along with the parametric glass facade. So these three projects, when we are talking about, I covered because one of the questions which was Shraddha had put across was that what are we looking at in terms of future of the building? Now, future of the building, when we say the sustainability is one of the core area where we are trying to cover the whole thing. What if we derive some system? What if we try to see if there are certain techniques by which we can encourage and incorporate ventilated facade system, which could really work as a skin, as an element, change the overall play, at the same time provide a very good prediction with the heat, has a very nice modern look towards the building. At the same time, it kind of changes the graphic of the city. So this is something when I selected these three projects, one of the key element here was that we are trying to do a parametric integrated design solution which could really work well in terms of executing the building within this context of Ahmedabad. So I think that is all, if there is any question or anything specific to be asked. Are you good? Yeah, thank you. Yes, sir. Yeah. It was designed for the 70 meters. It was designed for 70 meters. The raft was 2 meters, constructed whole side raft, like a full raft was constructed below basement 3. So there were 3 basements.
And what's the size of that project?
This the project is 4 lakh square feet.
No, the unit size.
The unit size is around 300 square meters net.
300 square meters.
Yes.
Okay. And you have given 4 balconies.
Yes.
I just was thinking that is it not too many balconies that you could have done with 2 bigger than giving?
So there is only in 1 unit, which was making it more feasible.
Okay.
But having that proportion right, the other requirements, so there were like kind of statistics derived by the client themselves that this is what our North India based clients really want, because you're having a 3-side open flat. this is the kind of segment we want to cater to the Gujarati clients, which is like, specifically very conscious about the ratio of open versus internal spaces. And catering to that, we came up with this solution that might as well, the front tower could have more balconies, which are kind of sky decks, and the internal one could be the smaller ones. So that varies from 6,000 to 6,600 sellable.
Yeah. The only thing.
So that requirement came from client.
It's the question that came into mind. Should I have, if I would be designing, should I be doing that or not? So that was one question that came into my mind. So I asked you.
Sure.
Because a lot of times, maintaining 4 balconies is a big issue.
Correct, sir.
And there are a lot of problems because this is a practical issue which I am also facing. A lot of apartments, they get occupied at different stages.
Correct.
And so kabutars and birds and so if I'm living at the lower level and nobody is occupying that, there is a balcony there and I have to listen to those speeches. So these are those challenges
So, sir,
that we need
this
to
same
resolve
question, the same question we had put across the client, that when we are talking about 70-meter building and such projections, you should also be talking about the maintenance of the building.
Yes.
So they said that we are talking about a niche category customers who wouldn't mind spending a little more for the maintenance, and we would be doing it for them.
So you're going to do the maintenance, the balcony and everything?
Yes, yes. So the builder is going to do entire thing and they've got this contract and everything. So the system was to actually look at a solution which could really cater to those volume.
Oh, no, but it was a good thing.
Thank you.
The previous design has been really done nicely. I saw it previously and I felt that it is not going to be accepted by the client. Yes.
Right.
So I think so my vision was right in a way. It was.
Thank you, sir.
It was nice. Good. I like your way we have done the facade.
Thank you so much, Mr. Bijlani. It was a beautiful presentation. Now I would like to call back Mr. Gautam Bhasin for the panel discussion. Could you please invite the other guests?
Thanks again, Nimit. The last good evening for the day before the vote of thanks, and congratulations to everybody who survived in the room. So I'll start inviting the panelists, and I think we've heard that Ahmedabad is going high every year, 75, 100, 150. I think the high-rise barrier is being breached. So today we are going to discuss glazed curtain walls in high-rise building and its challenges. And I'll start with the engines that drive this conversation, the architects. Jagrut bhai, I'll start with you. Jagrut Patel from Jagrut and Partners. Snehal Sutar from the Grid Architects. And then we can't forget the person who controls the engine, the developer himself, Abhileshji from Adani Realty. And then people like us who are basically just bogies following the train wherever it goes. It'll be myself, partly representing the moderation panel, but also looking at the consulting side of how facades are actually developed. And lastly, Nivedita, people who actually materialize the facades that we put on the buildings. Welcome everyone. 5 minutes have been taken away from our time, so we'll try and keep it as swift as possible. So like every good question paper that we get in exams, you have objective type questions. I'll start one with that where it's just 3 words when it comes to challenges in high-rise curtain wall, high-rise facade design. Just simple 3 words that come to your mind when you think about challenges that you encounter with design. I'll start with you, Nivedita.
It's
working.
It's working? Yeah. Right, so thank you, Gautam. I hope I'm audible enough, right? And this voice is good enough to break the, gloominess which we had. Anyway, so the 3 words, I will keep it short, because in the interest of time, I would say the loads, yeah. So the wind load, the seismic, the thermal, all of it.
I'll make notes.
Installation, big challenge when it comes to high rises. And of course, safety, which although it's being said the last, but not the least, it's very much crucial and critical when it comes to high rises. Yeah.
Wonderful. Quick 3 words. Jagrut bhai.
So, of course, Jay's mentioned few of them, but not to repeat them. Maintenance is one very critical issue when you do a high building, because a lot of times, you can make a tall building, but if something breaks, and safety, because if something falls from that height, or if something happens, an accident happens at that height, it is very difficult. Secondly, replacing also how it has been done. So if it breaks, and if after 10 years, people think of the immediate future. But if we need to put a building design for 25 years or something like that, and start thinking for that next 25 years and not for that facade. A lot of times, I feel that facades are being designed for sales, and it should not happen that way. It should be designed beyond the sales, because it has to be there for long period of time. So safety is one thing, of course, wing load, the engineering, and the manpower, the ecosystem available to execute it. Sometimes we really design something very beautiful, but then we don't have the people to execute it in the way we want it. So I think these are the 2-3 major things that I feel.
Very well covered. Mr. Jain.
Good evening, everybody. I'm Abhilesh from Adani. See, basically, when a high rise comes into the mind, first one is I need a very pre-qualified architect and the consultant. The second part is the parameters. The parameters where actually the high rise building is and what is the height of the building. Third and the last, which is, it should be maintained and operational. Because the maintenance point of view is very important. First we make it ready, but end of the day, when we start rectifying the things, the project looks very ugly. So basically, I would go more into the operational and the functional point of view, and not last is the cleaning. The cleaning of the facade system or any high-rise, whatever the system we are developing, needs to be taken care of.
So I will go for safety. Maintenance, of course, these are the two major factors. And accessibility. And the main thing is context. I think context is very much important part, whatever you design.
I think that's a wonderful segue into the next question, and I'll still continue with the architects. Building ideas obviously conceived on your drawing board, right? Client comes to you with a brief. I want a high rise, could be commercial, could be residential. It is conceived on your drawing board. When it comes to high rise, how is the approach different from something that is ground plus 2, ground plus 3, ground plus 4? What comes into picture when you imagine somebody working at 75 meters or living at 100 meters? How is that different as a design approach compared to a regular building? We'll start with you.
So when we design a tall building, the first thing is, the safety of that person, because at that height, wind is also there, wind pressure. Sometimes a slight, movement of the building also puts a lot of stress on the facade. You need to make it a little flexible also. So it's not that, it cannot be that rigid. So those are the factors that come. Safety is the prime thing, because it should be something which, also little bit of abuse also will happen. So we need to also think of those abuses and misuses, because you cannot educate every client at the end of the day, ye mat karo, wo mat karo.
So true.
So I think so. We also need to start designing for a little bit of abuse of a design than just the use.
Make it foolproof in a way.
Make it foolproof, or maybe stupid, no? Like management bolte hain, keep it simple and stupid. Yep. So we don't need smart attitude to use it or something like that. So that is one thing. Secondly is the simplicity of execution, because when you are doing a high rise, then if I make a very complicated design, the cost will matter, the maintenance will matter, and the refitting and retrofitting would matter. If, let's say, after 10 years I want to replace something, and if I've done something customized, if I go for something odd shape, to get that shape again is going to be a big challenge. So we try to make things which are more repeatable. Secondly, what kind of labor is available? If I'm going to do something in Ahmedabad, versus Bombay. Bombay, you have more ecosystem which does tall building, but Ahmedabad is a new field. So you cannot do too complicated designs. So those kind of things has to be taken care of, because currently we did few high rises and we had to get lot of things from outside, something made in Dubai, something made in China. So we need to also see that how, what kind of ecos, and then that delay, that makes the project delay also. And a lot of commercial projects don't have that luxury of timeline. So your details also have to be in that alignment of availability.
Yes, guilty as charged.
Yes, as Jagrut Bhai mentioned, safety is the first priority, and thereafter make as simple as you can, because it, it requires lesser maintenance. I think that is the two factors, and it has to be sustainable, of course. And sustainability, I think that is one of the criteria we would, of course, look after.
Please. Creative engineering, which is missing. We do creative designing, but we also need to start doing creative engineering with creative designing. Because engineers say कि मेरे को फंक्शन करना, ये 4 बोर्ड लगा दिए चलेगा, एग्जीक्यूशन में भी 4 बोर्ड लगा दिए, पर अच्छी तरह अलाइनमेंट में लगाना. Even if it is not something which is very visible, but if you really creatively and with aesthetic we do, the whole design comes out differently. Lot of times we think back end है तो चलेगा, ऐसा नहीं होना चाहिए.
I think geometry also matters. When you think about tall building, geometry plays an important role as far as structure stability is concerned.
So where does that really start? Getting the geometry established, materials, bolting. I know I'm being cornered every time Jagrut Bhai looks at me and is like, creative engineering bhi chahiye, khali hamara creativity nahi chalega. So that obviously is a very, very valid point where the entire team needs to work in sync, work in conjunction, try and come up with a more coordinated solution, so to speak. But in terms of geometry, where does it start? I mean, obviously, having the entire team in place on day one is important so that you can keep getting feedback and that starts informing the architecture. But also at the same time, I think architects have that sort of cyclic role to play to keep incorporating all that in the design, so it becomes a little more informed at the time where we actually start documenting it for construction. So great point. I have another follow-up questions. Always love conversations with architects about this. What are your best practices, best architectural practices when it comes to purely high-rise? Obviously, safety is one, barriers being established. But when it comes to somebody going from a low-rise to a high-rise, he still wants that low-rise experience while living up there. Ventilation, operables, etc. How is all that different when it comes to high-rises?
Frankly speaking, what I feel is facade should not be looked at something which you need to look into. There should be some function of that facade. And we need to also focus what is the real function that facade should perform. Okay, you are not just designing ke acha dikhega, glass laga do. But then what is the function? What do you have? We want to give a view, or you are in a place where view is not important. Then glass does not make a sense, because if there is, if the 360 view is not something, it's not a C or it is not something, then my facade will be different. And if there is a C, then my facade and everything will be different. So my context will decide what kind of facade I will do. That is the first thing when we design the facade. Now when we are going high, the engineering is going to be the most important part of that thing. Okay, you can be little okay with something which is done at 2 or 3 floors, but when you go high, when you go tall, the load, the pressure, the performance of the each and every component matters, and you have to be very mindful of that. Your detailing also should not be so challenging for the engineer that it is going to take him, to resolve something which is out of. Of course, if you have the budget, you need to step out of the comfort zone also. But a lot of times, when you are doing an average building, every time step out नहीं करना चाहिए. जो simple है proven वो कर लेना चाहिए. उसमें हमको नहीं दिखाना है कि हम इतना अच्छा design कर सकते हैं. But then it has to sustain itself with the finances also. So that is also one thing which is very important.
think true experience has spoken there. You should not try and push too much where you know that things will not go that far. Correct. Yeah. Yeah. So use your energies in the right place, simplifying it where it deserves simplicity. And create more problems along the way. Yeah. Great, great, great thought. You want to add something to that, Snehal? How is the process different? How is the design approach different in high rises?
I think I'm not too much for glass. Okay, I think looking at the context where we are working, as I mentioned you before, I think context plays a major role, and you have to be honest about it. Work honestly. Okay, you don't have to show to the world that this you can do. I mean, everybody is creative, and nowadays, you know, everything is available on net. If you are making glass building in Ahmedabad, I don't think so it's going to, I'm sorry, glass manufacturer, but I'm not too much for glass. Particularly, I'm considering Ahmedabad or Gujarat, where 45, 50 degrees temperature. Why can't we use our conventional method? Why can't we use screening and the way Karthik has used? That is a fantastic way of attending the facade. We have lot of, you know, heritage. See the stone jalis previously we used to use in our old buildings. I mean, the fantastic.
But I feel that glasses are also in technology improving, where you have nanoparticle fused glasses where the sun is getting cut, where the UV rays and everything are reflected. Glass is going to be the choice of the end user. We need to also be understanding that there is an end user who wants to see outside.
Yeah, of course.
And he wants to enjoy that view.
I do
so
agree.
We are catering to them as a designer.
You have to, at some point, you have to use your wisdom, being an architect. I think wisdom, you have to use your wisdom being an architect, and you have a responsibility for environment. Building is not only about indoor spaces. Building is also about the outer spaces. You know, imagine the glass facades are affecting the outer spaces. You see that it is heavily disturbing the biodiversity. Look at the bird. How many birds? They can't see the obstacles. And what about the heat load or radiation which is coming to the land? It is disturbing the biodiversity.
So
Heat
again, no
islands.
wrong answers here. Every approach is right. I think what Jagrut Bhai said leads to my next question. That's for you, Abhilash ji. Now, obviously, high-rise design is demand-driven, right? People want to go up, better view, possibly better air quality as well. What is your brief to your designers or your design team when it comes to high-rises?
Basically, first thing with high-rise in a design part is that for one thing, it should be a very functional. Second one is basically technically whatever they are designing, it's that person is able to give that workmanship what is required by the developer or by the end users. And the third and last is that the safety aspects, whatever is been designed and provided, all the safety aspects have been taken care of. If I say particularly in a high rise, before utilization of any system, let a PMU happen, because the first cost of the PMU is going to save you from any disaster in the future. And last not least is basically the maintenance point of view. Any replacement easily available material required, or we need some alternative which can be replaced available material. And last not least is a wind load, basically, which most of the time what happens, the wind load, which is a factor which plays a very vital role in the high-rise building. Most of the time when the cost comes into that factor, the people forget the designing part and just thumb rule basis the conventional systems are betterly used, and you know, then that doesn't work. That's rattling sounds are there, then a lot of damages are there, and then when it with the age you see the things get decay. You know, you can identify the building which was 2 years before done the facade is now basically not looking like a new building now. So that all the factors which in a high-rise building especially needs to. The last not the least in the Ahmedabad world, where we see in the high-rise building, the PG&Es are really the issues, big issues. So whatever design they do, they don't provide the ledges or the berths allowable to be within that building. So that are these factors which I oversee these things. Plus, the vertical movements basically in the high-rise building should be well elevators,
Yeah.
staircases.
Yeah.
So during the crisis, during the any fire breakdown or any problem, easily we can shift to an assembly point wherever it has been decided upon.
Snail.
So pigeon is a major problem, So again, I'll come to the biodiversity. So previously, 20, 30 years back, the problem was not this much because there were eagles, kites, vultures were there, they were maintaining the biodiversity. Nowadays, vultures are extinct, no kites.
So
In
pigeons,
Dubai-
pigeons have overtaken the city then.
Yes.
Basically, if you see now, due to pigeons, if you see in the facade also, whatever basically the cladding part, if you see, after 3-4 months, you can see all the sittings, and the cleaning system, it's not you can't regularly do in a week times. At least a month, you need a month time to do the regular cleaning. So that all are the factors basically. It's a very minor, but it can be addressed also properly if the planning is done properly and designing are being done.
So all the companies have an idea that they can provide a pigeon-proof facade and it will sell like hotcakes.
Bring back the kites and vultures. New campaign.
They also have a business opportunity to provide a material which is pigeon-proof or something like that.
Or we build a building for the pigeons in the city somewhere so they can all house themselves. Great. I'm going to throw a little bit of sparks into the fire that started with the previous questions, and that's open to that side of the room. We'll just stay safe here. Is glass curtain wall the right answer for a high rise? And I know there'll be some diverse views on the dais here.
It is right for the commercial building, whereas in the residential building, I would prefer percentage-wise 30-70. Basically the glazing part, the light where they need a light needs to be glazed.
That is 70.
30-70 basically. Rest in the residential 70% can be a basically solid type of, wherein the good ventilation system and the protection system is there.
I think again context and orientation. You see where is the north, you see where is the east, and then you decide. Again, being an architect, you have that wisdom how to use glass. As simple as that.
So I have a sort of short segue, a follow-up to that. Like if not glass, what are the alternatives that you typically explore as a part of your design process? Are there other materials?
Yeah, many materials are available.
Yeah.
Many materials, just explore. Bricks are there. You can use terracotta, you can use meshes, you can use green curtains.
I have a question. Let's say there is a sea in the west and there is a residential building. Would you use glass or not?
So the temperature ratio will be very less on that side because there is moisture in the air. Because there is a sea.
No, but
moisture
the sun is going to anyway. The sun is you are in a tropical climate. Yeah. So I'll tell you what.
But you can provide a strategic view.
Glass has become popular because it has its own charm and demand of the views. I mean, I'm not saying that we should not use it. What we need to do is we need to evolve the technology to a level that the drawbacks are taken care of. There is always a way through evolution of technology, and things have changed over years. So I feel that.
So that is why I'm talking about context. So most of the majority, for example, if you are staying near the sea, the temperature is not that much. I'm talking about Ahmedabad. I'm talking about Rajasthan. I'm talking about Jaipur.
Ahmedabad, you are at the edge of the city facing west, and there is all greenery in front of you. There's a landscape of, let's say, in New York.
And again, we are talking about tall buildings. So when you're talking about tall building, ground level doesn't matter that much because after 2-3 story, common plot, open spaces doesn't matter to you. Then you have an infinity view. If you are staying near, close to the land, then it is different because you have inside-outside connectivity. You can open the glass shutters where, outer spaces can become your indoor spaces. That is how you can do conversation. But what about the 25th floor?
But
you can
get
have a
those
strategical
integrated
view
doors and everything. So I don't know. I feel that instead of not using, how to use it is a more important question. If there is a potential of doing something which is bettering my design, then I need to resolve that so that I resolve the drawbacks of that material through my designs and give the advantage of the material. I think so. That's the attitude of a designer instead of just using what is heritagely proven. We need to look into the future and try to provide more than what is available.
Yes, so we can design performance-based envelopes. Okay, so for example, if I'm facing southwest, a beautiful view is there. I want to see that, and I want to even at the same time I want to no, I don't have to see the sun. You can always install this aluminum shutters, lower shutter, where you can slide it and you can adjust it, where you can control the sunlight. There are technologies available. So not only glass, aluminum or sliding shutter can be used for sun screening also. Even for the tall buildings, we can see in many buildings. Even terracotta shutters we can use.
So ultimately, we can use glass with all these features. So ultimately, glass is not the issue. It's the design, how you handle the glass is the issue.
Okay, I'm glad you shook hands on that one. I was just feeling this is turning out to be like a primetime news debate where I have to ask like, okay, please conclude, please conclude. But great, I think sits very nicely. Obviously, context is important, performance is important, orientation is important, but also at the same time, when somebody lives high up in the air, he would want to just be in his bathroom and still enjoy a great view. I think that's also the aspirations people have when they move into high rises. Let's give the architects some rest. I'll come to you, Nivedita. When it comes to materials or cladding for high rises, what are the engineering challenges, logistical challenges that you typically face? I mean, Fundamax looks great in bungalows, but if it's like a 100-meter tall tower, how is that different for you?
It was really interesting, and as a material manufacturer, it gives us and all others who are here from the material side a lot of perspectives, as to how do we innovate, how do we, fill in the gaps, right? Having said that, ladies and gentlemen, it might sound very cliched, but as Mr. Patel and architect Suthar, both of them were saying, design is just not about, how it looks and how it feels, but it's very important how it works. Yeah. Now, having said that, Gautam, the challenges, I would say, of course, when it comes to high rises, and just to add a bit, Fundamax as such, we are a HPL manufacturer, and I'm sure that all of you know about it. We are just not into residential, but we have gone more than 20 floors up. So that's pretty much of a high rise, just to inform the audiences. Having said that, installation, of course, is one of the challenges which we face, because when it comes to high rises, wind, of course, is something wherein we would, we design our systems, we design our profiles and all of it, depending on what it is, the wind load, the high rises and all of it. So it's all custom made. And safety, as everyone sitting here would, we would not want one of my colleagues in the morning was saying about the Upahar tragedy, or for that matter, the Glenville tragedy, right? We would not want, because safety is paramount, whatever be it. So we also take into account that, it's designed in a manner that, the safety perspective, the installation perspective, and not to forget, last but not the least, is the maintenance part, So we take into account all of these, and we ensure that the material which we provide, suffices and makes up for all these challenges.
Wonderful.
Yes, please. So I have seen this, the trend with material providers. Yeah. They make more and more expensive material. Why can't you make something which solves everything with a cheaper cost? Because that is going to solve the problem of the society. People want solutions, and if it is not affordable, I am not able to use the solution. It's like an injection which can save my life, but I don't have the money to buy it.
Architect Patel, I would just say, I would say that, the definition of cheap, okay?
Cost effective, which is value. Like, for example,
absolutely.
if I'm doing 10,000 rupees square feet, what will be out of the 10,000 will be allocated to the facade? It will be 500 rupees, 200 rupees, 300 rupees. And what is it solving for me? I can solve a problem. There is a problem. But to solve that, it becomes a 40% of my cost. So can I afford that 40% of my actual selling cost? See, the reality is that people need to buy it.
Correct.
And I have seen other industries, which I really am worried. Look at the car industry. Maruti is giving you everything what Mercedes is giving. If they can make things cost effective, why can't we?
So that's a very valid point, quality doesn't come cheap. If I have to summarize thing, I would just, give me a moment for that. Quality doesn't come cheap, and people can disagree to this as well. But having said that, you made a comparison between a Maruti and a Mercedes or a BMW for that matter. Safety. I'm not saying that a Maruti, I have also grown when I was growing up. I have been in a Maruti car. So I won't say that, it's not safe, right? But the features which we talk about, we are talking long term. You just talked about, we mentioned sustainability. We mentioned a time period, right? So, do you buy a BMW and change it every 2 years? No, you don't. Right? Because you're thinking long term, you have a comfort, you know that you're safe, right? So all of it. I would say that, we have to attribute this, that, how a material and why is it expensive, if at all it is. Because there are certain attributes which that particular material, holds or has, right? Which definitely contributes in a great way into the sustainability of your...
If you look at the Maruti 10 years back and today, the safety standard of them also has increased.
Absolutely.
They also have airbags, so what I'm trying to, that progress I'm not seeing in my industry. I'm not seeing that progress. I'm not saying that I'm comparing the safety standard of Mercedes and the...
No, that was
but
just
this, the lower end is growing. It is growing. And the affordability and the features are also growing, which is not happening in our industry.
So I would beg to differ on that. I have many...
I think we'll let you guys take this onto a coffee right after this.
Right.
Please leave the questions to me.
Sure.
I think just to touch upon your car analogy, I think it becomes unfair when people are expecting a Mercedes at the cost of a Maruti. I think that's where the problem is. And I fully agree that, yes, the safety standards have improved or the material quality has improved, even the most basic level of material manufacturing. But I think it's when people expect that, wo mere ko ye bhav mein chahiye, I think that's where things start moving around a little.
My point to madam, just I was discussing about it. In the market, there are a lot of materials basically in terms of the cladding materials, in terms of facade. But basically what happens, if you see in our industries, basically, we don't develop any facade engineers basically. Basically, we all, end of the day, civil engineer end up doing the facades and all things. And end of the day, becomes responsible for delivering the projects. So materials comes in a very good manner. We spend also. But end of the day, what we have seen, the workmanship. The workmanship is basically the engineer needs to stand and get it done. Otherwise, if you see the material who is supplying also takes that responsibilities along with the consultant who designs on that particular, then the things will come out very well. And what the answer basically is he was talking about. Obviously, we will be happy with spending for the material. So that is only the one thing which I have been seeing it, the workmanship. Though material is good, but if the design details are not proper, and the people who, the workmanship who do, they do at their will and wish without the groove should be provided 10 mm, 12 mm. It should be the right person who is supplying the materials plus the designer who has designed it for the structure into that, which I see is missing in the industry because there is no particular facade engineer in the particular any company basically. He is with an experience, he becomes an engineer of facade. So that is missing.
So I'm stuck with the car analogy again. If you buy a good Mercedes and the driver is not good, wo jaake signal pe thok dega. So basically you need to have somebody in house to use that material, detail it properly and then install it properly.
Our responsibility is to build an ecosystem. We want the material, we want somebody who can design it with the material and somebody who can execute it.
Wonderfully
we need the whole ecosystem and we need to work on everything.
My point is, again, I'm talking about the Ahmedabad bylaws. Since we are working here, I don't understand this projection of 2 feet. Only 2 feet, why? It has to be proportion to the window openings. 2 feet, engineering doesn't work in 2 feet. You can't put your AC, you cannot put your plumbing lines properly. Nowadays, people are installing VRV system and all. I think 2 feet is not enough for the kind of sun glare which we are having here and the kind of sun angle which we are having here. I think at least it should be around 3 feet. Now RERA is there. Previously what was happening, people were misusing it. But nowadays RERA is there, right? So if you are providing little bit wider projection, it will of course help for this sun curtailing also. At the same time, people can grow a lot of vegetations, lot of green walls, agri-texture, I would say. You can do hydroponics to that. Many things can be creatively done. But projection, I think, I'm not convinced with this 2-feet projection in Ahmedabad.
That's such a lovely thought. I think word of the day should be agri-texture, something we can all carry back, where we start looking at buildings as mini farms, so to speak, where we have the space to cultivate.
I think so. He's saying that we need to get incentive for that, those kind of things. 2 feet is a free projection, free of FSI. I should be intensive, right, for the 3 feet or 4 feet. It should be, you know, an incentive from the government as a KP. If you give better projection, better greenery, it is free of FSI. I do agree to that.
ठीक है, incentive arrange करते हैं साहब आपके लिए. With that, I'll start. I just have one question, which is again, sorry. Okay, please.
Sir, I was just wanted to add into this industry was one thing that as we design, basically the architecture gives the designers and all thing, but the facade part comes in a very later stage, wherein everything has been compromised in the facade. In respect of design also, in respect of the cost also, wherein I feel architect should take a lead with a facade consultant to deliver the proper design and details. Then only I would we can see a good facade in the coming years. Otherwise, what will happen? Everything becomes on the side. People just to decrease the cost do whatever they want, and structure consultant, facade consultant keeps giving the detail, and we don't follow the things. So somewhere I feel on this platform, architects and facade consultants needs to come into the picture from the day one, so that whatever the budget part is there has been taken care from the day one only.
Agree. I'll represent the entire facade consultant fraternity here. I think we have an agreement that we should be on the project on day one. So that's great to hear. Coming back to projections, agri-texture, obviously we want these buildings to have a little life in them. Typically, when we talk about glazed curtain wall buildings, it's basically a glass box with an AC stuck somewhere, which is constantly cooling it, maintaining it at temperatures like this, where we literally have to wear a jacket over our clothing. And what can be done architecturally or, you know, from a development brief perspective to bring a little more life? Can we actually have windows that open, that allow ventilation? Can we create balconies? Which obviously becomes a challenge when you have these projections and you can't really continue a curtain wall. How are those problems addressed, you know, on the drawing board or probably from a developer's perspective?
So first, I would like to talk about the AC that you mentioned. The AC is a big issue. Architects only are not responsible for solving the AC problem. AC designs have not changed since ages. They are not trying to respond to the building. This is the requirement of the modern age, and we can give you AC, or the footprint of ACs can be changed in such a way, and the ventilation can be changed in such a way so that it can perform, and it only requires so much space. They have that typical box which you have the throw in one side and that side. Everything is same. So innovation also has to happen at those element levels, which then it gets fused to a building level. So there is one thing. Now coming to the second point which you mentioned about the opening. Yes, opening are very vital, and you cannot do without fresh air. You really need a fresh air. And there are windows which really work very nicely in high rises and everything, which take care of opening and fresh air ventilation. I think so. The projection is not a challenge when it comes to ventilation.
Of course, apart from this projection and architecture, there's elements, I would also focus on the material which you are using indoor. You can use, for example, lime. Why we should use cement plaster inside the house? Why can't we go for lime? Lime have a very fantastic characteristics, which absorbs the CO2 from the atmosphere and releases O2. So once the CO2 is absorbed, of course, the temperature will come down. Why can't we use that? Why people are not promoting lime?
There's some business ideas to take home today. Lime
I
plaster is one
experimented
of
with
them.
lime, and lime is a very difficult material to maintain. It is one of the most difficult, and
It is
at a large
live
scale,
material.
I can do a house with lime, but I cannot do a project with lime because the availability, the workmanship, there is no ecosystem which works on that scale. See, first of all, when we are doing large scale projects, it is very important that I have everybody in line at that quantum. Even my suppliers has to provide me those material at that quantum, at that speed, at that rate, which is a challenge at times. Lot of times we go out of the box, and then the supply is so slow that my whole projects get stalled. So lime.
So after this kind of panel
But
discussion,
colors now these days colors are taking care of those chemical
so
things.
after this kind of panel discussion in some other city, some manufacturer came to me and he made lime color for me, which is called Vedic paint. I think you guys can look after it. So we are using Vedic paint in couple of our projects, which is easily available in drums like Asian Paint gives. And it is easily applicable, pure made out of lime. So if we initiative, we throw challenge to the manufacturer, we want this, they will manufacture for you. They should have, no, उनके पास market होना चाहिए. Then they are ready to do experiment.
And the market's being created, but sorry, that business idea is taken. Someone's already doing lime paints. So yeah, that goes out. I think second last question for the evening, I'm just really seeing the clock tick over my shoulder, is for you, Nivedita. Apart from your conversation, which you're going to have with Jagrubai about how to make it into a Maruti and not a Mercedes, what are the latest technological innovations which help designers, developers, people like us to make better lasting, robust, stable cladding materials?
So as you said, Gautam, I was glad and I was very happy somewhere inside that, architect Suthar and Patel, the architect Patel, both of them having this discussion. So taking all cues from all that discussion, we are very, very happy and glad to inform, them, in particular the design fraternity, which is out here, that at Fundamax, we have kept into consideration all of this, and we have a material which is called M-Look, which is reinforced glass fiber, which with a non-combustible core. So the fire part, it's A2, so that's taken care of. The color fastness, high rises whatsoever, and safety perspective is also taken care. So this is one of the technological innovation from the house of Fundamax, which is like really taken in a very, very big way worldwide. So yeah, I mean, we hear you out, and we do take steps to innovate. And as Architect Sutha said, if there is a market and if there is a requirement, we are there to serve you, sir. And I'm sure that everybody out here would agree to it. And just to end it up, Gautam, I would say, that as they also mentioned that let's design for the present, being fully aware of the past for a future which is very unpredictable. Yeah.
So it's like the chicken and the egg. The material will come first or the use will come first? Okay.
Okay, after M-Look, I think you need to come up with M-Cheap, and then Jagrut Bhai starts calling you with his client list. I think we're now end of the questions, and I would like to circle back to the three words that all of us gave, starting with you. Loads, installations, safety. I think we did cover a lot of that. Is there anything else you would want to add and how that gets addressed?
As we all, as he mentioned, the stakeholders, all of us are here in this particular hall, right? Not only this, we can talk about material, the nuances and all of it, but where does the adherence go? So the NBC, the building code, the National Building Code, the ASTM or the EN or the BS, whatsoever you call. So it's very important and crucial. And, Architect Hariyani was also mentioning, that conscientiousness has to come within the fraternity. Like, that what we are designing, it's for the future and it's sustainable enough. So that adherence, and somewhere somebody needs to tighten those screws that we adhere to those standards, right? So it shouldn't be a gross negligence is what I would say. So, all these have to be.
I think so. We need people, workmen, because design, we have enough architects in the city, but we don't have equal workmen who can really execute to the vision of those architects. So I think so. Companies and we all need to come together and educate or have some kind of a formal learning for those people so that they can also really perform better, so that our visions are also realized better.
overall and finally with final designs and everything, I would go with a good ventilated and energy efficient.
Design consciously.
Anybody has any questions?
Yeah, good evening. I am Fanil Javeri from Shilp Vastu. From morning I am here. I have not seen a single structural consultant who is doing actually the facade designing on the dais. Why so? Only simple question.
Can you answer this one? Why we don't have a structural engineer?
Because they are not interested in facades.
I will just answer this question basically. Basically, there is a structural designing happening basically, but what happens once the architect and facade consultant designs the concept, so thereafter everybody has their own systems. So when they are developing their own systems, so they need to get it done through their structural design, which has been vetted by the facade consultant, structure consultant. So they have a facade consultant keeps their structure person along with them. So basically in Ahmedabad, we don't follow too much and take an approval on the structure part. But I have been working with Delhi and Bombay. We are on their blood basically to get the approval done and get all the details. We don't know. We don't start the erection till they sign on the shop drawings basically.
We'll take one more question.
Hi, my name is
And one
Bharat.
more, okay.
So my question is a little two-pronged. It's for both the architects. So there are some challenges both with you have an affinity for glass eggs, I could see, and you for natural materials. So
I know this will be a very long answer, please.
So in terms of people, when you talk about cost of the product that is being applied on the facade, when you take a natural product, it may be cheaper than engineered product, but then the load that it is taking on the building, the reinforcement that you have to do on the building to take that on maybe a 40-floor building will be much more than the cost of the entire facade. So when you're taking the cost of the external facade material itself, suppose if I have to put something like a terracotta or something like natural stone, which is around 20 to 30 30 centimeter thick, it is going to be 30 to 40 kilos per square foot, whereas the newer materials that are coming in, they are at 750 grams, 500 grams per square foot. So the cost of the reinforcing the building to carry that load is much higher. That's one thing. When we're talking about glass, then the cooling cost, which is already discussed, suppose obviously the view part is essential, but then it can be interspersed between alternate floors or whatever depending on the design. So how do you tackle this, and are you all open to looking at newer materials like even newer variants of HPL, ACP, porcelain and all that, which have all the properties of your natural stones? They are 100% natural, and they also give you ventilated facades. You can create different things with all the partners at the Shuko, name it. They are all ready to give you solutions. But the what I've seen in Ahmedabad particularly is there's an apprehension to look at newer materials. Everybody, it's all templatized versions of what is happening. Every fourth building looks the same.
I'm still trying to look for the question. Where is it?
The question is, are architects willing to upgrade themselves to look at solutions which are neither old or extremely new and take a middle path to achieve what the design problem was?
So there are concrete panels which you can design, lightweight concrete panels, and of course, as she mentioned about GRs and another material, which are, I think it is a good material to use in facade, which is lightweighted. Again, thermal conductivity is not there, unlike metal, because metal also gets heat and it releases heat after the sunset. So I think GRC and this kind of material is good to use.
So, as I get your question, first you are saying that first thing that you proposed was the natural material is more expensive than the artificial material. I mean, the artificial material is more expensive than the nature material. That is what you're trying to say. that was one thing which in the source. So I would say that it should be reverse. A natural material should be expensive than an artificial material. That's what engineering should do. I should be able to create more cost-effective alternatives without harming the nature. Without mining, I am able to give you something which is at a lower cost. If I give it at lower cost, people are discouraged of using the natural material. Secondly, if you are not harming the environment, what is the difference between a natural material and an artificial material? Means 90% of the universe that we are living is created by us. So everything is artificial around us.
So my
So
question
we
is,
are not against using artificial material. So that is there, and yes, we are open to that of using natural material. I think so. People are not using. People have already moved to the artificial material. 90% of people are using artificial. Even the tiles also have become the bathrooms. You are not using. You are using the ceramic tiles. So I think so. Our built space has become 90 to 70%, which is artificial. Even wood is getting replaced.
I was about to say you can take this conversation over drinks, but then realized we're in Gujarat. So can we have the next question with that?
This question is for both the architects. First of all, a lot of respect both of you, because I have seen closely your buildings, and even Snehal sir's building, I'm already living into it. There is a Posh building, green building, IGBC green rated building. I'm a resident over there. So I've seen your approach towards the design. And my question to you is, right now I'm practicing industrial architecture. I've been an MSU student, so I can relate to what you are talking about, context and all those things. But I end up in designing glass buildings. My problem is, there is a lot of huge scale of buildings come into picture. The people like JSW and Ford and all those things, they are into square meters. So they want to see a lot of glass facades and all those things. So glass is always, I prefer to use GRC, but that is again a costlier material. Even I visited the concrete shop, which was designed in a terracotta shape and all those things. I try to explore, but I end up in using low grade materials.
So I think glass is not a wrong material to use. You have to cover it. We should be concerned about the sun, the context where we are designing. I think that is what I mean to say. Glass, nothing wrong.
I understood your point. But again, for industrial building, like having a 150 meter long facade, I need to put some MS structure or some kind of brick structure or some kind of RCC frame is required on the backdrop. So that is again adding to my cost. So ultimately I need to opt for the sheeting options or maybe some other options. So I would like to respond from your perspective, what can be that material?
Yeah. So you are saying that you are designing an industrial shade or something with a glass in facade. Is there something to be displayed behind it, or is there a view which we have to see?
Definitely, sir. Definitely. There are few clients who have separate corporate offices, but those have their own building, like R&D center, and all those buildings are within the part of their industrial factory outlet.
So I can give an example which I was asked to design a building in an industrial thing. So I said there is nothing to look outside. So I made a concrete wall around, I made a courtyard inside, and I made everything looking inside. I had the glass inside. So you need to tell your client, you need to sell your designs in a way which you want. You need to learn the skill of convincing the client the purpose of your design and what you are proposing. And if you see sense in that, he's going to buy it.
Gautam, can I add one point?
I thought that was going to take a while. So.
Gautam, can I add one point? So,
yeah, please.
So, Jagrut bhai, this is nothing to do with this subject of discussion, but I think the way we are practicing nowadays, clients want to see their building before it gets executed. So this rendering guy, they are the culprit, I would say, because if I show them a good sustainable building with using this kind of facades and all, they are not interested because they have not experienced that before. But they have exposure to the Western part of the world, all the glass buildings. So our 3D renderer show them the glass building on the screen, they will be fascinated. Oh wow, this is what we want. And architects, they don't want to take risk. यार project चला जाएगा, ठीक है यार उसको जो चाहिए वो दे दो. I think that is, I think ये भी एक point है छोटा सा.
So उसका आंसर है मेरे
Rendering वाला
पास.
किधर है भाई?
All the companies should give award to architects who are doing such kind of buildings, so that the society starts accepting those kind of buildings, and instead of giving awards to architects who are doing those glass buildings.
I think we'll take the last question now.
I'm sorry to take up. I work in a primarily industrial environment. I'm Neeraj Bhatt, working for Mott MacDonald. So far, whatever presentation we have seen have been for performance glasses for more of commercial, and in industrial, the challenge, I'm not going to ask you questions. I'm just going to tell you about the kind of performance glasses that I have been subject to. I have been
Subject to is a very interesting choice of word.
These are 25 mm thick blast resistant glass inside a production shed, because the control room has to see the entire line. So there the challenge comes where I have had to convince the client that, look, I cannot allow you to use a 5 mm to 6 mm glass. If that glass shatters, it's going to injure your workers. So they had to import a special 25 mm thick 3x3 module right from Germany just to. Second was working for a shell project where we had to use 10 mm blast resistant glass in order to prevent any explosion happening inside the laboratory, going outside and hitting someone. Third was in an acidic environment, how would the glass function? And I have come to know that they have told me that glass tends to stain. So to every manufacturer who comes to me with a glass, I have to ask them what is the chemical reaction of your glass. And at times, as he said, kharcha, nahi hona. So say, ठीक है sir, ठीक है, आप एक काम करो. I had to propose a 3 mm plexiglass in front of the plain glass, just to prevent that. That is all I have to say. But as I said, I have been asking the other vendors all to provide me specifications where I have chemical reactions and whatnot. That's all. Thank you.
Wonderful. I think 3 key takeaways. Design should be contextual. Rendering वाले को control में रखना चाहिए. And then thirdly, you should have control over your costs. And with that, I would like to thank the panelists, and over back to you guys.
Thank you so much, everyone. It was really informative. And at the start of the panel discussion, the whole discussion went on kabutars. So I really thought of a song that was just coming in my head. The song is Kabutar Ja Ja Ja. I think that should be a national song for India. So I would like her to take over.
Putra and Kagada, a Tronas dekhai.
So I would like to ask her to take the mic.
Yes. So thank you all for attending today's event. I hope you found it informative. As I mentioned in the morning, we're recording this event. We'll share the YouTube link along with you guys a week from now. And then until we return to Ahmedabad next time around, so hope to see you all soon. Hope to see more fancy facades with both natural materials and artificial materials in Ahmedabad. Just I'd like to add, absolutely functional. I'd just like to add to what architect Jagrut Bhai said. The West is moving towards natural materials. Factory controlled products are no more the fashion, you know. Stone is made a big comeback in cities like London, New York, Paris. You know, the amount of engineering which is now happening. A lot of facade consultants I know personally are hiring geologists to their team, because people now, I mentioned about carbon early in the morning. So they are talking about embodied carbon, and over there, stone, timber. So we do an event on timber envelopes also in the Western world. And then these materials are making a comeback. I think not yet in the Asian community, but natural materials are making a comeback, and stone and timber, which we disregarded, you know, have now come back in fashion, at least in the Western world. It's a matter of time we'll see them back in India. Something like bell bottoms, I think they were out of fashion, but they're coming back now into fashion. So we hope that all kinds of materials exist, as long as the building is more sustainable, can emit low carbon. I think we have our hands full to to design more sustainable and low carbon buildings. So thank you all. We'll do a quick photo ceremony with the panelists, and we'll have the mementos given to them, and then we'll all join you outside. Can I request the speakers of this session to come on stage? I think we just had one, and the panelists, we'll have a small photo opportunity with them, please. Thank you. Thank you all. Thanks for attending today's event.